Thank you, sir. And as it is, our PIRC and PR experts are ready. The rehabilitation of 4.1 kilometer long of Nelamangala flyover by replacement of external pre-stressing cables. The presentation will be done by Professor Mahesh Tandon of India. I would request Professor Mahesh Tandon to kindly come over. Hearty welcome to you, sir. Please come, sir. Rehabilitation and retrofitting of concrete bridges, case studies by Shri Anil Kumar Srivastava from India. Shri Anil Kumarji, hiya, sir, please come. And with regard to the PR experts, we have the presentation on new rehabilitation materials and technologies for road bridges, a report last cycle by Mr. Pierre Gilles from Belgium. Welcome, sir. And we also have one expert joining us online. The subject is reinforcing of pavement around deck joints innovation, Hungarian experience by Mr. János Karkus from Hungary. He is going to join us online in a short while from now. He's already there online and will be seen in a little while from now. So I would request the Honorable Chair, Shri Charan sir, to kindly take us, Sharan sir, to kindly take us through this session. Over to you, sir.
Good morning to all of you. This is a very important session, and that is on the advance in maintenance, rehabilitation, and retrofitting of bridges. So, as you know, India is going for a major infrastructure development, and when we are designing a bridge with the IRC code, generally the life of bridge is 100 years. But yesterday I could come to know that majority of bridges have average life of 30 to 40 years. So that is really a matter of concern to us. So whatever document in IRC in India we are having, it is for, earlier till today it was for normal bridges. But so many large span bridges are coming these days, like cable stage, extra dose bridges, and even large span arch bridges. We find a different cup of tea, and their construction are required to be much more different from what was normal bridges. So large span bridges of more than 200 meters in the case of extra dose bridge, and we are going for in the case of suspension bridges and cable stay bridges nearly up to 500 meters. But now we will be also looking for more than 500 meters, maybe 700 meters, which may be coming very shortly in the country. So what I feel that when we are looking for the inspection, maintenance and rehabilitation and BMS, we have to look into different angle, and with so many new material, new technology coming, so that when we are designing a bridge for nearly 100 years design life, at least it must sustain for that period in the servicity and the safety consideration. The user should not lose the confidence in using your bridges from safety consideration. That is one issue very important. So we have to make number of intervention during the lifespan of bridges, and regular maintenance is required. So on this concept, we find that when we are talking long span bridges, so maybe tsunami effect in the ceiling, and maybe a seismic, then wind, then wavelength, so many other consideration comes when the matter for large span bridges are coming. And normally the India, mighty rivers are there, Ganga, Brahmaputra. So bank to bank, the length of bridge is more than 10 to 15 kilometers. So these are the considerations. So with these opening remarks, I will like to introduce the presenter. The first is in this topic is by IRC expert from India, rehabilitation 4.1 kilometer long Nelamangala bridge flyover by replacement external pre-stressing cable by Professor Mahesh Tandon. So I will just make brief introduction, although everybody in the country knows Mahesh Tandon very well. But for the benefit of all those who are present here, I will just make a very short introduction of Mr. Mahesh Tandon. So he's a very active member and he was responsible in developing the cable stayed bridges, the code IRC SP 136 recently and which will be available shortly for sale uh, in the country. So he is the chief architect there. So I will just introduce you him, who is sitting right to me. Professor Mahan Tandon, Chairman, Tandon Consultancy Private Limited, an international expert in the field of structural engineering. He has accreditations of International PE India and is fellow of Indian National Academy of Engineering. He is the recipient of Distinguished Alumni Award of IIT Roorkee, Lifetime Achievement Award of IRC 2020 and is currently Chairman Research Council CSIR CRRI India for the period 2023 to 2026. So he is a convener of IRC, very important committee. That is convener of concrete bridge B3 committee, B4 committee, and he will be presenting the topic in a very short possible time of 15 minutes, although it's for 4.1 kilometer long Nilmangala Express. So now, Mr. Tandon, the floor is yours, and I think 15 minutes is for you. So please see that you can do justice to your paper. Thank you.
Thank you. So, good morning, everybody. I hope that you had a good, heavy breakfast and you are now going to walk through 4 kilometers of a flyover which was in distress, which we are trying to put right at the moment. This is the starting point of the flyover. It's the ramp that leads to the main spans. So, the commercial operation date was somewhere in December 2010. Cost was 444 crores. And after about 10 years of service, it started showing some distress signs. So there were 10 numbers of external pre-stressing cables which snapped, and that is where some alarm bells started ringing. But while the bells were still ringing, 2 more cables snapped. And so NHAI formed a committee of 5 people, and there were representations from the practice, from research, from academia, and of course there was the owner's representative, Mr. Srivastav, who's sitting right there, to oversee what the committee is doing and to make sure they are on the right track. Now the entry into the box girder is through this inspection hole in the soffit slab, which is totally inadequate. And I think one of the first comments that the committee had was that it was not properly designed. The access to all parts of the bridge should be possible. Here, if you are a circus artist, like the 2 gentlemen who are standing there, one of them being me, then it's okay. But otherwise, it's not easy to go inside and inspect. Originally, we had decided that we will take this entire 200, 300 people, whoever are the delegates, to the site, but then we changed our mind because I think the chances or risks of access itself is so prominent. These are the flyover during construction, and just to repeat, this is a precast segmental dry jointed externally pre-stressed superstructure. The cross section looks something like that. This is the very funny shaped diaphragm that you see. So you shouldn't get worried about that. It is all the cables are outside. Is there a pointer in this? No. Hello. इधर कोई pointer है?
This is the point.
This one?
Yeah.
Thank you. So where do I point? Okay. If you can see those green light, that is the pointer, and I am trying to point out that the cables are located outside the web. So this is an externally pre-stressed structure, except for a few cables here in the top slab, which are internal bonded cables. The rest of it is all external. The elevation of the bridge, you can see the cables, 3 slanting cables that you see here and 3 there. These are the cables which gave the maximum amount of problems. So externally pre-stressed cables, when we have, and this is from the FHWA, you have something called a diabolo, because these cables have to be, as you noticed, if you have to change direction of the cables at some point, you have to have these deviator blocks. And these deviator blocks, through which the cables must also pass and then change direction to whichever one you want. So one of the main features of this diabolo is that no part of the cable really touches any contact surface except right in the middle. But you cannot have the cable touching the rim of this of the diabolo, and that is why it has got a sort of a bell mouth, if you can see. Just to say it again, there are this 4 kilometer long bridge has 120 meter span. The spans are normally about 34 or 35 meters, and of course there are different span lengths required because this bridge is also curved at places. The rest, if people are interested, the spans rest on spherical bearings, which are placed on pedestals over the reinforced concrete piers. So we are using 19T15 and 12T15. These are the cables which were used for the external pre-stressing. Now, the first thing that we noticed that whether the protection level that was given to the cables was enough or adequate or not. And this is from the FIB, which tells you where you should have PL1, PL2, PL3, depending on the aggressivity of exposure and the protection layers that you require. When you say PL1, it is the normal cable that we are generally used to, which means you have a bare strand going into a duct, normally HDPE now, and finally grouted. You can do a cement grout or any other type of protection grouting. So that is PL1. But if you require more protection, then you have PL2 and PL3. PL2 is something which is more protection than what is given by our normal cables. What has been done in this particular bridge is that just the way you make an internally bonded cable, the same protection or the same type of construction has been done for the outside one when we put it as an external cable. This is, to my mind, not correct, because it is definitely has more exposure as compared to a internally bonded cable. So PL2 is what one can say should have been used. So distress, like I said, after 10 years, and while we were still discussing as to, how to go about it, 2 more cables had snapped. 10 were already snapped, 2 more while we were discussing how to go about it. So 12 cables were snapped in a matter of, I think, a few months. By the time we thought out what is to be done, 2 more had snapped. This is another problem with the design, that the design of the diabolo, like I explained in that photograph taken from FSWA, the cable is not supposed to touch the rim of at the exit. It has to be free of that, and this is something that was not so pleasing. And you can see the small picture on the right hand side. That is how it's supposed to be. And already, even before looking at it, the cable had damaged the concrete around it, and you can see that it has been repaired. So after opening up a few cables, we found that it was heavily corroded and there was problem of grouting. If you see the one which is left hand side top photograph, we could see that the corrosion had reduced the diameter of each wire in this case. Also, there were problems of the anchorages, which you can see on the lower part of this slide. So there were problems of proper protection against corrosion. There are several levels of protection that you can provide, and the current understanding is that you should have several levels of protection depending on what is required, what is the aggressivity of the atmosphere, and so on and so forth. So you can even on the level 1 means even the uh, exterior surface can be painted. That is one level of protection. So this way you can come down to, 5, 6 levels of protection as you can see in this. But how many levels to provide, it's up to the engineer who's in charge of the project. He should decide how many levels you require. But certainly you cannot provide in an external cable the same level of protection that you normally do for an internal bonded cable, which is very well protected. It has got a concrete, it's inside the concrete, and that is the primary level of protection is really that, the first level of protection. And if you don't have that protection in an external cable, then you have to make up this somewhere or the other. So what are the types of strands that are available? You have, starting from the left, a bare strand, then you can have a PE coated strand, and that blue colored sheathing that you see. You can also have galvanized LRPC strand. LRPC means low relaxation pre-stressed concrete strands, and we have a separate code for that. In the fourth one that you see is a very highly protected, which means that it is PE coated as well as it is galvanized. So as you go from left to right, you will have more and more levels of protection. Now which one to use, that is where the engineer's knowledge and experience counts. In this case, it was just a bare strand which was put in a HDPE duct and cement grouted, which is not adequate. And that is the one which caused the corrosion. This is what we actually provided. We got galvanized strands. We got the grease or wax in the interspaces that you have in between the 7-wire strand. And you also had the high density polyethylene as the outer cover. So this is the maximum means that we normally do this for a cable stayed bridge. Whether this was required or not, but this is what we provided. But in doing so, the diameter increases of the strand. So you can no longer put the same number of strands as you would if it was a bare strand. So there also you have to make some arrangements. I think I'll just move this. Okay, so the first thing that we decided, that if you have to design for 100 years, and really the understanding that we got from the authorities is that this is a high value project, and it will be a pity that even after 20 years if it becomes unusable. So you can do whatever you like. But in our discussions we decided that if we spend about 10% of the original cost, so long as we are lower than that, we should provide the maximum protection that we can. And so that is what the objective was right from the beginning. So we provided PE coated, wax filled, galvanized strands. And the question was whether as the cables break, are we going to wait for them to break and then provide this, replace them, or are we going to replace them anyway? So if you have a design life of 100 years, to cater for, and you are already in difficulty as far as corrosion protection is concerned, then you cannot wait for the cables to snap and then go there and change and all that. So we found out the cost of doing all this, and it was well within 10%, much below that. So we decided that we will replace all the cables, because you saw the condition of the grouting, you saw the use. It is PL1 what they have provided, what you do for the internal grouted cables, which is not adequate. So in doing all this, what we did was to suggest to the clients that this is the direction in which you should go if you are interested in a 100-year design life. Only 10 years have passed and this is giving you these kind of problems. So I think I'll skip this. So what were the identification of causes of distress of external tendons? I am skipping a few things because 15 minutes is the order given by the chairman, and I would not like to be on his wrong side. So first is that we found that some of the cables were physical damage. Even though it had an HDPE pipe as the sheathing, but some of them were damaged. Use of dry jointed segmental construction was the other mistake that was made. If you want to have external pre-stressing, you should not have dry jointed construction. Corrosion of tendons, insufficient protection of corrosion, bad quality of grouting, bad design of diabolo, and this is not the first bridge of this type which is showing distress. We have some external cables in another major bridge near Calcutta, which is called the Vivekanand Bridge, and the external cables there also had a problem. The same type of thing, that it was PL1, whereas we should have provided something like PL2 and selected. It is not necessary to put all the layers which I have explained, but certainly it cannot be PL1. And the client expectation, like I said, high value asset, life should be 100 years. He said, I mean, their view is that we gave this project on the condition that it will last its design life, which is 100 years, and you must make sure that it lasts. Otherwise, there is no use appointing a technical committee and of experts and all that who can't assure that. So that is the direction which we had to go. Okay. So 15 minutes seem to be coming to a close. So thank you very much for your kind attention.
Thank you, Mr. Tandem, for just sticking to the time schedule of 15 minutes. You can come here, please. And I will expect a lot of questions. Kindly make it ready, and we will take it once all the presentations are made. So you can be here, Tandem sir. Please. We will now go for the next presentation. Although this presentation was so crisp and brisk, done in a very short period of 15 minutes, but many more things will be, I think, definitely offering all the participants sitting here. So they can keep their question reserve or end of this all presentation. So next presentation is by Mr. A.K. Srivastava, former ADG in the Ministry of Road Transport and Highway. He is going to talk on rehabilitation and retrofitting of concrete bridges. It's a case study. So I will give a brief introduction of Mr. A.K. Srivastava. Mr. A.K. Srivastava who graduated in civil engineering from IIT Roorkee, did then the University of Roorkee in 1981, joined Ministry of Road Transport and Highway, and served in various capacity and rose to the level of Assistant Director General in the Ministry of Road Transport and Highway. Also served United Nations ILO during 1993 to 1995, ex-ambassador of International Road Federation in Indian chapter, faculty member of Indian Academy of Highway Engineers, member of Tunnel Experts Committee of Ministry of Road Transport and Highway, affiliated with IRC as convener of Hill Roads and Road Tunnel Committee S10, member of Ministry of Road Transport and Highway specification for road and bridges work committed during his tenure. So, with this, I request Mr. A.K. Srivastava, floor is yours. Kindly take 15 minutes time.
इससे क्या होगा आगे और लाइट इससे जाएगा ना वहाँ जाएगा ना Thank you, Chairman and Co-Chairman, for giving me opportunity to share my views on this issue before August gradient. And also good morning to all of you. And before taking up my this topic, I would like to share one or two points what Professor Tandon shared right now, because I am also associated with the committee, and I'll just share 2 points. That when we entered into the deck once, all the committee members, it was perhaps full of debris, and it was very difficult to move inside the deck to inspect the snapped cables and all. Therefore, committee directed that first take this responsibility to clean the deck clearly. And perhaps that was also the reason, one of the reasons may be contributory for this corrosion effect and all. We should keep in mind that whenever we are making such a long bridge, important bridge of 120 segments and all, then this issue should be addressed. And how previous construction agency left this debris inside the deck. Secondly, that due to the failure of drainage spouts, due to the heavy rain, in one of the decks, we found that about 40 mm depth of water was stagnant in the deck. This was a really very surprising that how it has happened and how it is going to affect the superstructure quality and all, reinforcement and cables and all that. Therefore, just I shared my views on this issue, and there were a lot of points also, because due to shortage of time, Professor Tandon could not share. But anyway, therefore, on one hand, we are thinking about the construction of long span bridge. We are thinking of extra dose bridge, cable stayed bridge, this ultra performs, this high capacity concrete and all that. And side by side, we are not moving at the same wavelength for the design, investigation, and quality control aspect, and lastly, maintenance. In fact, in order to ensure this sustainability of any structures, a proper wavelength should be maintained in all segments of activities required for the bridge. One of such issues has happened in my case, which I will share with you, that due to some problems, this whole foundation settled down. Okay, now, in fact, my presentation is mainly due to shortage of time. I have decided into 3 segments. First, this is just a brief introduction about the this bridge under construction. It was a 7 spans bridge and provided with 4 longitudinal PSC precast girders on spherical bearings and cantilever pier over concrete deck with 13.5 meter with footpath on one side. Because one side I'll show just now why on one side. Circular pier shaft 2.2 meter and board cast in situ pile foundation of 1.5 meter diameter and under abutment it was 6 numbers. Now this bridge is just shown below and existing bridge has been shown above, and in order to make the hydraulics flow uniformity to make uniform that when this span is in the line with the existing bridge. Therefore, in existing bridge there are 2 footpaths on either side, but in new bridge only one side has been given because this has been made 2-lane additional bridge. New. This is the layout plan which gives about the bore lock position which were taken for the construction of new bridge. And this is just simply showing the pile foundation and elevation of the new bridge having 7 spans. And this is the elevation of new bridge with respect to the existing structures, which was 2-lane on left side existing and 2-lane on right side, and clear gap was only 3 meter. And this is just giving the span designation and span length, about 36.5, that 36.4 meter of central spans of 4 spans, and number of pile foundation configuration is given, pile length also given, and this is the pier shaft height. Also, it has been given for each span. Now, this is the second part. That is the first, just a introduction about the existing and new. This is the position that this pier foundation 3, see, this is the settled down, this. And this was just under construction because there is no railing and has been made and no bearing course, no other superimposed load was placed there. Therefore, pier settlement took place about 650 mm, and suddenly it took place. Suddenly it went down under pier foundation P3, and it was a incidence on 23rd June to 23. The superstructure was erected in May 23 only after 1 month, and not open to traffic aid. Bearing course, expansion joints, and crash barriers railings were not yet laid over the bridge. Pier foundation P3 supporting the spans number P2, P3, P3, P4 of 36.4 meter each. Now, what immediate action it was taken to examine this issue, to conduct confirmatory geotechnical investigations of P3, upstream and downstream both, because there was a doubt that why it has happened due to this region only or some other regions were also there. To record of level of pile or 4 corners of foundation P3 to check any further settlement of the foundation after incidents or is it stopped. To record the foundations near P2 and P3 as there was a sudden increase in flow of water due to discharge of some dam from the Nepal side, because this bridge is located between near the border of Nepal and India. And due to some channelization of flow, the main flow was diverted towards P1, P2, P3. Now this is the river flow has been diverted. Flow is making some covariant flow. Therefore, it was between P1 and P2 and P3. Now, after settlement, both the spans had gone down. Therefore, immediately the measure was taken because span was intact. There was no problem in span, only foundation has gone down. Therefore, both the spans P2, P3 and P3, P4 were lifted to maintain the level, so that there should not be any further damage to the superstructures. Then this shows the lifting of spans using jacks, and also after lifting of a proper level, some placing of the wooden planks to support the superstructure. Now this is the condition which is shown after the settlement and after the lifting also. Difference in level, because one by one it is being lifted. Therefore, it is clearly show that how this level difference is there. See the right photograph, that this is the difference in the due to the settlement, because the faraway span has already been lifted, and second the front span is to be lifted. Therefore, this is showing the gap. This is the condition of the spherical bearing which damaged after the settlement of this pier foundation P3 and after the lifting of the girder. Now, probable, what was the reasons that it was tried to understand that why it happened. Therefore, after a lot of this scrutiny and available informations, record of testing, etc., then these were the regions where assessed that this may be one of the regions or combination of the regions there. Possibility of deficiency and investigation. Definitely deviation from the real-time condition of the soil strata. Possibility of existence of soft strata under tip of the group of piles. Possibility of non-uniformity in pile concreting. Pile length and non-homogeneous condition of concrete in pile. Non-mobilization of end bearings. Encountering of soft formation of soft toe due to insufficient washing and flushing of the pile boreholes. Any loose strata in both below P3 location using sudden settlement of piles, presence of natural cavity, which is very much possible below the pile foundation, possibility of natural cavity under the group of pile. The behavior of soils is regarded as a complicated material, and unlike most of the other structural materials, to use the structures built on the soil safety. And the presence of cavities in the most well-known problem in soils. The soils containing the cavities are named as problematic soils, as presence of cavities can cause the structural deterioration. Now, after the settlement, these fresh boreholes were taken on both upstream and downstream of the foundation P3 to check the condition of the soil, and based on the information, these were the outcome which was received and which was again redesigned and compared with the previous one also. Therefore, this has given the liquefaction depth. It was carefully examined because it is under the seismic zone 4, and C value, phi value, scouring depth also. Scouring depth was very important because some thought was going on that scour may be the region, but scour depth 7.5 meter was only after calculation. It is below the it is below the pile cap bottom, this depth, not from the total maximum scour depth, which is measured from the HFL. It is not that, but after calculation, it is 7.5. Similarly, pile length 32 meter, vertical capacity greater than 750 ton per meter square. Previously, it was taken 28, and this time it was assumed as 32. This is the upstream and downstream bore lock charts, which is showing the soil profile, and this is the figure obtained from the borehole data and design of the pile foundation. Then previously what was there about BH3, as for old geotechnical, it was only one, this borehole was taken. Earlier it was shown, and therefore downstream it was not taken. Therefore it is not shown. And now after settlement, in both upstream and downstream were taken, and therefore averaging has been done, and accordingly this is the outcome that pile foundation design or 70% pile capacity as determined based on the results of confirmatory and new geotechnical investigation test report. And earlier it was taken 28, but now the fresh which we will take the see the rehabilitation and retrofitting, that 32 meter has been taken. Now monitoring of the level P3 after settlement. It was also done that whether it is going further down or it has stopped. Once it was certain that it is stopped, therefore some retrofitting and rehabilitation measures was possible. And if it is still going down, then you will have to think about alternative solutions and all that. Therefore, this was the settlement of settlement record, and it was found stable just after 6 or 8 hours. There was no further settlement. And now soundings was also taken. Soundings were well within the limit, which was calculated based on the HFL, maximum discharge and silt factor and HFL. Therefore, this was not the issue. Similarly, P3 was also taken, and P3 to compare. Now quickly 2 minutes I will take to this rehabilitation and retrofitting measure. This is the main important part, that this is the location which has been examined considering the existing well foundation location, that whether this rehabilitation retrofitting measure is going to affect the existing structures or not. Therefore, this was a certain to take the diameter of the well and taking the influence zone of 2 die, and it was decided that new retrofitting measures pile foundation should be where it should be taken, because after superstructure it was very difficult to take the responsibility of rehabilitation and retrofitting measure. Therefore, just you see that we have taken the new pile just outside the influence zone of the existing well foundation. Now, this is the arrangement, plan location of pile foundations. There are 2 numbers which is beyond the superstructure. Therefore, it was taken 1500 millimeter die of 2 number of piles, new pile cap, 2.25 meter by 6.3 meter by 2.25 depth, and a new pier was taken. It was shown as a red color, which was taken as this one is a new one, and this is the new one, and this is the new two pile foundations, and a new pedestal with the bearing locations. All bearing locations were shown as a red, a small this force this side and force top side, and one is a blue color T shape. T shape is a seismic restrainer, sir. Restrainer. Seismic restrainer was placed like this. Now, this is the plan at pier location P3, elevation of existing pier shaft with pier cap, plan of new pier cap. Then here it is seen that how this old, sorry, this has gone down. This is the pier which has been dismantled, this dotted. It was old pier, it was dismantled. And this is the arrangement, trestle arrangement to lift the superstructure while dismantling the main existing pier as well as a pier cap. And this is another view of the trestle, which was every member, it was designed to lift the 770-ton load of the superstructure temporarily, how it is bolting has been done and all. And this is another side view of the trestle arrangement, lifting of the superstructure and bolting arrangement also, that there should be no any untoward incidents. This is the section of the these main beams and tie beams, inclined trestle members to support the superstructures while dismantling process is on. Now, this is the view of the pile foundation P3 after the completion of new arrangement. See, this P2 is backside and P3 new. P3 has been totally dismantled, only pier cap is visible. This is another view. This is a P4 before P3. P3 is on the backside. And this is the lesson learning, sir, a detailed subsoil investigation and complete hydrological studies are vital for design and construction of sustainable bridge foundation. With this submission, thank you very much. This is from all my friends. All is from my side. Thank you very much.
Thank you, Mr. Srivastava, for your excellent and very brief and lucid presentations. Kindly keep your question ready. If you want anything, end of session, we will take it. With this, we are coming to the presentation from PR experts. Next is going to be from Mr. Pierre Gilles from Belgium, sitting here. And he is going to talk on new rehabilitation materials and technology for road bridges. Reports, that is a last cycle by him. So 15 minutes for you, please.
Thank you, Mr. Chairman. Good morning, everybody. I would like to present you a report that we made during the previous cycle in the Road Bridge Committee in Prague, which was related to new rehabilitation methods and materials. Well, if you say new, that means perhaps innovation. And innovation is something which is very difficult because innovation is very depending on the country where you are, on the owner of the bridge, of the engineers to the office that you can have. It's also depending on the contractors that you have on the field. So there is no standard, of course, for innovation. And also you don't make innovation for the pleasure to make innovation. You just make innovation to try to meet in a better ways some objectives. That could be structural objectives, that could be durability, execution facilities, or also reducing traffic impact. And we know that it's also a very important objective even in Bangalore, whereas the traffic seems to be high. So I will present, in fact, not one report, but two reports. And I will illustrate these two reports with an example in my country, Belgium. So the first report, in fact, it was not during the previous cycle. So as you know, PR committee are working on a cycle of 4 years. And during 4 years, we are working on one topic. And at the end, we produce some report. So during the cycle 2012-2015, we already work on new repair and rehabilitation methods. In this case, what we did was to imagine, and in fact we collect them from our members, we collect 22 real degradation problems that we encounter in our daily life. And we propose those 22 real degradation problems to different countries, and we ask them, please give us your standard solution for this kind of problem, and give us also an innovative method that you could apply, or that you have applied, it's a better way. And then we make some evaluation and comparison of all these methods. So we can see that for the 22 real degradation problem, we collect answers from 12 countries, and we collect 59 standard methods and 48 innovative methods. And you will find all these methods in this report from the cycle 2012-2015, and it is, of course, available for free on pre-ARPO's site, but you know already how to collect them. So during the last cycle, 2020 to 2023, we were still working on these topics about innovation, innovative rehabilitation method. Why did you say? Well, why? Because the techniques are always evaluate, and new technology appears, so it was interesting to update our data. And we were focused on rehabilitation. That means we tried to restore the initial service level of performance of the bridge. And we focus also on retrofitting. That means that we will try to increase the service level or the performance of the bridge. So in this case, we didn't propose some real degradation problem. It was more free, ask for proposal. And we asked them a short description of the bridge, a description of the degradation, of course, and the description of the method that was applied. We collect 41 answers. That's quite nice. You can see the different countries. And we try to categorize the origin, the problem category of the bridge. And you can see that it relates mainly to fatigue of steel structure, bad design, aging of materials, and also corrosion of structural steel, but also corrosion of reinforcement steel, including post-tensioning. If we look to all these methods that we collect, in fact, we collect 41 methods, and we can see that half of these methods, these innovative methods, are related to not half, a quarter of them, 10 of them are related to carbon or glass fiber reinforced polymer, and we speak already about this technology yesterday. And another quarter are related to ultra-high performance concrete. That is also a very important innovative method. And half of the techniques that were, innovative techniques that were proposed are, well, difficult to classify. And in fact, it is also an illustration of the diversity of the challenge that we have to encounter when we have to rehabilitate a bridge. There are many different configurations that we have to manage. And you can see here some example of the other techniques that has been applied, like the one we just saw before. So this was a huge quantity of materials that we try to organize a little bit in order to help the reader or the report to find the best idea what he was looking for. So we, of course, we include all the case studies in the appendix of the report, but we provide 3 tools to the readers. In fact, 3 tables. First tables, it is a short synthesis table, like you can see here, a first line, where we collect all the case studies. And then we make an index table regarding the problem categories. So for different problem categories, we identify different methods that can be applied. And we make the opposite. an index based on rehabilitation categories, the category rehabilitation methods, and we look to, well, for this rehabilitation method, which kind of problem we can treat. So, as an example, I would like to present you a bridge in Belgium. It was a great work that we had to do there. We needed to replace the approach spans and to rehabilitate the central box girder bridge with a new waterproofing, with adding external post-tensioning and make some other concrete reparation. And we include there also 2 innovative rehabilitation methods. The first one is also related to the problem that Professor Tandon mentioned about the, well, how did you access to a box girder bridge is always a problem. In our case, the initial solution they found it was to put a hole in a lane, in a traffic lane. So it was necessary to close one lane of the highway in order to go inside the bridge, which, of course, is a very, very, very bad idea. So during the works that we perform, it was necessary to make a new opening in the lower part of in the lower slab of the box, as you can see there. But it is, well, a difficult place because we have there the anchorage of the post-tensioning, the initial post-tensioning. It will be also the place where we put new anchorage for new post-tensioning. And so there are many stress there. So it was necessary to reinforce the slab before we perform the hole. And we did it by applying some carbon fiber reinforced polymer. So you can hear on the left, you have the inside of the box with the new opening that has been performed. And on the right side, you can see the different layer of the carbon fiber reinforced polymer that were applied before the opening was performed, of course. And you have here the different characteristic of this carbon fiber. This technology was detailed in both reports from 2015 and 2023. You will find other example of this kind of technologies. The second technology that was applied was in fact related to a problem of PT, internal PT with chloride pollution. In fact, we are here in the middle of the midspan of the box girder bridge with the red circle. And, well, there is always a problem. How will you collect the water coming from the bridge? So you can, no, excuse me. You can see, no, it's quite difficult here. Over the blue line, it's the way we put some tube to collect the water and to evacuate this water here with some collector that were placed inside the box. Of course, due to the fact it was difficult to visit the box, due to the fact that the hole was in the first lane of the highway, well, we didn't go very often in the box. And, well, this solution was very quickly degraded and water was going inside the box. And, well, we are in Belgium, we have some challenge with snow, so we use some de-icing salt. So this water with de-icing salt was going inside the concrete and was polluting the post-tensioning tendons. It was an old technology, the old Fresnel's technology, with a metallic sheet and with just wires of 7mm diameters and cement coating. So we make some opening, and as you can see on the right, the injection was good, but we had too much chloride, and in half of the case, we overpassed the limit of 0.08% of mass. So we were looking for an innovative technology, and well, we decided to inject a corrosion inhibitor with a technology that was imagined by two people, French and a Belgian guys. And this, in fact, this technology is now belonging to a famous company in PT, as you can hear. So the inhibitor that were injected is calcium nitrite, which is a very well-known inhibitor. And the problem, of course, is how to push it in a cement grouting. And there, in fact, the innovative solution, they use some power acoustic waves. So you can see below, you have this device, which is the ultrasonic transducer that will push the inhibitor inside the grouting. And in fact, well, there are different mechanisms linked to this ultrasonic effect. So there are cavitation effect, there are some alternative pushing effect that allow you to push this inhibitor inside the grouting. As you can see on the top, on the right, you can see these beige color lines, which is in fact the inhibitor who is coming in the grouting. And so you perform along the cable, you perform different holes where you need to go up to the cables, and then you inject from one point to the other one, and you inject up to the time which is necessary to allow the inhibitor to travel from one point to another point. This is a technology that we have used in different bridges, 5 bridges in Belgium, and it's also used in other countries. And there were some feedback observation has been made 30 years later, and there are still no degradation with this kind of degradation of technology. So, as a conclusion for this presentation, of course, we know that even in certain countries, bridge construction is still going very fast, like in India. But for other countries, we have an old bridge stock that we have to manage, and we will need to make more and more bridge rehabilitation. So this became more and more a huge challenge for us, where innovative new methods are very interesting to try to help us to solve the problem that we have to solve. And that's in this field, as in other fields, it is very, very important to share knowledge. That's the aim, in fact, of PRAC, and that's what we try to do. So be imaginative when you try to rehabilitate your bridges. Be also aware that the competence of the bridge engineer and the bridge constructor are not also the same in different countries. So when you find a good solution on the paper, perhaps in your country it will not be available. So you may be careful about that, and don't forget the quality control. Thank you for your attention.
Thank you very much, Mr. Gill. And you have rightly finished your presentations. Now we will go for online presentations from a gentleman who is from Hungary, Mr. Janis Karkas. So he is going to talk on reinforcement of pavement around deck joint innovations, Hungarian experience, and that is online presentations. So organizer, can it play it there? I think Mr. Jain is available.
Yes, I'm here. I hope that you can hear me.
Oh, pardon?
I'm here, and I hope that you can hear me.
Yeah. Please go ahead. You have 15 minutes time for you, please. If you can do it. Are you able to hear me? Yeah, you please. Please go ahead.
Okay, okay, I'm going to speak about reinforcing of pavement sections around expansion joints. Do you hear me?
Yes, Janos, we can hear you. You can go forward.
Okay, thank you. So I'm going to speak about
Others can speak or
reinforcing method of expansion joint surrounding.
our delegates, are you able to hear him? Or you want some more tone? Okay? Okay, okay, fine. Please go ahead. They are also able to hear you. Please go ahead.
Okay, thank you. Let me express warm greetings from Budapest, Hungary, to all of the participants. As I told you, I am going to speak about the reinforcing method of pavement around or in the vicinity of expansion joints. But it's not only a Hungarian experience and innovation. It has about 10 years history. I've seen similar methods in Croatia and in Austria. So in Europe, it's maybe well known. Let's just see the index of my presentation. I will tell a few words about the background of this problematic, and then we will go into the details of the deterioration signs, and then I will present the principal idea of this intervention. We will look what are the benefits and the advantages of this method, and there is a disadvantage you see, maybe on the side of the expenses. We'll have a look about what to watch out for during the intervention, about the experience and the regulation in Hungary. The next slide shows the background situation. I think most of you know these things, but I tried to summarize what are the disadvantages of this location. It has to serve certain movement needs, longitudinal and transversal expansions, and what we tend to forget, there is sometimes an angular rotation, which may lead to vertical movements also. This is a connection point of different pavement layers, different thicknesses and made of different materials, and sometimes it's uneasy because it's not very easy to compact the asphalt in such sections. And there is a rigid structure encapsulated in the elastic pavement that also causes some problems. And it's also very advisable to ensure suitable drainage of this location, because water is one of our biggest enemy. Some kind of technology because one of our biggest enemy is water, as I told you. So I will come back to this question on the next slide. But let's see the advantages of such an intervention. It can be applied on new bridge construction and refurbishment projects also. And it can be a suitable complement of almost any type of expansion joint. On the pictures you show an asphalt expansion joint, a finger type, or modular or lamellar. And this intervention gives a very high rigidity or stiffness of the effective pavement layers, but thereby it reduces the dynamic effects on the expansion structure itself and results in less noisy passage also. And as a result, this section will be more resistant against mechanical damage, and if it's properly implemented, then maintenance costs can be saved. But the one and only disadvantage so far is that the intervention itself is more costly than the standard well-known repair technologies, such as the pothole fillings and the re-asphalting processes. And what we have to watch out for during the intervention is that suitable weather conditions shall be during the construction. Only a dry receiving surface works well, so we have to wait after the cutting for a while because the cutting results in water ingress into the grooves. So we have to let a certain time to dry. And we have to construct these ribs in accordance with the design, precise design. It means the allocation of the depth, length, width of the ribs and the distances from each other. We have to keep all the regulations about the construction technology itself. We have to keep mixing ratios, mixing time, the workability time, and also that when to get the traffic back on this implemented section. And there is also one question what we have to be very careful of. That usually the asphalt layers are getting more and more thin in the vicinity of the expansion joint. The arrow is going to show us the location where we have to be extremely careful not to cut through the waterproofing when doing this intervention. And we have to also keep the expansion structure itself in good condition so don't cut it also. The experience in Hungary is quite positive from the operators who have such sections around expansion joints. We have the feedback that this solution has proven itself very well. As I told you, it has about 10 years of history in Hungary, and only positive experiences are gained. So this is why this solution, after a short experimental period, was deemed then worthy to be incorporated into the technical specification. And on the right side, you see a page of the Hungarian technical specification where it's determined there are two options based on the intensity of heavy traffic. And you see that in the table the length, width, and the depth of these stiffening ribs. So, as a conclusion, in Hungary we have an experience that this solution is worth and try to help or assist in such questions if there is a need for that. This is all I think I have to finish because we are running out of time. So thank you for your attention.
Thank you very much, Mr. Karkas. Um, I will be getting question for you. Then I will request the organizers to mail you so that you can reply if they want. If you want, so that I will request all those who are sitting here, if you have any clarification question for him, please give us, then we can mail it or you can answer just now. So with this, we have come to end of all the presentations, and there are a lot of questions we have received for Professor Tandon and Mr. Srivastava and Mr. Pierre Gills. So I will request first Mr. Tandon. I am not going to read the question. I will request Mr. Tandon to read the name of the who has asked the question as well as the question so that he can reply. Tandon, please.
Okay, so yes, there are quite a few questions. First one I am reading is from Mr. Jay Gopal. And he says, with so many negative factors, you recommend this type of flyover bridge in future also in India. He also said there looks to be design fault in design of diabolos. So first question was about whether with so many negative factors, you know, it's not really negative factors, and there's nothing wrong with external pre-stress. It's only a question of how, what else you have to do with the external pre-stress. As a matter of fact, while we were having a discussion just 2-3 days ago with many of the people here, it seems that in some countries it is even preferred over grouted cables inside the concrete. But obviously they don't do dry jointed external pre-stress. That is now disappearing. I mean, more and more countries, I think, are saying that it should not be there. And there are reasons for that. But nothing wrong with external pre-stress. That's what I wanted to, that's the answer to the first question. There looks to, design of the diablo is faulty, it's obvious. The cable you are replacing do not have a code, either ASTM or BS or Euro, but it has only FIB. Is IRC contemplating new code regarding these cables? It is true, but you know, ASTM code really gives you specifications for the material. It doesn't tell you anything about replacing cables and things like that. That has to come in some code which is more of application oriented, and FIB is one of those codes. There is no code in India, I agree, of how to replace cables, but I beg your pardon, sir. So there is no code in India yet, but we do have codes for retrofitting and repairs, and I think that is the place where this can be added as to how to replace cables, because it is definitely an art as to how to replace the cables and what type of cables. The in external pre-stressing, and we are, I think, making a special publication on it. The cables that you use should be totally encapsulated from anchorage to anchorage, and they should be replaceable. That is going to be the recommendation in the special publication which we are making and which will be out soon. Even now the end blocks are supposed to be inside, but inside in grout material is incorrect. No, I think that, you see, if you have the anchorages outside, you have to take care of them. For example, you can't use metallic caps which was used here. And of course, the grouting is so important in that part of it. And the method of grouting, how to make sure that this place which is a potential location where you can have water going into the cables. So there is a special thing, methodology as to how to do grouting so that there is no air, no water possibility of leaking into it. So this is really a grouting procedure, which I think that we should have proper specification. Next one, Mr. Vikas Dikshit. My question, why can't we use stainless steel tendons? So there are two reasons that I could think of. One is the cost, of course, of stainless steel is quite high. The other is that, as far as I know, there is no pre-stressing system with strands which has been developed for stainless steel. I mean, so far they have gone up to galvanized strands, that is quite okay. But if there is a stainless steel, then you must have a pre-stressing system which caters to it. And unless that happens, we cannot really use it. The question was from Mr. Vikas Dikshit. Next question is Mr. G.K. Sahu. If there is no inspection to be provided anywhere in the major bridges, is there, if there is no inspection hole provided anywhere in the major bridges, the hole provided only 300 millimeter to 400 millimeter diameter only in the major bridge. You can have twin or triple cell box girders, and how to go about that. You see, the first thing about inspection is that all parts must be accessible. In the original design itself, you have to make provisions that it is possible to inspect. Okay. So this is a part which is a part of the inspection procedures, and the design when you do of a bridge, you have to make sure that it is possible to inspect, and for that whatever holes or anything is required, you have to provide them. From the diaphragm side, I think it is simpler, and another question from Mr. O.P. Srivastav. In India, we generally go for external pre-stressing in rehabilitating bridge. Only the flyover was designed with external pre-stressing of cable. No, I think that the first part of it is correct. We use external pre-stressing quite extensively in India for rehabilitating a bridge. But there is nothing wrong with providing external pre-stressing. The question is, external pre-stressing with dry jointed construction gives you one more layer of protection missing. Okay. Okay. This was from Mr. O.P. Srivastav. So I think we have to I think that there are far too many questions, so
I'm sorry, due to positive time, we have to rush up. So there are many questions of Professor Tandon and Srivastava or our others. So what I will do, I will read the name of those who asked the question, and they can discuss with Mr. Tandon later, online or offline or whatever. So there are questions from Alok Bhaumik. He has asked a number of questions. I'm not going to read. Although Mr. Tandon has prepared answer, but positive time, I'm sorry, I cannot do it. Then Dr. Sanjay Kumar, he has also asked the questions. Then Mr. V.N. Hegde is also a number of questions, although answer has been prepared by. Hello. So this slip can be passed on to him also. So these are the things, and including also one very interesting question from Mr. Ranjana Tandon, who is sitting here. He says that why the man were transferred like a sack of bag and potato in the bowl. So that is very interesting question.
Hello.
So it is general observations. So can there be any other method to take the worker inside for replacement of the thing in Bangladesh?
Hello.
So that was very interesting question.
So can I make one observation?
Another question from Sanjay Kumar. I've already read. So these are the number of questions. So I'm not going to. Hello. I'm not going to request to Mr. Tandon to answer it just now, but these are available, and you can discuss with him.
Okay, sir.
During tea time or maybe any other suitable occasion. So similarly, number of questions from for Mr. A.K. Srivastava, B.V. Jagdish, then Bimal Kale, AC Design, then B.V. Jagdish, then Paramjit Singh. So these are the questions. One more question for Mr. Pierre Gilles is there. So that is also there. So you can discuss, although you have prepared the answer, but no time. Sorry, we cannot do it now. Please. So with this, we have come to the question answer sessions and all the presentation. Now I will request my co-chair to just briefly sum up what has happened today.
Okay.
Dr. Anjali, please.
Okay, thank you very much. So we had a very interesting session about maintenance and rehabilitation and the retrofitting of bridge. So we might try to build the most durable bridge. We see that inevitably at sometimes it's during construction, sometimes it's 10 years later or maybe more years later. They need to be repaired because something has gone wrong, or maybe just the structure has aged. Due to the diversity of the bridges and the problems that can arise, it's a new challenge every time to repair the bridge. And we really need to repair them to restore serviceability, safety, durability, and the confidence of users. So from the huge pre-stressed bridges to the foundations to the expansion joints, today we've covered a wide range of examples. So thank you very much to all the speakers for that. And just as a little conclusion, I would say that we should be imaginative to find the right solution to the problem according to the owner's main constraint and wishes. And we also need, as the problem is very diverse, we also need to share our knowledge worldwide. So that's why we're here. So it's really good. And I also noted down that we need a really careful quality of the work during the repairs as well as during the first construction, so quality controls, and afterwards maybe it can be good to go to regulate the methods used for the retrofitting as they did in Hungary. So thank you very much for your attention.
Thank you very much for very quick summarizing. And we will come to the end of this session, and I would like to thank all those who are here, my co-chairman and all presenters, along with all the participants who are patiently here, heard it. So with this, I declare this session a closed one. Thank you.
Thank you, sir. We request all of you to kindly stay for a few more minutes. First of all, I would request the co-chair, Mrs. Cecile, to kindly come forward and felicitate our the Indian experts, Professor Mahesh Tandon first. The IRC experts. Thank you, Professor Mahesh Tandon. Thank you very much. I would request Shri Anil Kumar Srivastava to kindly come forward and receive the felicitation from Mrs. Cecily Bove. Thank you very much. Thank you, Mrs. Cecily. I would now request Shri G. Sharan to kindly come forward and give a memento to Mr. Pierre Gilles from Belgium. Mr. Pierre, kindly come forward. Thank you very much. It's a great experience for people coming from outside of India, I'm pretty sure. The rich tradition of our rich cultural heritage, you will definitely remember this for a long, long time, the memorable one. And on behalf of Mr. Yanis Karkas, I would request the chair of the Technical Committee 4.2, Mr. Nicholas Vardo, to kindly come over and receive the felicitation from Mr. Sharan. Thank you, sir. Sir, I would request you, Sharan, to kindly felicitate here, sir. Here, yeah. Because he's receiving the felicitation on behalf of Mr. Karkas. Thank you, Mr. Nicholas Bardo, for receiving this on behalf of Mr. Karkas of Hungary. Thank you. I would now request the Secretary General of IRC, Mr. Sanjay Kumar Nirmal, to come over and felicitate the chair, Shri G. Sharan, and the co-chair. First the chair, yeah. You receive, sir. Thank you very much, sir, for steering the session to a great session it was. Thank you, sir, for chairing the session. I would also request the co-chair, Mrs. Cecil, to kindly come forward and receive the felicitation. Thank you very much. More than the memento, I'm pretty sure all of you will relish the shawl. So thank you very much for that. Thank you, Sri Sanjay Kumar Nirmal. I would request all of you to kindly come forward for a photograph, sir. Chair, co-chair, all the presenters kindly come forward for a photograph. So immediately after the photograph, let's have a very quick break and do come back in the next 15-20 minutes because the Honorable Union Minister and Shri Nitin Gadkari, the Honorable DCM Shri D.K. Shivkumar, the Honorable Minister Shri Satish Jarkioli and host of dignitaries are going to be there for a very special plenary session. So I would request all of you to kindly have your tea or coffee very quickly and do come back in the 15 minutes. And do not forget that in case your questions, you want to pose any questions, the QR code will appear on the giant screen. You can always send in your questions, which will be replied to you through mail. The QR code on the LED, please. So enjoy your tea and do come back in 15 minutes. Thank you.
Hello, 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 check, hello. Hello, hello, check, hello, hello, check, check, hello. Number 5, sir. 5. Hello, 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 check, hello, 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 check, hello, hello. Hello, hello, check. Hello, 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 check. Hello, hello. Oh. Hello, hello, check. Hello, 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 check. Hello, hello.
Check, check, check. Hey, check.
ಬನ್ನಿ ಆಮೇಲೆ ಇವರಿಗೆ ಮೇಲೆ ನಿನ್ನೆ ಯಾರಿಲ್ಲ, ಇವತ್ತು ಮಿನಿಸ್ಟರ್ ಬರ್ತಾ ಇದ್ದಾರೆ, ನಿನ್ನೆ ಸ್ಪೀಕರ್ ಅಷ್ಟೇ. ಅಲ್ಲ ಇಡೀ ಏನೊಂದು 8-9 ಅಷ್ಟೇ ಇದೆ, 10 ಜನ ಇದ್ದಾರೆ ಅಷ್ಟೇ.
Ladies and gentlemen, the Honorable Union Minister Shri Nitin Gadkari ji is here. Let's give a round of applause and welcome the Honorable Minister. We also have the Honorable Minister of PWD Shri Satish Jarkiholi. Shri Nitin Gadkari ji, Shri Satish Jarkiholi. I would also request Mr. Nicholas Bardau to kindly come over. Shri D. Sarangi, Director General. Dr. S. Selvakumar, Principal Secretary. Shri S. K. Nirmal, Secretary General. Shri C. Satyanarayana, Secretary, PWD Government of Karnataka. And Shri S. F. Patil to kindly come over on stage, please. Well, ladies and gentlemen, true to the expectations prior to the start of this international seminar, since yesterday, industry captains from all over the world have congregated here in Bangaluru, the IT city, BT city, the technological capital of India, and fruitful discussions have been happening since yesterday. On behalf of the Ministry of Road Transports and Highways, Government of India, PARC, Indian Roads Congress, and Public Works Department, Government of Karnataka, I am Shankar Prakash, extending a very, very warm welcome to all of you for the very special plenary session on the International Seminar on Advances in Bridge Management. A very hearty welcome to all of you, ladies and gentlemen, boys and girls. As per the tradition of Karnataka, we start this special plenary address with the rendition of Nada Gite, Jai Bharata Jananiya Tanujate Jaya He Karnataka Mate. I would request Kikeri Krishnamurthy team to kindly come over here and present the Nada Gite. I would request all of you to kindly rise for Nada Gite.
Hello, hello.
जय भारत जननीय तनुजाते जय हे कर्नाटक माते जय सुंदर नदी वनಗಳ ನಾಡೆ ಜಯ ಹೇ ರಸ ಋಷಿಗಳ ಬೀಡೆ ಭೂದೇವಿಯ ಮಕುಟದ ನವಮಣಿಯೇ ಗಂಧದ ಚಂದದ ಹೊನ್ನಿನ ಗಣಿಯೇ ರಾಘವ ಮಧುಸೂದನರವತರಿಸಿದ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜನನಿಯ ಜೋಗುಳ ವೇದದ ಘೋಷ ಜನನಿಗೆ ಜೀವವು ನಿನ್ನಾವೇಶ ಹಸುರಿನ ಗಿರಿಗಳ ಸಾಲೆ ನಿನ್ನಯ ಕೊರಳಿನ ಮಾಲೆ ಕಪಿಲ ಪತಂಜಲ ಗೌತಮ ಜಿನನುತ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಶಂಕರ ರಮನುಜ ವಿದ್ಯಾರಣ್ಯ ಬಸವೇಶ್ವರ ಮಧ್ವರ ದಿವ್ಯಾರಣ್ಯ ರನ್ನ ಷಡಕ್ಷರಿ ಪೊನ್ನ ಪಂಪಲ ಕುಮಿಪತಿ ಜನ್ನ ಕುಮಾರ ವ್ಯಾಸರ ಮಂಗಳಧಾಮ ಕವಿ ಕೋಗಿಲೆಗಳ ಪುಣ್ಯಾರಾಮ ನಾನಕ ರಾಮಾನಂದ ಕಬೀರರ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ತೈಲಪ ಹೊಯ್ಸಳರಾಳಿದ ನಾಡೆ ಟಂಕಣ ಜಕಣರ ನೆಚ್ಚಿನ ಬೀಡೆ ಕೃಷ್ಣ ಶರಾವತಿ ತುಂಗ ಕಾವೇರಿಯವರ ರಂಗ ಚೈತನ್ಯ ಪರಮಹಂಸ ವಿವೇಕರ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಸರ್ವ ಜನಾಂಗದ ಶಾಂತಿಯ ತೋಟ ರಸಿಕರ ಕಂಗಳ ಸೆಳೆಯುವ ನೋಟ ಹಿಂದೂ ಕ್ರೈಸ್ತ ಮುಸಲ್ಮಾನ ಪಾರಸಿಕ ಜೈನರು ಉದ್ಯಾನ ಜನಕನ ಹೋಲುವ ದೊರೆಗಳ ಧಾಮ ಗಾಯಕ ವೈಣಿಕರ ರಾಮ ಕನ್ನಡ ನುಡಿ ಕುಣಿದಾಡುವ ಗೇಹ ಕನ್ನಡ ತಾಯಿಯ ಮಕ್ಕಳ ದೇಹ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ.
Thank you very much for the soulful rendition. At this juncture, it's my privilege to request the Honorable Minister, Union Minister for Road Transport and Highways, Shri Nitin Gadkari ji, and other dignitaries to kindly move to the left-hand side of the stage to light the lamp and signal the beginning of this very special plenary session. I would request the other dignitaries to kindly join in the Honorable Union Minister. I would also request Shri Satish Jarkioli, Honorable PWD Minister, Government of Karnataka, and other dignitaries to light the lamp. Well, ladies and gentlemen, this is a very, very special occasion in terms of advances in bridge management. Experts from all over the world have congregated here, and they have shared their experiences. And we are also having a few more sessions in the afternoon, wherein we'll get a deep insight into the management of the bridges, which will help in a long way. Thank you very much, Shri Nitin Gadkari ji and other dignitaries for lighting the lamp. I would now request the Honorable PWD Minister, Shri Satish Jarkioli, to kindly welcome and felicitate Shri Nitin Gadkari ji, Honorable Union Minister for Road Transport and Highways. The traditional Mysuru Peta, which signifies the cultural heritage of Karnataka. And we all remember Bharat Ratna Mokshagundam Vishweshwaraya, one of the most eminent engineers of Karnataka, showcasing India to the world. That is the traditional Mysuru Peta. Thank you, sir. I would now request the Director General, Road Development and Special Secretary of Ministry of Roadways to kindly come over and felicitate Shri Satish Jarkioli. I would request Shri D. Sarangi to kindly felicitate Shri Jarki. I would request Shri C. Satyanarayana to kindly felicitate Mr. Nicholas Bardau. Satyanarayana to kindly come over and felicitate Satyanarayana. Yeah. Friends from print, electronic, and social media have been of tremendous support. Let's give a round of applause for all the friends from the media who are covering this in great numbers. And now it's... Thank you. I would request Shri S.F. Patil, CPO, to kindly felicitate Shri D. Sarangi. Director General, Road Development and Special Secretary, Ministry of Road Transport and Highways, D. Sarangi ji. I would request Shri P.B. Prakash to kindly felicitate Shri S.K. Nirmal, the Secretary General of IRC, Mr. P.B. Prakash, to come over and felicitate Shri Nirmal. I would request Shri Sunil Kumar to felicitate Shri C. Satyanarayana, Secretary, PWD, Government of Karnataka. And finally, I would also request after this, Shri Rahul Patil to kindly felicitate Shri S.F. Patil. Thank you very much. Well, ladies and gentlemen, it's indeed a matter of great pride for all of us that in spite of his busy schedule, the Honorable Union Minister for Road Transport and Highways, Shri Nitin Gadkari ji, is here. I would now request Shri S.F. Patil, CPO of K-Ship Government of Karnataka, for the opening remarks and welcome address.
Good afternoon to all. It is my pleasure to inform you that Indian Road Congress, in association with the World Road Congress, PIAC, Public Works Department, Government of Karnataka and Ministry of Road Transport and Highways is organizing this premier two-day international seminar on advances in bridge management in Bangalore. On behalf of Government of Karnataka, we thank Indian Road Congress for interesting us in organizing this two-day premier international seminar. It is indeed our pleasure to host this event here in Bangalore. At the outset, it gives me a great pleasure to welcome all the dignitaries and delegates on and off the dais. In my opening remarks, I would like to very warmly and respectfully greet the presence of Honorable Union Minister for Road, Transport and Highways, Shri Nitin Gadkari sir, who despite his busy schedule was kind enough to be present in this seminar. On behalf of Government of Karnataka, I welcome you to Bangalore and to this seminar, sir. I welcome you, sir. Honorable PWD Public Works Department Minister Sri Satish Jarkari sir, our PWD Minister is instrumental in this hosting this seminar here. Without his kind courtesy, it could not have been possible. I welcome our Honorable PWD Minister Sri Satish Jarkari sir. I welcome you, sir. Mr. Nicholas Bardo, I welcome you to this seminar, Mr. Nicholas Bardo. Sri Sarangi, Director General, Road Development and Special Secretary More, I welcome you to the seminar, sir. Sri S.K. Nirmal, Secretary General, IRC, I welcome you to the seminar, sir. Sri Satyanarayan, Secretary to Government Public Works Department, Government of Karnataka, I welcome you to the seminar, sir. I welcome PIAC members and all the delegates, I welcome you all to this seminar. Dignitaries on the dais, off the dais, industry representatives, friends from the press and media, ladies and gentlemen, on behalf of Government of Karnataka, I welcome you all once again. I look forward to your participation in making this seminar truly fruitful and successful one to cherish. Thank you one and all. Jai Hind, Jai Karnataka.
Thank you, Mr. Patil, for that quick opening remarks and welcome address. I would now request the PIAC Technical Committee 4.2 Chair, Mr. Nicholas Bardo, for his address. Ladies and gentlemen, please put your hands together. I've been telling since yesterday, India is known for Atiti Devo Bhava. Please put your hands together.
Dear Mr. Shri Nitin Gadkari, Honorable Minister of Road Transport of Highways of India. Dear Mr. Shri Shiv Kumar, Honorable Deputy Chief Minister of Government of Karnataka. Dear Mr. Shri Satish Jarkioli, Honorable Public Works Minister of Government of Karnataka. It's my responsibility today to introduce PIAC, introduce our association, and introduce our works. It's also my responsibility to thank warmly all our Indian hosts for this fabulous technical committee meeting and seminar that we just are living. So it's my responsibility to introduce quickly PIAC. PIAC, it's the road association, the World Road Association, founded in 1909, and you need to know that India was one of the country founder of PIAC. This is the first forum of exchange of knowledge about road. We have 129 country members, and we join more than 1,200 experts in the world. We have 4 main missions. The first is to be a forum of analysis and discussion about road in all its dimensions. The second is to identify and disseminate all the best practice and to communicate in international communications. The third is also cooperation issues between the high income country and low and medium income country. And third, the last objective is to promote some tools in order to help decision makers regarding road issues. This association met every 4 years, have cycle of 4 years with indication gave by the committee, executive committee, who join all the 129 countries. We have a strategic theme, and we share this strategic theme in 24 specific committees. I have the honor to share the bridge committee. We do a lot of outputs, a lot of deliverable with philanthropy, with philanthropic skills. The idea is to share. All the deliverables are free. We organize meeting and seminar, for example, today. And also, there is 2 big rendezvous during the cycle. We have our World Road Congress. The next date is 2027 in Vancouver, Canada. And in between, we have the Winter Congress and Resilience Congress in France, Chambéry, in 2026. 2 words about our technical committee, the Bridge Technical Committee. We join 143 members from 64 countries. And we work in different issues, and we have mainly 5 principal issues in this cycle: digital transformation, management and monitoring of post-tension growth duct bridge. We see that this is 2 items really important also in India. Requirement evaluation for structural redundancy in a time of climate change. It's really important. We continue our work in forensic engineering, as we had a session yesterday on that, and low carbon material. And in our last cycle, it will be my end word. In our last cycle, we already had 10 deliverables, and the aim of this seminar regarding PIARC was also to share with you these works. We already share forensic engineering, we share technical inspection, we share new material rehabilitation, and in the next session, we will share measures regarding climate change for bridges and resilience for seismic damages. So thank you very much for your welcome, thank you for your attention, and I will be available with all my colleagues from 26 countries here in the room to answer your question. Thank you very much.
Well, ladies and gentlemen, Mr. Nicholas has played a very important role in getting the experts from around the world. So let's give a round of applause and thank Mr. Nicholas for his presentation. Thank you, sir. I would now request Shri D. Sarangi, Director General, Road Development and Special Secretary of Ministry of Roadways and Highways, for his address.
Honorable Minister, Road Transport and Highways, Government of India, Honorable Minister, PWD, Government of Karnataka, Mr. Nicholas Bardo, PIARC T2 Chair, Principal Secretary, PWD, Government of Karnataka, Secretary General, Indian Road Congress, Secretary, PWD, Government of Karnataka, CPIO, KSHIP, Government of Karnataka, delegates from PIARC, bridge experts from various organizations, participants from MRTH, NHI, state PWDs, other government organizations, construction and consultancy firms, friends from media, namaskar and very good afternoon to all of you. On behalf of Government of India, I heartily welcome you all to this plenary session of the International Seminar on Advances in Bridge Management, jointly organized by Ministry of Road Transport and Highways, Government of India, Permanent International Association of Road Congress, PRC, Indian Road Congress, and PWD, Government of Karnataka. As you all know, India has embarked on a very massive road construction, improvement, and upgradation program for national highways. There are similar developments by state governments also in all categories of roads from urban to rural. So as a process, this has necessitated construction of large number of bridges, culverts, flyovers, underpasses, ROVs, elevated roads, etc. We constructed the first cable-stayed bridge in Kolkata, Vidyasagar Setu, way back in 2002. And after that, there have been steady number of increase in long-span bridges, whether cable-stayed or extra dose or cantilever construction. We have been also constructing a number of steel bridges and with the requirement of railways, particularly bowstring girder bridges are now visible everywhere on national highways. To give a glimpse of bridge construction in the country, currently we have 13 bridges under construction over Ganga alone, having an aggregate length of around 48 kilometers, of course, including the viaduct sections on either side approaches. We are also using advanced construction materials like UHPFRC, etc. Multiple structural configurations are used depending upon span, cross-sectional requirement, and aesthetic considerations. We have also switched over to precast construction in a significant way, whether it is I-girder, T-girder, or segmental box superstructure. We are designing bridges and structure as per our codal guidelines for 100 years design life. And bridges are required to meet strength, serviceability, and durability criteria for the entire design life. IRC has also developed standards for limit state design for RCC, PSC, and steel bridges. IRC has also developed several guidelines for cable stayed bridges, extra dose bridges, etc. But, sir, we have also, among all these developments, we have been also facing issues with regards to design and construction of bridges. During last 3 years alone, there has been collapse of one or more spans of 11 numbers under construction bridges. Most of the projects we implement either in EPC or PPP, that's HAM or BOT toll mode. Design, construction, and quality issues have been noticed in all these projects where there are failures. There is absolute necessity to upgrade our standards, guidelines, enhance skill and competency of our engineers, whether working in government organizations, contractors, and consultants, and upgrade our overall quality ecosystem. Insofar as cable-supported bridges are concerned, domestic design capability also for both service as well as construction stage also required to be upgraded. We are also facing problems on temporary structures, launching girders, bridge deck erection equipment, and we have to overcome these challenges. Management of our existing bridges and structures involving periodical inspection, investigation, and timely repair, rehabilitation, or retrofitting is a big challenge. We started Indian Bridge Management System way back in 2016, but somehow it could not properly succeed. We have now again started IBMS in a more structured manner. Inventory module is ready. Condition survey module will be ready in a month or two, and hopefully we'll be able to collect inventory and condition of all bridges and structures on national highways by the end of next year. Whereas real-time health monitoring of particularly long span cable supported bridges were going on for some time. We have come up with detailed guidelines and model contract documents for real-time health monitoring of selected bridges in continuous or discrete manner using various kinds of sensors. We have also taken up a research project to develop protocol and software for meaningful analysis of data received from various kinds of sensors to predict with reasonable level of confidence the residual life of the bridge and specific interventions required. The focus and contents of this international seminar has been structured to deal with the issues I highlighted in my note. We have almost all bridge experts from our country here, and we have 40 eminent expert delegates from different parts of the globe. The deliberations are continuing in a very fruitful manner. While it will be most certainly elevate the knowledge and exposure of the participant, it will also help us at ministry and IRC level in consolidating and strengthening our strategies to make our bridge construction and maintenance program more scientific and result-oriented. Sir, I want to commit of the entire fraternity of engineers who are here our resolve to improve the condition or the way we are now managing our bridges, whether it is construction or maintenance. I am sure the deliberations that we'll have already since yesterday, and it will be continuing till the end of today, will not only enrich our knowledge and competency, but also our resolve in that direction. Thank you all. Namaskar. Jai Hind.
Thank you, sir, for giving us a comprehensive overview of the various steps being taken by the road development arena in terms of strengthening this sector. I would now request the Secretary General of IRC, Shri S.K. Nirmal, for his address. Devar Sajjano Swagat Kijiye, Shri Nirmal.
Good afternoon, Honorable Union Minister for Road Transport and Highways, Sri Nitin Gadkari ji. Honorable PWD Minister, Government of Karnataka, Sri Satish Jarkioli ji. PR Chair, Bridges, Mr. Nicholas. Director General and Special Secretary, Ministry of Road Transport and Highways, and my colleague, Sri D. Sarangi. Principal Secretary, PWD, Government of Karnataka, Dr. S. Selva Kumar ji. Secretary, PWD, Government of Karnataka, and Chairman, State Steering Committee, Sri C. Satyanarayan ji, CPO and State Organizer, Government of Karnataka, Sri S.F. Patil ji. In fact, I got a message that Honorable Deputy Chief Minister, who was supposed to come because of the cabinet meeting, he is still in the cabinet, so he could not come and he may be coming a little late. So, ladies and gentlemen, on behalf of the Indian Road Congress, I express my sincere gratitude to Honorable Union Minister for Road Transport and Highways, Sri Nitin Gadkari ji, for sparing his very valuable time to be with us today in spite of his extremely busy schedule in this special plenary session. In fact, he was to come yesterday originally, but because of the cabinet meeting and all or other very pressing engagement, he could not come. But he is always kind enough to spare his time for blessing us in our IRC sessions, IRC seminars. So I also express my sincere gratitude to Honorable Minister PWD, Government of Karnataka, Sri Satish Jarkioli ji, for guiding this seminar and agreeing to host this seminar in Bangalore and gracing this function. I would also like to thank Sri D. Sarangi, DGRD and MORTS for facilitating PR participation in this international seminar and providing all needed support from time to time. I also thank Mr. Nicholas Bardo, PR Chair, for making this international seminar possible by mobilizing international experts of renowned, their committee members, bridge committee members, and other experts from all over the world. In fact, he was closely associated with us in planning and monitoring of all activities associated with organizing this seminar for last 6 months. In addition, PRC also provided us opportunity to host their first bridge technical committee meeting just before 2 days. I mean, Monday and Tuesday we had a PRC technical committee meeting also in India. That was the first time, and I thank all the PR delegates coming from different parts of the world for participating in this seminar after their technical committee meeting. Sir, I will just little bit brief I will give about IRC, that IRC is an apex body of highway engineers which started 90 years back. PRC started in 1909 and we started in 1934. So very close to that. And we are the founder member of PRC, and the IRC is a national committee of PRC. There are total 50 national committees, out of which IRC is one national committee. So the main objective of IRC is to formulate standards, codes, specifications, manuals relating to all aspects of road transportation. And we have so far prepared, sir, about 280 codes and guidelines. And 50 of these codes belong only to bridge subjects. In fact, 50 codes are already available and 12 codes are already under print. So, and many of these codes will be maybe very few in the world. Maybe only 2 or 3 codes are already available, and we may be in the forefront of preparation of these standards and codes for the bridge sector also. We have been organizing, sir, our seminars with PRC for last couple of years. In fact, in COVID period also, we had a webinar with PRC in May 2021. And that was followed by a seminar on tunnels last year, sir, in Dehradun. And this year, we are having this particular seminar on bridge subject. Sir, the present seminar is being attended by 40 international delegates from 25 different countries. And they have also provided 16 PRC experts, speakers, for delivering their presentations during this seminar. Sir, over the last 2 decades, we have seen the tremendous growth of our road transportation in India due to various our development programs. And they are having a lot of stresses in our bridge network also. And in addition, for last couple of years, we have seen a number of bridge failures in India, which is a major cause of concern for all of us. And therefore, main theme of this seminar, including the subject of our panel discussion today in the afternoon, is bridge collapsing during construction and lesson learned. So in fact, we asked all the foreign experts also to focus on this area because various states we are facing this problem of bridge failures. So during this 2-day international seminar, we have planned 7 technical sessions. They are dealing with subjects of like new materials in bridge construction, forensic engineering for structural accidental failures, inspection of operational strategies for bridge management, instrumentation and structural health monitoring for bridges. So these 4 topics were covered yesterday, and today we have covered in the morning session also advances in maintenance, rehabilitation, retrofitting of bridges. And in the afternoon session, we will have a measure for adaptability of road bridges to climate change. And then that last session will be on the panel discussion, dealing with the bridge failure and lesson learned from that. So sir, every session we have planned in such a way that there are 2 Indian experts and 2 foreign experts in every session. And chair also, 1 chair is from PRC and 1 chair is from India. So it is truly international seminar in all sense. Sir, I'm happy to inform you that as per your direction, IRC finalized the new guideline on use of glass fiber reinforced polymer bars. And we have published it as IRC 137. And this document was prepared in less than 1 year. I think it is very, hardly any few document which we prepare such in a fast way, and it is less than 1 year we have completed and printed. Yesterday, during the first technical session on new materials, in fact, there were 2 international presentations from 2 experts, one from Canada and one from Belgium, who are using GFRP bars for last more than 25 years in their country. And they shared their experience with us yesterday. And I hope this has provided us more confidence for using this new anti-corrosive material in our project. Sir, I am sure that deliberations made during the seminar, specifically from the international experts, what we have learned will be very useful in enriching our present knowledge on bridge construction, maintenance and management for all the stakeholders present here. Moreover, it will definitely help IRC in updating our existing standards and codes and preparing new standards, and it will benefit the entire highway profession. Thank you, sir.
truly international seminar in the true sense. Thank you, Sri S.K. Nirmal, for your address. Well, ladies and gentlemen, the Honorable PWD Minister of Karnataka always believes that the engineers as well as all the staff will have to upgrade their skills on a regular basis so that they will be competitive not just in India but in the entire world. So, and he was mainly instrumental to ensure that it happens in our city, Bangaluru. So let's give a round of applause and welcome Shri Satish Jarkiholi for his address.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. It is indeed pleasure to have Honorable Minister, Road Transport and Highways Sri Nitin Gadkari here to inspire in his busy schedule. He has come to hear on our request. Our Principal Secretary, PWD Karnataka, Government of Karnataka, Dr. Shival Kumarji, Saraniki Director General, Special Secretary Morth, Sanju Kumar Nirmalji, Secretary General IRC. So, Mr. Nicholas Ji, Secretary PWD Satnaran Ji, और KC Chief Engineer P.S. Patil ji, press and ladies and gentlemen, ತಮ್ಮನ್ನೆಲ್ಲ ಬೆಂಗಳೂರಲ್ಲಿ ನೋಡಲಿಕ್ಕೆ ನನಗೆ ಭಾಳ ಸಂತೋಷ ಆಗ್ತಾ ಇದೆ. I am happy to see you all are in Bangalore. You have selected quite relevant topic for seminar to discuss the current problems and future solutions. For bridge management, as you all know, recent flood due to heavy rain has created a lot of problems to road infrastructure in Karnataka. Lot of bridges collapsed, damaged heavily in the Western Ghat area of Karnataka. In addition, around 1,200 kilometer length of roads are also washed away. It is in my observation that maintenance of roads and bridges requires specific performance-based programs, but that is not updated in the system. Routine maintenance policy is followed since so many years. This maintenance policy should also be revised based on advanced technology. The online monitoring of the roads, bridges should be planned digitally so that it is helpful more for good governance in coming years. The discussion in the seminar should be able to address the common problem of the roads and bridges. The solution should be more practical and financially feasible. Also, new technology and advance in the bridge management tool should able to predict in the future about behavior of bridges and varied loading pattern and various climatic conditions. Otherwise, maintenance of the bridges under severe climatic conditions, the composite loading pattern become very difficult to hear climate change. Best practice followed on the other countries need to adapt to our state if it is competitive. The team should also work on this so that good practice of other countries can follow to make bridge management more municipal to the society. Also, all engineers should work sincerely and maintain bridge and road in the systematic manner. Pre-monsoon and post-monsoon inspection of bridges should be made mandatory so that most of the problems can be solved on the site. The bridge inspector and Safety inspector rule is also very important. We need to train our engineer in the field of bridge and safety. Please share the program of advanced learning in the field of bridge maintenance so that our team can be trained for efficient management. And also to ensure asset management can be more productivity, I wish this conference will through light on advanced, workable and most reliable, perfect the model of the better future in bridge. Design, quality, construction and maintenance and functionality. I hope this seminar will bring in more ideas and innovation to the shared, all our shareholder. I wish everyone to all best for this program. ಬಹುಶಃ ನಮ್ಮ ಕೆಸಿಪ್ನವರು ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಭಾಳ ಅಚ್ಚುಕಟ್ಟಾಗಿ FS ಪಾಟೀಲ್ ಅವರ ನೇತೃತ್ವದಲ್ಲಿ ಈ ಪ್ರೋಗ್ರಾಮನ್ನು ಮಾಡಿದ್ದಾರೆ. ಅವರಿಗೆ ಮತ್ತು ಅವರ ಎಲ್ಲ ಸಹೋದ್ಯೋಗಿಗಳಿಗೆ ಮತ್ತೊಮ್ಮೆ ಆತ್ಮೀಯ ಅಭಿನಂದನೆಗಳನ್ನು ಸಲ್ಲಿಸಿ ಈ ಕಾರ್ಯಕ್ರಮ ಯಶಸ್ವಿಯಾಗಿ ಅಂತೇಳಿ ನನ್ನ ಮಾತು ಮುಗಿಸ್ತೀನಿ. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಜೈ ಭಾರತ್, ಜೈ ಕರ್ನಾಟಕ.
Well, the Honorable PWD Minister has highlighted the importance of advanced learning towards efficient management. Once again, let's give a huge round of applause and thank Shri Satish Jarkiwali. Well, ladies and gentlemen, every Indian agrees that under the able leadership of Shri Nitin Gadkari, the area of road transport and highways has been totally revolutionized, and it is on par or even better than some of the major developed countries of the world. So let's give a huge round of applause to the Honorable Union Minister for his special plenary address. Devier Sajjano, swagat kijiye Shri Nitin Gadkari ji.
My respectable colleague, Honorable Satish Jarkiwali ji, PWD Minister of Karnataka, Mr. Nicholas Baud, PIRC Chairman, Dr. Selva Kumar, Principal Secretary, PWD, Government of Karnataka, Sri Sarangi ji, DG, Ministry of Road Transport, Sri S.K. Nirmal, Secretary General, IRC, Sri Satyanarayana, PWD Secretary, Government of Karnataka, Sri Patil, C. PWD, Government of Karnataka, delegates from India and abroad, officers from central and state government, and respectable dignitaries. First of all, I am welcoming all the foreign delegates who are specially attending this conference in India, in Bangalore. I am giving my warm welcome to all of them. I am very happy to be present here because I am not an engineer, but I am related with the road activities, and where I 100% I am confident that 100% I can understand some new innovations, new research, and learn something new from you. The Indian infrastructure is very important as far as the society is concerned. We have a big population and we are the fastest growing economy in the world. Water, power, transport and communication, these are the main infrastructure, and without that, we cannot get industry, trade, business and development in agriculture. And without development in industry, trade, business and agriculture, we cannot create jobs. And without jobs, we cannot eradicate the poverty. So the role of the infrastructure in the development of our country is very, very important. I always, from 95-2000 when I was minister in Mumbai, in Maharashtra, in just back to my seat, a famous statement of John F. Kennedy was there. The American roads are not good because America is rich, but America is rich because American roads are good. So I always remember this. And IRC's track record is very good. From 90 years old, this is a technical organization which is guiding our infrastructure development in our country. I always feel that the knowledge is the most important power. And now the future is related with the knowledge. The innovation, entrepreneurship, science, technology, research, skill and successful practices, we name it as knowledge. And conversion of knowledge into wealth is the most important agenda in the development of every country. So today the transformation of knowledge into infrastructure, that is to be the basic responsibility for IRC. We have to accept whatever the best practices in the world, and we have to develop good quality of infrastructure. We need good quality, but at the same time, we need to have a reasonable cost. Without compromise with the quality, we don't want to reduce the cost. But with the good quality, we have to maintain good quality, and actually the cost is equally important. Today, IRC is the knowledge engine for our growth in infrastructure. One thing always in every IRC I am convincing and try to give proposal to the all office bearer of IRC. Somewhere I feel that the IRC is working like a political party. So you are professional people. So you should have a permanent organization, Institute of Management, Institute of Research, Training and Development, with the technical laboratories, and it should be full-time activities. And the people who are more interested in the research and the technology, you can appoint them up to 70 years and take the advantage of their knowledge and their experience. Still, also in this IRC, I am offering you, if you want to start this, we are ready to give you land in Delhi and even grant for developing infrastructure and everything. And I am confident that the whole state government, including Karnataka, they will contribute. So by which it should be an independent, impartial and fair organization. You should not work under the umbrella of the ministry. Because I know that in the government, boss is always correct. Whether he is taking wrong decision, everyone is telling that my boss is correct. That is the philosophy. So you should have an independent, impartial, quality conscious approach for that. And that is exactly the need of the hour. Regarding the bridges, we are facing a lot of problems. And particularly in the area which is nearer to the seashore, where a lot of bridges are collapsed. Now I am very much bothering about when I was minister in Mumbai, in Maharashtra, I got opportunity to construct 55 flyovers in Mumbai and Worli-Bandra ceiling project and Mumbai-Pune Express Highway at that time. At 95-2000, there was one technical people giving me the proposal. They have some green coating on the steel and they have given me the guarantee that it should be permanent, there will be no problem. But now I feel that somewhere that was my mistake, because I can't understand all the technical thing at that time, because I don't have engineering knowledge. But today, from last 7 to 8 years, I am telling to every my officers that you should have use of stainless steel regarding the area near to 25 kilometers from the sea. But now, after 7 years, the government now issuing the order. So now in the 7 years, who is responsible for that? So the transformation of knowledge, the time is very important. The most important thing where I am very much annoyed about the time. I don't want to use that word here, but somewhere I am using this word for DPR people, the main culprits. And because of them, we are facing a lot of problems. And after accepting that DPR, our government people just treat it as a Bible. They are not ready for any variations. And because of that, lot of mistakes we have committed, and that is to be a biggest problem. You should find out the solution for that. We need good quality and perfection. I remember in 95-2000, I remember the name of the consultant, bridge designer, Srinivasan. At that time, he was from Hong Kong. And from VT to JJ Hospital, that bridge was designed by Mr. Srinivasan. Even Varli Bandra also, Mr. Malik, one of the consultants from USA. And after that, the work was given to Srinivasan. And actually, I am requesting all of you, particularly engineers people, you go there and see. After 26 years, the expansion joints are perfect. And if I can ask question to my DG and secretary, you show me a bridge where expansion joints are perfect. You tell me, you show me where is it. You can't see. Everywhere there is a problem. Actually, 3 days before I was in Jammu and Kashmir. Yesterday I was in Haryana. Today I am in Bangalore. So everywhere, yesterday, I was on that Dwarka Express highway. And that is to be the state-of-art project, a beautiful project. I don't know, but the project designed in such a way that it is very much pride to the country. But at the same time and the time of the expansion joint, when I was about to travel from that road, my opinion, I just asked to our engineer why these expansion joints are not perfect. I never understand what is to be a problem. Somewhere 101% perfection, no compromise. The habit of making compromises is very bad. Actually, if you are going to neglect that, that is going to be happen like that, a spark neglected, burn the house. So I feel that everywhere there should be 101% perfection. And ultimately in government, I don't know what the reason, but the people are now making a lot of compromises. So today we have world record, 7th world record. And now I am seriously thinking that I should have a world record, that how much people I am going to suspend, how much contractor I am going to blacklisted, and I am really eager to do that. I am not going to compromise with anything because the quality is the priority. And whatever the new innovation and research which are available in the world, why you are not going to accept? What this rigidity and conservative approach is creating damages to the future of our country. So I feel that with the World Road Congress, World Bridge Congress, everywhere in different part of the world there are a lot of good things are there. Good standards are there. Good successful practices are there. Why are not making one world code? And whatever the country they feel that they can accept that. Because as far as the quality is concerned, the transformation of knowledge is very important. And somewhere you can take it from them. So I feel that you should have the World Congress in charge is here. And you should think about whatever the best thing in different part of the world, in different countries. You can receive the proposals, and that should be verified by your technical expert committee. And after their satisfaction, you can make that, add into your code. And that can be, any country can use that as their standards. Because time is the most important concern. I don't know what the reason, but starting from consultant to engineers, no one has habit to take the decision on time. And time is the most important capital than technology and financial resources. One, first of all, for giving design, he takes 3 months. After design for correction, again taking 2 months. Why? What is this? Why we should not have a digital management system by which he can approve the things. You never understand what is the importance of the time. I'm very sorry, I don't want to use any harsh language for that. But the people who are getting salary every month, they know that if you're not getting salary just 15 days late, how will it happen to you? So the person who invests money, capital into the project, the bank has already started interest. And there are some people who are not taking decisions 6 months, 4 months, 5 months. What is this? One technical general manager in our ministry in Jharkhand, there was a minister was there, and the road condition was so bad, and the issue was actually very, very unfortunate. We are facing criticism on social media, and when we make the inquiry, the proposal was pending with the general manager technical for 6 months. We immediately take the decision and suspend him. So why this is late? What is the reason? If supposed to be a legal, logical and ethical decision is there, you should take it. Some of the people, they don't want to take the decisions. So IRC is the body which is going to develop all type of new innovations, research, standards by which we can make qualitative infrastructure in the country. So I am really expecting from you that this to be a great thing for us. Regarding using of different material also, that is to be, I am requesting you about lot of new technology I already developed, that is steel fiber. And particularly in the Malaysia, the way in which they have developed that enforcement concrete technology, where we can maintain the quality, at the same time we will reduce the cost. I feel that this is the appropriate time that we should make bridge construction mandatory in precast, because that is going to improve the quality. At the same time, in the road infrastructure, for the heavy rains, we are facing a lot of problem, and I feel that this is the appropriate time that we have to accept the white topping technique. Yesterday, I just signed that file, and where we can make the concrete road, because this is the need of the hour, because lot of roads where we are facing lot of criticism in social media. Regarding the recycled asphalt pavement, soil stabilizer, polymer modified bitumen, glass fiber reinforced steel, and the most important thing is, in the bridges, we need aggregate. My suggestion is, at the time of developing good infrastructure, we are committed for ecology and environment of the society. So we are using now a segregated municipal waste, and in the Delhi-Mumbai highway, the Ahmedabad-Dolero highway, we have just used more than 80 lakh ton of municipal waste into the construction of bridges and road. So that is to be a good saving as far as the ecology and environment is concerned. The use of flash, it is very popular now. Now there is a shortage of flash. We have to request state government and power ministry to give us flash. But in place of flash, if we can use the municipal waste, by segregating that municipal waste, we will get metals, glass and plastic. I have also my own plant where we are making crude petrol from the plastic. And we are adding that crude petrol into diesel in tractor and sugarcane harvester. So my feeling is it can be a saving also. At the same time, we have import of 90 lakh ton of bitumen. And the capacity of Indian refinery is only 50 lakh ton, 45 to 50 lakh ton. Now we have decided to add plastic and rubber, waste tire rubber powder we can add into the bitumen. Just 4 days before, the Indian Oil chairman was with me. I just requesting that you should, with the Central Research Organization, you should formulate the idea and add plastic and rubber, waste rubber, plastic and rubber, waste rubber powder into bitumen and fix up the standard, and where we can save the import also. We are also making bio-CNG and bio-LNG from rice straw. I am the chairman of that association. Today we have 400 projects in the process, 60 already implemented, and they are making that lignant. And 35% lignant we can add into the bitumen. So we can reduce the cost, we can reduce the import, we can protect the ecology and environment. And this type of new experiment, where I will request all office bearer of IRC that they should take the special initiative for that. We have successfully implemented the bamboo crash barriers. It is up to the mark. And bamboo is from the farmers in the forest area. So why we are using this steel? This steel and cement people, they are taking the advantage of the demand. They are making the cartel. You should take the initiative for alternative material where we can reduce the use of steel and cement, and that will be a good thing for them, that they will maintain the price. Otherwise, if the demand is increased, they always increase the price. So that is the reason I will request you that using of bio-bitumen, at the same time, I feel that the glass foam aggregates also, the FRP also has a good technology. I feel that you should have some code for that, and we can give priority for that. And at a time of precast, steel bridges, even we can think about the FRP also. And most important thing which I will request you, that today in the country we have water grid, we have power grid, now we are making road grid. So my suggestion is, the investment in infrastructure is very huge. As a Minister of Road Transport, we have good budget. But now we are using fund, capital from capital market. And that is very important, that when we go for capital market in our InvIT model, the time was prescribed 7 days. But first day within 7 hours, our bond issue was subscribed 7 times more. So today we are assuring the people, poor people, that we will give 8.05% interest, and the people are ready to give us that money, and with their money we can build the infrastructure. The money is not the problem. You can take me how much proposal you have. There is no problem about the resources. The problem is that now we need to find out what are the new revenues which we can get it. Now the idea is we are making roadside amenities. Now at the same time that can be an income source. But now I am doing one experiment in my own city in Nagpur, that is on the ring road of 50 kilometers. We are now starting the bus, electric bus. And we have just about to visit in Skoda in Czechoslovakia, and 18-meter and 24-meter bus is there. And now that bus is charged. The charger is coming. Within a half minute it is charged for 40 kilometers. The Siemens and Hitachi, they have got the technology. And now I am taking initiative that Tata is already having a joint venture with Skoda and Hitachi, and now we are starting that bus. And the cost of the ticket rates we are going to reduce by 30%. The bus will be air conditioned with executive class, with the laptop, everything, with the bus hostess, everything, and ticket rate will be less than 30% compared to the diesel. So now I am planning that we are making big express highway. Delhi to Dehradun, Delhi to Amritsar, Katra, Delhi to Mumbai to Delhi, then Bangalore to Chennai, then ring road in Bangalore also. That is to be a big project. So my idea is we can have a mass rapid transport system. And with NHI, we can give them the right by which they can invest into bus and the technology, and we will get the returns from that. So public will get more comforts. Somewhere it is the time for the infrastructure institutions and authorities to how to get the money back and how we can invest more in infrastructure. We have BOT model, hybrid annuity model, EPC model. We are now already, we can make the EPC mode. We can get the loan from the banks on that 15 years. We can monetize that road. So there is a lot of opportunity where we are getting funds, by which we will increase the pace of road construction. So that is to be very important, that we should have good quality of road. We will give good service to the people. At the same time, we need to find out the new ideas by which we'll get the revenue, and with that, giving more comforts to the common people. So the road infrastructure is very important, and I feel that presently in India, our logistic cost is 16%. And the logistic cost in the China is 8%. Logistic cost in USA and UK is 12%. But because of the Green Express Highway, because of good roads, and using the alternative fuel and biofuel, like ethanol, methanol, LNG, bio-CNG, electric, green hydrogen, and biodiesel, we have now got flex engine vehicles. I am also the transport minister related with this subject, and it is a great pleasure and pride for me. When I taken charge as a minister, the size of industry was 7 lakh crore. Our number was 7th or 8th at that time. Today, our number is 3rd. 3 months before, we just surpassed Japan. And now the first is USA, second is China, and third is India. I am confident that within 5 years, our number will be second. And within 10 years, we will be number 1 in the world in the manufacturing of automobile industry. This is the industry which is already created 4 crore 50 lakh jobs. This is the industry which is giving maximum GST to the state and central government. This is the industry which have got maximum export. So by making good road, we are 100% going to reduce the logistic cost. And all reputed brands of automobile now present in India. Our two-wheeler industry, Bajaj, TVS, Hero, they are exporting 50% of their material. Even all brand in the world now, Mercedes to everyone is here. And now they have decided to export from India. By our scrapping policy, we are going to reduce the cost of components. That is also an advantage to the automobile industry. I feel that the future of road infrastructure is the need of our country, and future of automobile industry is very good. And we have got a lot of opportunity. And for that reason, we have to make the infrastructure of international standard. My dream is to make Indian road infrastructure equivalent to USA. I am confident that with 7 world record, this is really a great credit to our ministry. And this is not my credit. This credit goes to engineers like you who are working day and night for that. I am not a technical man, because actually, unfortunately, in 75, when I was in HSC matric, at that time my admission, my percentage was 52%. Because at that year emergency was started, and I was start work against emergency at that time I was with Jayaprakash Narayan, and fortunately my percentage was actually, because of that activity, I can't get admission in engineering college. Today I receive 9 doctorates, 9 deletes, but still I am not using doctor name, because my 5 deletes are related with the agriculture science, but I don't know too much about the engineering. But my request to all of you, that futuristic vision, futuristic planning, digital management system for implementation, committed for the future research, innovations, research, successful practices as a knowledge, and using waste to wealth, using the waste material into the construction, reducing the cost without compromise the quality. I am 100% confident that people like you who can make miracles. I am really happy that you are thinking on all this line, but you should not be working like a political party. Whatever the resolutions and paper are here, somewhere I will request to you that you should submit your report in the next year, whatever the report you have received, on the basis of that, what you contribute for the sector, what decision you have taken, what policy you are framing. So after that, it can be very useful for the country and for the society. I am really happy that this institution is very important, 90 years old. Your contribution in the development of good infrastructure, your contribution is really, really very great. We are all very much proud of you. And at the same time now, our Indian infrastructure, road infrastructure, is not only recognized in India, but in the whole world. Actually, some days before I was in Australia, the people coming to me, not only of Indian origin, but the foreign origin, and they are insisting me to have a photo with them. So that is to be credibility and goodwill, which we are getting. It is because of you, because of your work. And I feel that the work satisfaction is also a great achievement. I am really happy that your vision, your technological knowledge, your implementation, your strong political will is going to make miracle for this country. One thing I always telling the people that the strong political will is very important. If there is a will, there is a way. And if there is no will, there is only survey, discussion, seminar, committee, subcommittee, and research group. I am sure you are not on that line. You want to implement. And that is the reason that your experience, your knowledge is going to helpful for the future generation, is going to helpful for the future development of our country. Your vision is very important. You can donate eye, but you cannot donate vision. Your experience and your vision is going to contribute for the futuristic planning and development of good infrastructure in the country. I am really happy. I am giving my all blessing to IRC that today is these conventions, and particularly the expert people who are coming from the foreign countries. I am giving my special thanks to them. Thank you very much. Namaskar.
Well, ladies and gentlemen, you would all agree with me. It was highly inspiring, motivating, and thought-provoking. Let's give a huge round of applause and thank for the visionary address from the Honorable Minister, Shri Nitin Gadkari. I would now request the Principal Secretary, PWD, Government of Karnataka, Dr. S. Selvakumar, for words of thanks.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good afternoon to everyone. It's my proud privilege to thank our Honorable Union Minister for Road Transport and Highways for coming all the way despite his busy schedule and attending this important special plenary session and giving his thoughts to all of us. It's an inspiration to all of us. Sir, I thank you on behalf of all the participants here and also on behalf of the Government of Karnataka. I also thank our Honorable Minister for PWD Public Works Department, Government of Karnataka, Sri Satish Jarkioli Saab, for coming all the way and participating in this important plenary session. I thank Sri D. Sarangi, Director General and Special Secretary Morth, for taking all the interest and providing more support to the state government and all of us in organizing this important seminar. I thank you on behalf of Government of Karnataka. I thank Sri S.K. Nirmalji, Secretary General IRC, for giving us the opportunity to host this important international seminar on advances in bridge management, which is an important topic and which is valuable to all of us. I thank IRC and the Secretary General, Mr. Nirmalji, for doing this. I also thank Mr. Nicholas Bardo for coming all the way from abroad and participating in this important seminar. I thank our colleagues from the state government, Sri Satyanarayan and S.F. Patil, for providing all the support for this seminar to be a successful one. I also thank all the international delegates who have come all the way from various countries and participating in this important seminar and providing us an insight into the advancements in bridge technology. I also thank the officers from the central government who have come in large number and giving us full support in this seminar. I also thank our colleagues from the state government for participating in this seminar. I thank all the delegates who are participating actively in this two-day event. I thank all of you. I thank friends from media for covering this event. I thank you one and all. Thank you. Jai Hind, Jai Karnataka.
Thank you, Dr. Selvakumar, for a cordial words of thanks. Now I would request all of you to kindly rise for the national anthem. Please rise.
Hello, check.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मागे गाहे तब जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you very much. We would like to express sincere gratitude to the Honorable Union Minister, Shri Nitin Gadkari ji, Honorable PWD Minister, Shri Satish Jarkioli, and all the dignitaries for gracing the occasion. Now, all of us will break for lunch. We are already behind schedule. So please do come back in the next 30-35 minutes so that we'll start the afternoon session. So enjoy your lunch and see you all in 30 minutes. Thank you very much.
Chairs also
Ladies and gentlemen, welcome back. We are intending to start the session in the next 3 to 5 minutes. I would request all of your friends outside, if you're listening to my voice, please come inside and take your seats. I know we were late for lunch, but then in the interest of time and to hear our experts for a longer time, we are intending to start the session in the next 3 to 5 minutes. So please take your seats. Well, ladies and gentlemen, welcome to session 6, measures for increasing adaptability of road bridges to climate change and make them sustainable, safer, and disaster resilient is the topic of this particular session. I would like to call upon the chair of the session, Professor Ravi Sinha from IIT Bombay. Let's give a round of applause to Professor Ravi Sinha. Onto the stage, please. Yes. He's a professor and former dean at IIT Bombay. He's a civil and structural engineer, more than 35 years of academic experience. He chairs the Structural Safety Sectional Committee of Bureau of Indian Standards, also a member of Bridges and Structures Standards Committee of Indian Roads Congress. He co-chairs the National Panel of Experts of Ministry of Roads, Transport and Highways, Government of India. He's also the head of India delegation at ISO TC 98, which is responsible for ISO standards on design of structures. And he represents India at ISO subcommittees and working groups on resilient infrastructure. Hearty welcome to you, sir, Professor Sinha. Let's give a round of applause and welcome the chair. And our co-chair is Mr. Marcel Kraus from the Netherlands. So put your hands together. The technical manager, the executive agency of the Ministry of Infrastructure and Water Management, technically responsible for the long-term replacement of the Surov Bridge and serves as a senior advisor on the renewal of all bridges in the Netherlands. So those of you, most of us would have visited Netherlands. Those of you who have not visited and who have visited, please give a huge round of applause for Marcel Kraus. Hearty welcome to you. And now I would request the local organizing secretary, Mr. P.B. Prakash, to kindly come over and give away bouquets to both our chair as well as the co-chair. Welcome to you, sir, Mr. Marcel. I would now like to call upon the speakers, PR experts, measures for increasing the adaptability of road bridges to climate change, report by Mr. Gil Hyong-gabe from South Korea. Kamsamida. Yes, please come. Damage resilient bridges in seismic areas, report by Mr. Kazuo Endo of Japan. Welcome to you, sir. And the IRC experts, carbon abatement strategies for bridges by Shri V.N. Hegde from India. Namaskara, sir. Hearty welcome to you. And also effects of climate change on existing bridges by Dr. Lakshmi Parameshwaran from India. Yes. And we also have from Mexico, a bridge retrofitted after seismic damages and compasses by Mr. Luis Rojas from Mexico, the PR expert. A hearty welcome to you. So in the interest of time, I would straight away hand over this session to Professor Ravi. Over to you, sir.
Thank you. So how much time do we have in this session? So do we get the full 2 hours? So I would request the cooperation of the panelists if instead of 2 hours, if we can finish in 90 minutes. Yeah. So maybe 15 minutes of presentation like in the morning session, and so that we have some time for discussions. Okay, so thank you very much. So without any further ado, I would like to proceed with the first presentation. We are very pleased to have with us Dr. Hyung Bae. He works with the Digital Convergence Research Division of Korea Expressway Corporation, where he currently works on developing an IoT-based structural health monitoring system for expressway bridges in Korea and abroad. He also worked as a project manager for developing a digital twin of a cable-stayed bridge. He has a doctor's degree in structural engineering from the University of Texas and 25+ years of experience in bridge construction and maintenance. He is very interested in adopting digital technologies for road construction and maintenance. Over to you, Dr. Hyung Bae.
Oh, thank you. Thank you for a kind introduction. As Chias introduced, my name is Hyung Bae Gil. I'm from Korea Expressway Corporation. Good afternoon, everybody. I'm going to present about measures for increasing adaptability of road bridges for climate changes. This is the work carried out by previous PIAC cycle. So this is my order of presentation. I first briefly discuss about the study background, then I'm going to show the research review results, and then I'm going to discuss about the collection of case studies that we carried out to collect actual climate change cases around the world. And I found out that I don't have any studies from my country and India, so I Googled, and I'm going to show the result from my Google research. And finally, I'm going to give a brief conclusion about this topic. So first, on the start of this month, there was an article in the New York Times, and I was surprised to see this article. The title of the article was "Climate Change Can Cause Bridges to Fall Apart," like a Tinker Toys. I'm not that familiar with the Tinker Toys, but I believe it's easy to broke or easy to fail. This was a surprise to me that the climate change effects is felt by not only the engineering community, but also the general public. So they issue these kind of articles on the kind of prominent newspaper in the world. The article said that extreme heat and flooding can accelerate deterioration of the bridges. I think this is very close to what I'm going to present in this presentation. So what's really happening around the world? I have a result from Europe and United States. As you can see here, according to the European study, we are experiencing the hottest summer around the globe. Also in the United States study showed that the global surface temperature was ranked almost in the 175 year on the record. Typically, the meteorologists say that if the temperature is increased over 1.5 degrees Celsius, it will be a tipping point, and there will be a lot of changes. Unexpected climate changes can really affect the Earth and our lives. So I think we are really near the tipping points as far as these climate changes are concerned. So as I just said earlier, the technical committee of the PIAC 4.2 carried out the study on the measures for increasing adaptability of road bridges for climate changes. The objective given was collect case studies of damage resilient measures and establish criteria for the design and construction of more resilient bridges and search for innovative solutions to extend the service life of the bridges. The expected output was a literature review of the theoretical and some analytical reports on the subject and collection studies through the questionnaires and case study collections. The whole reports can be downloaded free of charge through the PIAC homepage. First, I'm going to discuss about the literature review. We tried to search the literature on the climate change and the bridge. However, we found out that the design code and specification have not specific clause or some articles or specification about the impact of climate changes. So it does mean that there is no design code to really consider the climate change during the design stage or construction stage. But we found out that the climate factors such as temperature change, salinity, sea level rise do really affect the bridge behavior that we need to consider during the design. Also, as I said earlier, there is limited papers on available on the subject, but there is one report from the European Commission. It clearly shows the impacts and adaptation strategies for bridges. The expected climate impact will be increase in maximum temperature, increased rainfall, and sea level rise. So we can expect some kind of impacts on the bridge side, and some kind of actions or the adaptation measures were provided, such as replace expansion joints, alter design stone criteria, and relocation of the roads and infrastructure near the seashores. We also carried out questionnaires as a part of our study on this subject. we collect case studies through the questionnaires. Some of the questions are such as whether each country experiencing any climate changes, about the concern, whether there is any concern about the impact of the climate change on the transportation system, and is there any different definition of climate change effects on the bridge stock, and is there any impact from the following impacts, such as flood, sea level rise, and etc. And also we want to see whether there is any design codes referring to the climate changes. We collected 19 responses, and there is also some 11 responses from different countries, and we collected 19 case studies. So what kind of climate changes each country are experiencing right now? Mostly each country or the individual countries experiencing such thing as heavy rainfall, flood, extreme wind, and temperature changes. I think these 4 things are most evident climate changes we are experiencing right now. How about impact due to different climate changes? The respondents say that rainfall, flood debris, and temperature change really affects their daily life. Also sea level rise and winter tornadoes also have some effects on their each individual countries. How about impact for the bridges? As you can see through this graph, the extreme rainfall, floods really affects almost all countries, and the wind and tropical storms and high temperature also do affect the bridges. Actions against climate changes. I think countries are trying to save or reduce carbons through some kind of measures, and they do have some government approaches to cope with the climate changes. But as I find out through the literature review, there is no specific bridge design course so far available for the bridge design stages. But most countries are carrying out research programs to deal with climate changes. How about some bridge failures due to climate change? The Belgium submits some bridge failure due to high flood. As you can see, there is a bridge shifted and moved to the lateral side due to debris and high flood. In China, the continued heavy rainfall caused some slope stability issues on one of the abutment, and it moved to the abutment, and there are some problems in one of the bridge piers. And France and Germany showed us that the bridge problems due to strong flood. As you can see, one of the pier was subsided due to flood pressure. And Norway and Japan show us that erosion and scouring problems in one of their small, I believe, small creek bridges. As you can see, there is a lot of debris movement, the rock movement at the base of the bridge. How about my country and India? In Korea, we also experience a lot of floods and high temperature problems. Our meteorological administration defined a new word, what they call extreme heavy rain. When it rains more than 50 millimeters in an hour or 90 millimeters in 3 hours at the same time, we call them extreme heavy rain. But as you can see in this graph, the number of extreme heavy rains really increased over the last decade. When we compare to the 1970s to the 1920s, the numbers are really increased like about threefold. And it creates many problems for the bridges. As you can see, flood level rise, and sometimes bridge failures. How about heat waves? We are really experiencing really high temperatures during this summer. We broke the highest temperature record in the summer, And we also have experienced longest stretch of the tropical nights. What I mean by tropical nights is the overnight temperature never goes below the 25 degrees Celsius. So we cannot sleep overnight. We really had a terrible summer, and this kind of high heat waves will create problems on the bridge as well as pavements. There is a many number of bridge expansion joint failures. We also really high number of pavement failure due to these heat waves in the year of 2024. I was really interested in climate change in China, in India. I found out that there was some kind of a roundtable workshop on climate change and just resilience. And I found out that India is also concerned about climate change because India can be a climate change hotspot, and India is also prone to multi-hazards problems. So I believe they are also concerned about infrastructure resilience. And the literature also on Indian climate change and some of the impact show that you are experiencing heavy rainfall, forest fire, droughts, and landslide issues. I think these things are very common to other countries. So finally, my brief conclusion, as I said, we are experiencing a climate change in all over the world. And many countries believe that bridges are also being affected. In particular, the countries recognize bridges are being affected by flooding and the scour. So we need to do something about it, about the flooding and scour. As yesterday, one of our colleagues pointed out, the scour and erosion is one of the most critical factors that cause the bridge failures. So some of the countries also experiencing high wind speed, and the fires and high temperatures. So it is necessary to prepare and revise the current bridge design code in order for us to accommodate these impacts and expect some hazards due to these climate changes. Thank you for your attention. I hope I can finish in time.
Thank you, Dr. Wang Wei. Very interesting presentation. And also thank you so much for keeping to the time. Thank you so much for keeping to the time. So we move on to our next presentation. We request you to write down your questions and send to us, and so that we can take up the questions at the end of the panel. We move to the next presentation. This is by Dr. Ando on the damage resilient bridges in seismic areas, a report.
Thank you, Chairman, for your introduction. My name is Kazuo Endo. I'm from Honshu Shikoku Bridge Expressway Company in Japan. Today, I'd like to talk about damage-resilient bridges in seismic area. I had worked on this issue as a co-leader in the previous cycle of PIAC activity. The leader was Dr. Dimitrios from Switzerland. He is absent today, so on his behalf, I'll give a presentation. Okay, here is the index on my presentation. First, I'll talk about the two documents produced by a committee, and then I will focus on the retrofit technique for increased seismic resilience in terms of the prevention of unseating and retrofit of piers and seismic isolation. And then I briefly mention about the methods for prioritization of bridges to be retrofitted. And finally, I will end my presentation with a conclusion of technical report. For the issue damage-resilient bridges in seismic area, our committee published two documents. One is a collection of case studies which are collected from the member countries. And the other is a technical report which analyze and synthesize the collected information. These two reports are posted on the PIAC website, so you can download these freely. And we got answers from 11 countries like this, mainly from the earthquake-prone countries. And general questionnaire is composed of two parts. First one is the general questions with regard to the existing design code and the standard, as well as the retrofit strategy and technique. And the second part is a case study with regard to the retrofit example of existing bridges. And as for the general part of questionnaire, we got 14 responses. And from France and from United States, we got several answers. And as for the case studies, we got 16 responses in total. And first, I'll talk about the retrofit technique for increased seismic resilience. First one is about prevention of unseating of superstructure in piers and abutment. According to the survey results, all 11 current codes that responded have provision regarding a fail-safe system which prevents catastrophic failure for unexpected loads or conditions. And the most typical example to provide enough seat length and to install restrainer. This lower photo is an example of restrainer in longitudinal direction. Left-hand side one is an example from Japan. Many cable restrainer connects girder and abutment. And right-hand side photo is an example from Portugal. This is a seismic connector, a damper. This is used as a restrainer at the Gelba joint. And this is an example of Switzerland, shear key in transverse direction. In this type of bridge, seat width in transverse direction is small. So in order to prevent the unseating in transverse direction, these red color members were additionally installed. And another common technique for prevention of unseating is the seat width extension. Left-hand side photo is the extension in longitudinal direction from a case in Chile. I think this is a common example. We can see many cases like this. But the right-hand side photo is not so common, I think. This is an extension in transverse direction from a case in Japan. This bridge was reconstructed after large-scale earthquake in 2016. And this bridge was located crossing over the active fault, which moved laterally in the earthquake. So in order to prevent the unseating in transverse direction, in case of unexpected future lateral ground movement, we install additional seat widths in transverse direction. This is another concept for prevention of unseating of superstructure in piers and abutment. Based on the historical data in Japan, all girder unseating events did occur in multi-span simple beam type like upper right photo. So when a large-scale retrofit program is planned, it's a good idea to examine the possibility to convert the multi-span simple type beam to continuous beam types over intermediate piers by connecting wave plate like lower left photo. And this is about the retrofit of RC piers. There are three common methods, RC jacketing and carbide sheet jacketing and steel plate jacketing. And each method has its own characteristic. So we should select the proper method based on the bridge conditions. Besides, we need to consider the interaction of three structural properties, stiffness, load-bearing resistance, and deformation capacity. Generally speaking, the balance between bearing resistance and deformation capacity is important. Too much bearing resistance or too much deformation capacity is not good. Proper balance is important. And as for the stiffness, RC or steel plate jacketing may increase the stiffness, and which lead to the increase of inertial force due to the decrease of natural period. So we should select the proper method based on the comprehensive evaluation considering these properties or characteristics. And this is about the seismic isolation. This technique could be effective in some cases. And this diagram shows the concept of seismic isolation, elongation of natural period and increase of damping to decrease the inertial forces. This method may allow the structure to remain elastic or quasi-elastic, maintaining the functionality after the seismic event. But this method have some disadvantages. It may be costly in short term, and elongation of natural period would lead to a large displacement, and which result in the intervention in expansion joint. This case study is from my organization. Seismic isolation method was applied to steel truss bridges. This truss bridge is dual for highway and railway. Upper deck is for highway and lower deck is for railway. Seismic vulnerability assessment shows that red-colored member got damaged during a large-scale earthquake. But strengthening of this red member is impossible to secure the safe railway operation. So in order to avoid the retrofit of this red member, we apply the seismic isolation method. Existing steel bearing were replaced to a new isolation bearing, which is a laminated rubber bearing with built-in lead plug. And the next is about the methods for prioritization of bridges to be retrofitted. The method can be categorized in two ways. First one is a case-by-case analysis. Seismic retrofit determined by the case-by-case basis and examined in the frame of an important rehabilitation program due to aging or upgrading. And this method is mainly used in countries with low and mean seismicity. And the other one is the use of decision tree process. This method is mainly used in countries with high seismicity. And this flowchart comes from the Spain. Seismic retrofitting prioritization determined based on the seismic score in terms of seismicity, bridge importance, and vulnerability, and susceptibility. Okay, here is a conclusion about the seismic performance, existing bridge, and related code and guidelines. The country with moderate and high seismicity that responded have sufficient and up-to-date codes to support the seismic evaluation and retrofit of existing bridges. And the improvement of seismic codes has increased considerably the safety level of road bridges. And the evolution of related standards is continuing and progresses thanks to the knowledge obtained after a new seismic event and due to seismic scientific development. And the seismic evaluation of existing bridge may take into account the remaining service life, resulting in less severe requirement in comparison to the new bridges. And the several levels, the right-hand figure shows the seismic performance level depending on the performance level, like fully operational and life safety and collapse. So that guideline and standards provide a methodology for selecting the appropriate level of the performance. And the next is about the seismic retrofit strategy and the techniques. Of the countries that provided responses, only a few of them have concluded seismic evaluation of their entire bridge inventory and have identified the assets which have to be prioritized for retrofitted. And for the rest, the exercise is still ongoing. And there are a variety of effective retrofit methods. And there are no general seismic strategy because each bridge is a unique structure. So seismic isolation, like upper right photo, is not always a good solution. And provision for unseating found in all seismic codes. Due to its importance, measures for unseating are often redundant to significantly mitigate the risk. And we can take into consideration the effect of soil structure interaction. In case of upper right figure, backfill soil can be used as a resistance. And as for the prioritization of bridges to be retrofitted, we need to consider the resilience of the road network and all possible alternative routes. Okay, that's all my presentation. Thank you for your kind attention.
Thank you. So I missed introducing him at the beginning. Dr. Ando, he has been a senior director of corporate planning department, Honshu Shikoku Bridge Expressway Corporation Limited in Japan since 2023. After he entered the company, he has been engaged in the design, construction, and maintenance of long-span bridges. He holds bachelor's and doctorate degree from the Osaka University and Master of Science from University of Texas at Austin, all in civil engineering. So we have two University of Texas speakers over here today. We move on to our next presentation, which is going to be given by Mr. V.N. Hegde. He is the founder and CEO of Decon Complete Solutions at Mumbai. He is a recipient of around 16 national recognitions in addition to an international prize from IABSC and fellowship from FIB. He has more than 205 publications, including papers in journals, conferences, proceedings, and chapters in guidelines to his credit, and is a member of various IRC committees. He is also a fellow of the Indian National Academy of Engineers. Mr. Hegde, please.
Thank you very much, Professor Sinha, for that kind presentation, introduction. And I've got a challenge in front of me because I'm going to talk about the carbon neutrality and sustainability. Generally, it's a dry subject. And not only that, I've got a time constant also in front of me. I was told that I'll be having 30 minutes, but it's going to be shortened. Perhaps the presentation is prepared for 30 minutes, but I will make sure that I'll be able to adhere to the timeline as has been adhered by the others. I just want to tell you that almost a month back, I had an opportunity to talk in Bridge 24, which was very successfully conducted in Bangalore, on the climate change effects on the bridges. In fact, that is a sequel to this presentation which I'm going to talk today. In fact, this presentation is about carbon neutrality in the bridges, how to achieve it. Just to give a background of that, most of the people are aware of it, perhaps. Why there is a requirement of carbon neutrality in the environment. As you can see here, up to the pre-industrial era, as you can see, that the global average temperature was hovering around, fluctuating around 0 degrees centigrade, but since then it has risen up to around 1.6 and 1.8. Last year it was reported in India, basically. And we are in the emergency period of the climate emergency from 2000 to 2050, as you can see here. If you don't peg it down now, what's going to happen is the temperature is going to rise. The manifestation you can see on the right side over here. why this climate changes or the temperature has to increase. It is because it has a direct relationship, as you can see here. The carbon dioxide concentration in the environment, as you can see again, up to the pre-industrial era, it was around 200 ppm, which has risen up to 450 to 500 ppm now. Unless we peg down or maintain this, this carbon dioxide concentration in the environment, this temperature is going to go down. So all of us agree that we are in a situation of the carbon emergency. It is just a slide. I'm just going to rush through this because I just wanted to say that India has contributed around 7.15% of the carbon dioxide, almost around 7.15% of the carbon dioxide emission to the environment. So totally, we have almost 36.3 gigaton of the carbon dioxide, as you can see here, out of which the built environment alone contributes around 42%, as you can see here, as per the latest 2022 evaluation is concerned, out of which the operational carbon in the building emits around 9.9 gigatons, whereas the cement is 2.9 gigatons and the steel is 2.14 gigatons, others being around 0.36 gigatons. So it puts on an extra onus on we civil engineering fraternity to see really to control the carbon dioxide emission to the environment. Now, as all of you are aware of it, the COP 26, particularly which took place in Glasgow, we gave all the world leaders had to give the declaration as to how to reduce the carbon dioxide emission to the environment and achieve the carbon neutrality. We also give the 5 panchamritas, what we call it as a panacea, 5 panacea in that particular this one. There are 3 types of carbon dioxide actually, which is getting emitted, as you can see here. The one is the capital carbon, operational carbon, as well as the user carbon. Since we are talking about the bridges, I'm going to demonstrate to you that the operational carbon is almost negligible, while in the building is quite high, whereas the user carbon in the bridges is quite considerable, 25 to 26%. That we are going to discuss here. Whenever we are talking about the carbon neutrality, first of all, we'll have to understand the whole life carbon. As you can see here, whole life carbon for any infrastructure, including the bridges, it will be divided into 3 phases. As you can see here, up to the before the use stage, in use stage, as well as the end of the life stage. Ultimately, we come to this D module, which is called as the circularity model, which we're going to discuss. This is also earmarked by what we call it is a boundary system, that is the cradle to gate up to the product stage. It's called the cradle to gate system boundary, cradle to completion, cradle to grave. It's up to the end of the life of the bridges, in particular when we are talking about when it is again used, recycled, reused, components are used, it is called the cradle to cradle, as you can see here. So now we are coming to after having understood the importance of the carbon neutrality in the environment, net zero emission in the environment, I have tried to define here what is the carbon neutrality. How do I define the carbon neutrality? It is simply carbon neutrality is a process where carbon dioxide emissions are brought to net zero by avoiding, reducing, and setting up those emissions which cannot be avoided and reduced, which I have represented by a model called what I call it's an years model here. The definition is encapsulated in the model which I've given over here. Now, the first step in the model is to estimate the carbon dioxide emission. I will straight away go to the how do we estimate. As I said that the before use carbon dioxide is there, carbon emission is there, in use carbon emission is there, as well as the end of the life carbon emission is there, as you can see here. And how do we estimate the carbon dioxide in A1 to A3 module? That is called the product stage module, as I explained earlier here. This is the product stage module. You can see here, this is the A1 to A3, where the material production takes place. Excluding the construction, it is called the product stage. It is the construction stage, basically. In this it's very simple. We have a carbon factor. Say, for example, cement is emitting around 0.8 ton carbon dioxide emission to the environment for the production of 1 ton of cement. That is multiplied by the quantum of the cement. that gives the carbon dioxide emission to the environment. It's as simple as that. So we'll be having a different carbon factors for all the construction materials, especially in the bridges, expansion joints, perical, fuel, and the surfacing. Everything will be having the carbon factor like that. That carbon factor will be multiplied by the carbon, the quantum which has been used. That's how you'll get basically the carbon dioxide emission to the environment, as you can see here. In construction stage, that's the model which has been represented by the A4 to A5. The estimation is very simple. In the construction, how the carbon dioxide emission takes place. Basically because of the fuel consumption of the plant and equipment which has been operated, and the wastages in the material, as you can see here, wastages takes place, and the use of enabling and temporary structures. This is basically emits the carbon dioxide to the environment during the construction stage. That is how it has been calculated during the construction stage. Now, in use stage, I think particularly, I think our guest from Korea talked about this, the resilient structure. That is where we have to talk about it, basically. In new stage, carbon dioxide emission takes place because of the maintenance of the bridges. Bridges designed for the 100 years over here. We'll have a regime, maintenance regime, as defined over here in the right side. Because of the maintenance, during the maintenance period, how much? And it's very alarming to know that most of our bridges is lasting only for the 34 years. Bridges which has been designed for 100 years, if it is last for 34 years, I think it has to be totally replaced, or the capacity augmentation is required. Carbon dioxide spiking takes place over here. So that is the reason in use stage, all over the world, almost around 60% of the carbon dioxide emission takes place in the whole life carbon in the in-use stage. And it's a challenge really to see how to control this basically. So the carbon calculation after the end of the life stage. You know, once we have already completed over here, the estimation of the carbon dioxide in use, as well as the before the use stages, we come to the end of the life of the bridges. After 100 years, it's supposed to be the end of the life. Simply, it is, you will have to dismantle it, you will have to transport it, you will have to use it as a landfill or recycle it. All for that processes, the carbon dioxide emission takes place. This is a very simple calculation. There's nothing rocket science in this basically. That has to be done. Once this dismantled materials, suppose it's a component itself is dismantled, and if it is used for the new construction,
you
basically
have 5 more minutes.
5 more minutes. I think I'll stop here itself because not going to possible to finish in 4 minutes. So that's how it is. Now I've just given an example of the how to calculate do the carbon estimation over here. Carbon calculation for the cradle to completion for 2 of the examples you can see here. This is one of the example of the Exodus cable stay bridge, which I did the quantities for the Vikram Shila brick. It's a multi-spire Exodus brick. Quantity calculation was there. And also I did the calculation for the carbon footprint for this up to the cradle to completion. That means up to the completion of the construction you can see here. If you really look at it, if the carbon dioxide emission which has been taking place, if you really look at it, for an Exodus bridge per square meter of the concrete deck with the concrete superstructure and the concrete pylon, 2.5 ton, 5.8 ton carbon dioxide emission per square meter of the deck is taking place, including the foundation. Foundation has the well foundation over here. In case of the signature bridge, which has got a steel pylon, as well as the steel deck, it's almost around 5.18. Here, primary steel is used, not the recycled steel is used. Almost double the carbon dioxide emission takes place if you're really going for the steel structure at the current, present state of the technology we have. So, if you apply in the concrete itself almost around 92% of the cement carbon dioxide emission comes from the concrete, as you can see here, 92%. In these 2 bridges, when you did the analysis over here, for the concrete deck superstructure, 92%, 91.36% of the carbon dioxide emission takes place only because of the steel and cement. And in case of the steel superstructure, 96% of the carbon dioxide emission takes place only because of the steel and cement. So in my opinion, in case of the bridges, basically achieving the carbon neutrality in cement and steel is analogous to achieving the carbon neutrality in the bridges itself. It's as simple as that as far as I am concerned. So we'll have to achieve the carbon neutrality. Now, we have, go to the next step. Is it possible to avoid the carbon as per the next step? And complete avoidance of the structure, bridges itself, it's impossible because social sustainability as well as the economical sustainability, as has been explained by our Nitin Gadkari also today in the morning, it's very, very important to have the structures, bridges. And it's not possible for us to really avoid. But it is possible for us to avoid the cement and steel completely in the construction of the bridges. And also perhaps the avoidance of non-renewable energy consumption in the construction and operation completely is possible, as you can see here. This is one of the examples where cementless steel, cementless concrete is being used, and also the FRP bars we have been talking about, FRP bars, even the PT bars which has been used over here is made up of that aramid strands, aramid PT bars. If you completely avoid the cement as well as the metallic reinforcement, whether it's in the form of the strands or whether it's in the form of the reinforcement, it is possible to bring down the carbon dioxide emission in this bridge girder from 1.3 to 0.4. That means almost 70% reduction in the carbon dioxide emission to the environment, as you can see here. I'm just running very fast. Avoidance of non-renewable energy sources, all of you are aware, it's possible for us to completely avoid that by going to the like the solar energy, biomass energy, etc. It's possible to do it. Now come to the third step in our model, that is the carbon neutrality model. And it is basically, if you really look at it, by reduction of the OPC content in the unit volume of the concrete for the concrete structure. But I think Nitin Gadkari also said that it's, fly ash as well as the slag is not available in plenty. Perhaps I think we'll have to go for the limestone as well as the calcined clay, which is available in abundance in the world. I think we'll have to go for the pozzolanic replacement rather than fly ash as well as the slag, which is easily available, but only the 15% is available for the replacement in the future. Everybody is using it already. So this is about the calcined clay. Reduction of the waste-based product composition and the upgradation of steel. See this particular trajectory, if you see here, the world is reducing, trying to reduce the carbon factor from 1.9 to 0.1 in case of the steel. It's by 2050 in phases, of course. And the cement carbon factor is supposed to be brought down from 0.6 to 0.03. That is the target which has been given by the world body, and that is what the basic material industry carbon emission intensity trajectory has been projected by this one. By improving the production process itself, I don't want to spend much time on. In fact, as far as the cement production, achieving the carbon neutrality during the production of the cement, I think Dr. S.B. Hegde is the right person to talk much in detail. Some of the ways of doing during the production is improving the emission control by upgrading the plants, improving product formulation, replacement of optimization of the combustion seal, gas balancing, etc. Of course, another very important thing is the waste heat recovery system that could be applied to both the cement as well as the steel plants, as you can see here. Reduction by intervention during the service life. That is, during the service life, I think we can use the steel, stainless steel in case of the steel structures, and we'll have to go for the performance-based design, and to make sure the less intervention is required, it should last more than 34 years at least, It should be lasting for the 100 years. That we'll have to see, basically. And also the climate change effects, I think Dr. Lakshmi is going to talk about it. I think the effects on the structural action has to be taken by the probabilistic models which has been there. Basically, the climate adaptation studies, as I explained to you, it's an interesting slide. Validity of the design code is only up to the 2000. After that, climate change effects have taken place. For that, the design codes have to be completely changed after the 2000. Even now, the design codes are meant for the climate ambience, which is there up to the 2000. 2000 onwards, the climate change effects have started taking its toll. So that is the reason we'll have to really look at this on the, like the load factor side, on the action side, as well as the safety factor side, on the strength side. I think we'll have to really look at it, and all these factors have to be really reworked on the basics of the climate change effects. Reduction by policy making, I think these are the Basically, the policymakers are owners, constructors, suppliers, and designers. They play a very, very important role. And environmental product declaration for the construction materials.
Request you to conclude.
It will not be complete otherwise. Just give me a couple of minutes. I'll just rush through it. And the QCSBS procurement system, what I'm talking about, quality, cost-based, sustainability-based procurement system, we'll have to really look into that. And the standards and code makers have to tighten their belts and to make sure it has to be sustainability-oriented. And there are a lot of problems as far as the standards and code. This one is concerned. This is one of the bridges, that said that the vicinity of the foundation should be the same as that of the new foundation. By insisting that in the arbitration, the contractor lost the case. It was design was completely satisfied. There was one sentence that the vicinity of the foundation has to be there. That's why it was insisted upon. That ended up with the carbon dioxide emission of 5,533 ton carbon dioxide emission, in addition to the time overrun as well as the cost overrun for the government. 35 to 40 crore rupees they ended up paying as far as this. So this is some of the issues we'll have to address in the courts. Basic external pre-stressing with the dry joints. That is somehow encouraged. By going by that, by the epoxy application, if you've got 10 kilometer viaduct, as you can see over here, it's almost 5 crore rupees additional and 385 days more if you are going for the epoxy application for the 10 kilometer viaduct. I think we'll have to improve our all these things and go for the double-decker. Imagine a case, this is a Trans-Harbor project we appreciate quite a lot, 24 kilometer. It should have been done for the multimodal transportation system, like in China and so many other places which is taking place. And another agency, metro or railway will come, they will construct another 24 kilometer over there. That could have been done on the same foundation as well as the substructure. That could have reduced the, there's an interaction requirement is there between the different departments. I'm just, the mandatory green certification for the site officers and the labor officers. I just want to, the carbon value engineering has to be done the way we do the value engineering for economization. Cost control is concerned. Some of the design efficiency measures, these are some of the, high tensile steel with the ultra high performance concrete. We can go for that. Steel is a highly sustainable material. We should go for that, but we'll have to make sure recycled steel is used. Otherwise, the carbon dioxide emission is quite a lot as far as the steel structure is concerned. It increases the spanability. All world record holding structures are the, in terms of the span is made up of the steel, as you can see here. It can be beautiful, aesthetically very good bridges can be made. Stainless steel, weathering steel. In fact, weathering steel is an invention of basically all this weathering steel as well as the stainless steel will reduce the maintenance cost during the in-service service stages. As you can see here, steel structure, as I think Alok explained, that the accidents during the construction in the steel structure is quite comparable as less. Reduction during construction stage, I will not talk about it because Professor Sinha is not allowing me. Last step in the model is the setup. Basically, how do you? What we cannot reduce, we can set it up by, the circularity, by modular or pre-engineering construction. This can be dismantled at the end of the 100-year service life, and it can be reused. When you reuse it, all these things, even externally pre-stressed, dry-jointed segments also can be reused after the 100 years usage. Basically, that way it is possible for us to reduce the carbon dioxide by circularity, which cannot be avoided by circularity. We'll have to go for the CCUS, as you can see here. And the roadmap to carbon neutrality, I've got only 2 slides. Professor Sinha, don't worry about it. This is for the steel. I told you, achieving the carbon neutrality in the bridges is nothing but achieving the carbon neutrality in cement as well as the steel. In my opinion, that can be done, as you can see here, by bringing down the carbon factor in the cement from 0.8 to 0.3, you'll be able to reduce by 56%. By decarbonizing energy during the construction, even 50% you do that, 10% reduction is there. Balance can be reduced by the design efficiency, setting of circularity, as well as the setting of CCUS, as you can see here. Final slide is that for the steel also the same thing. Like the product formulation and the plant upgradation, steel carbon factor, if it can be brought down from 2.5 to 1.5, we'll be able to reduce by 36%. Decarbonizing energy during construction, 5%. design efficiency 10%, setting up by circularity 35%, setting up by CCUS 13%. The world-wide, as far as the cement is concerned, they're talking about CCUS achieving carbon neutrality by 36%. I am suggesting only 15% is required. It's not necessary for us to go for the CCUS by 36%. With this, though I have taken a little bit more time, I hope that I have done justice to my presentation.
Thank you very much, and sorry for rushing you. I know so much effort has gone into this excellent presentation, so really sorry to rush you through it. Thank you very much. Our next presentation is by Dr. Lakshmi Parmeshwaran. She is a former chief scientist at CSIR CRRI in New Delhi. And she is an eminent researcher with more than 37 years experience. She was a faculty at AXIR. She holds a PhD in civil engineering from IIT Roorkee. She has been actively contributing to the formulation of bridge design standards and guidelines by IRC and BIS. She is a recipient of Boycast Fellowship for research in the area of disaster mitigation from Department of Science and Technology in India, and was a visiting scholar at Johns Hopkins University in the US. And she has been affiliated with several IRC committees and is responsible for a number of important activities in IRC. Dr. Lakshmi.
Thank you, Professor Ravi Sinha, and my fellow panelists, distinguished delegates, ladies and gentlemen. Thank you for giving me this opportunity to share my views on effect of climate change on existing bridges. And the agenda for this presentation is climate change induced environmental effect, where I'll be focusing more on India, because we have already seen what is happening all around the world, and significance of climate change on design of transport infrastructure, because we cannot isolate bridge from the road network, and also these road networks are very much essential for disaster mitigation activities, and how climate change is going to affect the performance of existing bridges. And quickly, I'll be focusing on adaptation strategies and mitigation measures so that we can have safe bridges. And climate change is not only affecting like our infrastructure, but also health of people, and also agriculture, and also a country like India, we have to worry about our economy, and we are developing the road network. So we need to pay more attention about the maintenance of structures because we have limited resources. So coming to climate change, I think we have already seen. So I will quickly go through this, some of these slides. So any change in climate over time, whether it may be due to some natural variability or as a result of human activity, that is called the climate change. And there are human-induced activities which can cause this climate change as well as natural action. So if you see this particular slide, you can see that there is a reduction in biodiversity or urbanization or deforestation. These things have changed to changes in the vegetation, and also like our agricultural lands are being converted for industry, and that is also one of the human activity. And these industries, they emit a lot of gases like carbon dioxide, sulfur dioxide, nitrogen oxide, etc. And also, like with industrialization, like the traffic is also increasing. For example, in Delhi, 20% of the land area is for the roads. So a lot of traffic is there. And also, like for the production of electricity, we are using the fossil fuels. But slowly we are transiting to solar energy or wind energy. And all these human activities and some of the natural activities that has led to the green gas concentration. We have seen the increase in the carbon dioxide, something like 400 ppm and more. And this has led to the global warming and to the climate change. And we have the Reserve Bank of India. They have prepared a bulletin in 2020, and this is for our country, like what are the major type of occurrence of these extreme weather events. And you can see here that we have, during the period of 1998 to 2019, there are 28 events of flood, followed by storms and cyclones. Actually, India has a vast coastal lane, both on eastern coast and western coast. So earlier, we were having more cyclones in the eastern coastal lane, but because of the climate change, we are experiencing more number of cyclones in the western coast also. Then unseasonal rains, and because of that flood and landslide, I think Kerala, that suffered a landslide, and one of the village, they lost something like more than 300 people recently in the last month. Then heat wave, some 7 number like that, drought and other flash flood and cold wave conditions, etc. And if you see that, like how they are occurring, maybe some years like we have some 10 events, and in other something like 4, 5, etc. That means every year we are having more than one of these extreme events happening. And Indian Meteorological Department, they have defined these extreme events as snowfall, lightning and storms. Like we used to get lot of thunderstorms, and that frequency of these thunderstorms, they have also increased, and that heat wave condition and cyclones. For example, as I said that the western coast, they have more number of cyclones, and we have recently one important bridge, Dwarka Bridge, which has come in Gujarat, in the state of Gujarat. And during the construction of that particular bridge, that was subjected to 4 number of cyclones. So you can imagine the activities which are increasing, especially towards the extreme events. And how the Indian Meteorological Department has defined these extreme events. That means the heat waves, basically, that is if there is a departure of a maximum temperature from 4.5 degree to 6.4, that is called the heat wave. And a severe heat wave means it is more than 6.4 degrees centigrade. Similarly, for the heavy rain, like 64.5 to 115.5 in 24 hours, very heavy rainfall, extreme rainfall, that is more than 204.55 millimeter. Similarly, like some of these states, they have cloudburst, so where very heavy rainfall with more than 100 millimeter per hour. Then we have the northern India that is experiencing the cold climate, and cold days are also there, and now like we have cold waves also there. That is for number of days, the minimum temperature will be lower than the 6.4% normal. So we have all these extreme events which we are experiencing year after year. Then now we can see that like the major cyclone and heat-prone states. So you can see that the dark color marked here, like, where is the pointer? Basically the state of Tamil Nadu, which is in the eastern coast, that has number of cyclones. Similarly, Andhra Pradesh, Orissa, West Bengal. In fact, this year also we have one in the West Bengal coast. Then the Gujarat coast also experiencing the cyclones. And heat wave also, like we have in the eastern coast, like 3 states, like they are prone to the extreme heat wave condition. So this shows the average annual temperature volatility, and you can see that the mean annual temperature and also the average annual temperature, average temperature during 1971 to 2000. In fact, for the design of bridges, like we consider what is the maximum temperature, minimum temperature, and what is the thermal gradient which we have to consider for the design during the night time and also during the daytime. And we consider for the wind like a return period which has to be considered for these events like that. But the temperature volatility also you can see how much it is in this particular chart. Similarly, like as I said that the Gujarat is the state which is subjected to cyclone. It is not only subjected to cyclone but also flood prone. At present we consider that only one major event may have to be considered, like for example maybe cyclone or the earthquake for our design. But I think slowly we will have to move towards considering the multi-hazard for our design, because the same state is subjected to flood, it may be subjected to heat wave, it may be subjected to like your cyclone. So some of the other states, they are also subjected to the hailstorm prone states. So these are some of the projected changes because we have in the northern region like our mighty Himalayas. So there also there are changes in the temperature and also in the air temperature and also in the annual precipitation there is a change. And there are different models which are available, that is this RCP 4.5, which is described by IPCC as a moderate scenario in which the emission peak around 2020 and then like it decline. That is what we expect, but that is not happening. So if we go for by RCP 8.5, that means that there is a continual rise in this climate change even after 2020, and these models can be used for further in analysis and also find out what is going to happen to these structures in the coming years. So why this climate change is important for transport structure? And I think we have seen many of these with some photographs, etc. But basically it is going to affect
Five more minutes.
Okay, road pavement foundation, and also it may affect the drainage system, our embankment, and even the road surfacing also may be subjected to cracking, rutting, and increase wear and tear. So it is not only like the bridges, but also the road pavements also is going to get affected. And we have already seen a nice photograph that the bridge expansion joints that will be affected because of the change in the temperature and also because of the flooding and other phenomena. Also like the drainage system is going to get affected, and there could be like more floods and also landslides, slope failures, damage to roads and bridges. And the net effect of the climate change impact on the existing bridges that is given in this particular figure. So you can see that the indicators of climate change, one is that the carbon dioxide concentration is rising, precipitation is increasing, and that is leading to higher flood, higher risk of collapse and settlement, higher risk of soil liquefaction, and also higher hydrostatic pressure behind the abutments and retaining wall, and insufficient capacity for the drainage system. Similarly, for each of the activities like the higher temperature, that is because of the solar radiation increase, and there could be more higher thermally induced stresses. So there are many effects like which we have seen in the previous presentation also on the existing bridges. So if we classify them, just like how we classify the damages or distresses what we see when we inspect the bridges, if we classify the climate change impact, we can have not sensitive, low sensitivity, moderate sensitivity, and high sensitivity. So if we, high sensitivity means permanent or extensive damage that is likely to happen and which require extensive repair. So we have like large scale bridges and small scale bridges, and you can see that all of them are sensitive to the climate change, and you can see that the moderate is the orange color, so extreme heat like that is going to affect the large scale bridges. Similarly, storm surge, sea level rise, and damaging storms, they are all affecting. So, but if you see the flooding, and we have seen that our country, the floods are going to be one of the most prominent event. So that is going to affect both large scale as well as the small scale bridges. And with respect to the material which we use for the construction also, like we can see that like there are certain, that is the brown color, that is the extreme effect. And you can see that mostly in the road bridges we use concrete and also metals. And also there are certain coatings and polymers which are also being used. But all these materials, they are subjected to the climate change effect. So the accelerated material degradation, that is one major concern for us, because as I said that we have vast coastal lines, and also otherwise also like our bridges are subjected to corrosion because increased precipitation, the relative humidity is also changing, and higher carbon dioxide concentration, so carbonation effect on these bridges that are there. And also, like yesterday, we have seen that the increase in the lowering of the pH. I think Mr. Jayagopal has explained that. But again, like the climate change can also lead to the reduction in the pH, and because of which, like we can have more, you can say, corrosion of the structure, and the corrosion can be either due to carbonation or it can be due to chloride attack. And the pavements are affected. Similarly, we have some railroad bridges, so the rails are also subjected to higher temperature, and they are subjected to buckling and also thermal expansions, etc. They are there. So I think this is what I said, that the models which we can be used, they can be used to find out what is going to happen in the future. So there are some numerical simulation which predicts that the climate change that will totally submerge two bridges like in Canada, that is in one of the research, like they have published it like that. So there are certain mitigation measures which are required, and one move towards what we are doing is adapting these electric vehicles in our country, and also the renewable based electricity projects, and Mr. Hegde has explained so much about it, so I am not going into it. We have one IRC SP 133 that is on guidelines for reduction of carbon footprint on road bridges. So this I have already explained, that the temperature rise and change in precipitation, and also more greenhouse gases that will increase the carbonization, as well as chloride ingress and also chloride attack. So now what strategies we can adapt? Basically accelerated degradation material, that is by protection, by design, that is increase in the cover thickness, improve the quality of concrete. We can have protective surface coating, barriers, stainless steel.
Please try to summarize.
Yes, yes. Stainless steel, galvanized reinforcement, corrosion inhibitors. We can go for like this glass fiber reinforced rebars, etc. And more inspection and maintenance will be required. And like the scour critical bridges may have to be identified, and also we will have to do more inspection and see that we are able to maintain them. And I'm not going into detail, but there are two aspects, that is the mitigation aspect and the adaptation that can be done. So for heat-induced damage pavement, we can have this polymer modified bindings or heat-resisting paving materials, etc. can be used. And also more expansion joints in pavements, rails, etc. may be required. Increase long-term deformation of bridges, again, periodic inspection. So we may have to review our guidelines and see what has to be the frequency for such bridges. And it is not that a countrywide specification will be suitable, but we may have to move towards a regional region-based specification for such things. So flooding, again, how we can protect our bridges, and also drainage capacity, what we can do. And another is the wind-induced loads, where many mitigations measures can be done, and also some dampers, geometric modification, dampers, or structural modification, etc. can be done so that we can make them safe. And increase cover rate, using of riprap or partially grouted riprap, and gabion mattresses, sacrificial embankments, all such things can be done. These side slope failures, landslide, foundation settlement, rock falls, these are also some of the other impact and the potential measures, adaptation technologies I have listed here. So a way forward, that is climate change induced environment effect, needs to be studied at regional level, because even in our country, there is a diversified climate we have. Rather than using a return period concept, we may have to move towards non-stationary, time-varying action that needs to be considered for the design. Climate change impact assessment studied for road projects, including bridges, that needs to be done, and carbon footprint estimation, that we are making it mandatory for our bridges. And already the guidelines have been prepared, and adopt appropriate adaptation strategies to enhance the performance of the bridges. And we need, just like we have a guideline for the road projects, we need one for reducing the climate change effect on bridges. There, three aspects needs to be considered. One, what are to be considered during the design, and what are to be considered during the construction of the bridges, because sometimes the construction period of the bridges goes longer. And the third is how we can protect our existing bridges. So these are the way forward from my side. Thank you for the kind attention.
Thank you very much. Again, an excellent presentation, and sorry for asking you to cut your time. We have an online presentation now. Okay, thank you. Yeah. Oh, he's here. Okay, great. So we have Dr. Royas Neetu from, he is at the Civil Engineering from the Monterrey Institute of Technology with honorable mention. He completed a master's degree in structures at the Higher Institute of Reinforced and Reinforced Concrete in France, and a diploma in project management, as well as various professional courses and in bridges and structures. So Dr. Neetu.
Thank you. It's a pleasure to be with you. And now we go to Mexico. What happened in Mexico with the climate change, with the hazards of risks? We know the risks that we have in our country. Gilles say, we need evaluation and recommendations of the PIARC, and to make synergy with other institutes, with all associations, technical associations. Now you can see all the risks, that photos, that videos, there are in Mexico in the last 10 years. risk of slides, risk of inundations in Acapulco, risks of seismic in Mexicali in the north of Mexico, risk of fires in the roads and the bridges and the trains. We need to evaluation the risk by likelihood, we need evaluation by impact. And what kind of damage we have in the bridges and the roads? Earthquakes, like we see in Japan. The climate change make all the rivers increase the flow, increase the scouring, increase the collapse of bridges by scouring, like we said yesterday, what happened in the bridges. The fire, the slope collapse, the false cover, etc., etc., etc. We need to know our risk in the roads. You can see the metro line, La Línea 12. There was a 26 dies. It's a lack of instrumentation. It's a lack of quality in the studies. It's a lack of a plan of maintenance of the metro. It's a lack of the vision to verify and maintain all the structures. There is Mexico. You can see the last 70 years of hurricanes in Mexico. In 2013, we have 2 hurricanes, one in the Pacific side and one in the Gulf side at the same time. It's the more catastrophic event of hurricanes in Mexico. And these hazards, the damage, what made in our infrastructure, road infrastructure. You can see how is the cost of the lack of resilience, of the lack of the studies and the risk. You can see in 2018, Sismo Mexicali, $7,700 million in 2010. In 2018, with the seismic in Puebla, $5,800 million. It's a cost. Why don't invest this money in resilience? Why don't invest this money in monitoring our infrastructure? It's a cost or it's an investment? Your minister said, it's not a problem money. Then we can do it. Where are Mexico in seismic risk? Like La India is 10 in the world, and Mexico is 7. Chile and other countries. Then we need to know our risk, the actual risk, not the older one. We need to modify our codes. We need to know our risks. This is a study in 23 that we made with the Minister of Transports of Mexico to know where is the dangers, to know where is the peligrosity, we know where is the risk in or risks in Mexico and all the roads, motorways, federal roads. And we detect that we have 1,098 risks or bridges with high risk, with medium risk, with that. And then with that, we can make a plan. What risks we need to inspect it, to monitoring, and to verify our foundation that we see in the other presentations. We need to implant dumpings, like Katsuo said. We have 15,000 bridges and 1,000 bridges with high risk. This is a map of the seismic this week in our country. You know how many seismic events we have in our country? I think in La India there are many seismic. Every day we have a seismic in Mexico. A little, a medium, and the higher risk. We need to improve, we need to do something. And what we made Mexico? Mexico is the AASHTO codes, because we are beside the United States, we are in TLC, we are to respect the same code with Canada and with the United States. John Harman is here. And we improve now this classification of the breaches. Critical, essential, and other. It's a coefficient of resilience that improved in USA, and now we're going to improve in Mexico. And with the Spanish Agüero codes, with the Spanish Latin American codes, to make specifications in Mexico with our prop risk, our own risk in climate change and seismic risk. We need more resilient bridges. This is an example of the several collapses of bridges in Mexico. In construction, all the bridges, new bridges, etc. And we need policies. We need our governments make the policies to improve the resilience in our roads, in our bridges. We have in Mexico that we need to improve is the first step. With the new technologies, with isolation, with the dampers, with the new technologies. It's not the new technologies. It's the technologies what we can use now in our country. And the case of study, Viaducto Puebla, 22 kilometers, a risk the 1.2 G of acceleration of gravity. And we made the specifications for the design and construction with the new technologies of this viaduct. It's cheaper than make a conventional design. This is a Xochitepec bridge in 2017 with liquefaction of sands. It's an oldest bridge. We know in geological behavior of other bridges, we know the status that they had. We made new verification of geological way that they are, or bridges in the country. Coajilote Bridge is another example. We improved the new technologies with authorization of the administration. We are engineers. We can have the technology. We can the software to modelize all the bridges. We can evaluate the resilience with design the bridges with the code, or if we design over the code with some scenarios for the new bridges. This is an Hurricane Ingrid Manuel, Acapulco. Is the bridge we has the two hurricanes in the Pacific and the Gulf, and there was 200 bridges that fall down in 2014. 200 bridges in the same week. Like you can see what happened in Coyuca Bridge in 2014, and after in 2013 was the collapse, was the Hurricane Bridge Manuel. 1 year later, 6 months later, was seismic 6.5 when the bridge was building. And then the Minister of Transport said, we need to improve the resilience, we need to improve the new technologies, we need to improve the dampers in this bridge. And what's the rehabilitation of this bridge? We stopped the wars, and we improved the new technologies for with dampers. in this bridge. You can see the periodo of the structures, 0.6, 2.5, with the quantity of pilots or piles in the foundation, to 10 to 6 with the new technologies with the dampers. This is a new bridge it's an example in Coyuca Bridge in Acapulco, near the Acapulco. With reforms in the new bridges for make is retrofitting Puente Coatzacoalcos, etc. With the fiber carbon and for torsion, for longitudinal flexion, etc. This is a new bridge in Guadalajara, Colima. It's 1.2 G acceleration. And what we made in 2023. The minister.
You have two more minutes.
Okay. The minister said we made a synergy with all associations, the Ministerio de Transportes, the Ministerio de Hydraulics Rivers, la Structural Association, Mexican Structural Association, la Mexican Hydraulic Association, la American Roads Association, la American Geotechnics Association, la Mexican Seismic Association, to make a group to improve the new specifications for all the bridges in Mexico. That's what we need to do. And when we make a work plan, and then we make a work plan, we put the climate change to improve the new specifications for all these bridges and the new bridges. And the quality in the studies and the quality of maintenance and the quality operation of bridges. The conclusions there are, we need to develop or maps the risk and hazards. We need to determine the classification of resilience in all of our bridges. It's different, the motorways, Mexico-Acapulco, that federal way to Cuernavaca. With meet is determine and classify or resilience plan or infrastructure, roads, culverts, bridges, etc. We need to use the new technologies, the big data. In Mexico, we will improve the big data for the geological studies. For all engineers have the geological data for all the bridges in Mexico. The good construction, the good process for construction. Increase the resilience of infrastructure. The use of materials, low carbon and quality. The good engineers to form the engineers in specialization in bridges in Mexico or in other countries. Determine and classify the critical and essential structures. All the bridges, for example, the stackable bridges, that are very, very, very important. They need classifications for very important bridges. Consider the sustainability and climate change in public policies. Increase the reliability of infrastructure, also additional benefits in terms of service level. The minister say all the infrastructure is for service for the people, for us, for our families. The service is the last thing that we need to improve in our society. And the maintenance of infrastructure, roads, bridges, etc. And the quality is not negotiable. It's not negotiable. Okay. They put it here yesterday, not now, not today, because the studies, several presentations of you say, oh, it's a lack of studies, it's a lack of technical It's a lack of the good calculation. It's a lack of the capacity of engineers. It's a lack of the supervision. It's a lack of bad construction. It's a lack of the bad maintenance. It's a lack of bad operation. Then we can do it. We have the knowledge, we have the capacity, and we have all of us improve for our countries a good infrastructure. Gracias. Thank you. Gracias. Merci.
Thank you very much for keeping it short. As was mentioned at the opening, that this session is being curtailed, keeping in mind the delays which are happening. So I have just been informed that the question and answer session we will take online. So request you to submit your questions online using the QR code, and the responses would be sent by the speakers by email to you. So we would not take any Q&A. I would request my co-chair to summarize the session and give his remarks.
Thank you, Mr. Professor Rivasina. I would like to thank all the presenters, Mr. Hunabe and Endo, for emphasizing the collaboration between the countries, which PIARC does, of course. So this is very good. And Mrs. Paramaswaran and Mr. Hugade for emphasizing that we do need to reduce carbon, and it's very important that all measures we take, it helps for the environment. And last but not least, Mr. Rojas, Luis Rojas, for the emphasizing that quality is non-negotiable. Especially this is very important in our business, and it's better to spend money on that than to spend money on rebuilding bridges. So as the honorable gentleman, the presenter said already, I'm from the Netherlands, so it's a very nice country to visit, but we're also below sea level. And our agency, Rijkswaterstaat, he is the prioritization of protecting the lower regions of our country from sea level rise. And these last few years or decades, there is going to be more and more heavy rain. So we just had our anniversary, our 225th anniversary last year, and it was about climate change. And the focus was on whenever we did the reconstruction of infrastructure, we had saying that getting it right the first time. So this is very important. You have to think ahead. So all these presentations and also the presentations of yesterday, and if you look a bit more historically, in the Netherlands we were start building bridges in the 30s, but the steel bridges, but later on in the 60s, 70s, more and more concrete bridges came. And we hadn't had any more real guidelines, but some accidents occurred due to bad designing or quality control. But in the 80s and 90s, guidelines came up, but we also did the more production of bridges. In the 2000s, the Euro code came. And then we saw that the lifespan of bridges were lesser than we anticipated. So we have a big renewal task ahead of us. Onto that, there's also the extremes of the weather and the prediction. So this is very important that not only we have the renewal, but also we have the extremes that we have to account for. And this is what we have to do on this climate adaptation session, is the most important thing, that we not only design by reconstructing a safe constructional design, but it also must be robust and resilient for the future task to be. So again, the quality control is very important, but also the engineering. And the advice from the Netherlands is, if you're going to do infrastructure renovation or climate change, do it right the first time is most important. But if you have to build a second bridge due to a flood or seismic, an earthquake, carbonization, reducement has no effect. So the most effective is do it first. Yeah? So this is my conclusion.
So thank you, Mr. Cross. This session touched upon a topic which we are going to hear more and more about in the future. It has the potential to transform the way engineers practice their profession. And again, I would like to congratulate the IRC for being on the forefront and showing leadership to take this topic so early. And we look forward to the further development in this field. So thank you all for listening to the excellent speakers, and thank you all the speakers for your very insightful presentations. Thank you all.
Yeah, I'd request all of you to kindly stay back for a few more minutes. First of all, I would request the co-chair, Mr. Marcel Cross, to felicitate Carbon, Mr. Shri V.N. Hegde. Kindly come forward, sir. Thank you, Shri V.N. Hegde, for the presentation on carbon abatement strategies for bridges. I would also now request Dr. Lakshmi Parameshwaran to kindly come forward and accept the felicitation. Thank you, Dr. Lakshmi Parameshwaran. Effects of climate change on existing bridges. That was the presentation by the IRC expert. Thank you very much. Thank you. I would now request our chair, Professor Ravi Sinha, to kindly come forward. And I would request Mr. Jil Hyungbae to kindly accept the felicitation. I would now request Mr. Kazuo Endo from Japan to kindly come forward. Thank you very much. And finally, I would request Mr. Louis Rogers to kindly come forward to accept the felicitation from Professor Ravi Sinha. Thank you very much. I would request Mr. O.P. Srivastava, Additional Director General of Ministry of Road Transport and Highways, to kindly come over and felicitate our chair, Professor Ravi Sinha, first. Sir, chair, kindly come forward, sir. Professor Ravi, kindly come forward, yeah. Accept the felicitation. Thank you, Professor Ravi Sinha, for spearheading this important session. I would now request our co-chair, Mr. Marcel Cross, to kindly come forward and accept the felicitation. Kindly come, sir. The tall man. Thank you very much. Thank you, Shri O.P. Srivastava. I would request all the esteemed speakers to kindly come forward for a photograph. Yeah, all of you together for a photograph, please. Well, ladies and gentlemen, as the photograph is being taken, let's break for tea and do come back in 15 minutes. And also, more importantly, the QR code will be displayed once again after this photograph. And you can also, some of you have forgotten to ask questions earlier, can think about it and send in the questions using the QR code. And you can get your answers, as already told by our chair, Professor Ravi Sinha, that you will get your answers through mail. So once again, let's give a round of applause and thank the panel for their presentation. Enjoy your tea or coffee and come back in 15 minutes. Thank you.
चेयर लेके आ जाओ नीचे से।
सुनील सब थोड़ा आगे आ जाओ, मिश्रा देखो बताओ, देखो सही दिख रहा है।
खाल तर मग त्या अखंतले ते हल्लू याद कुठले ब्रो ब्रो थोड़ा ते जर्मनी
Check.
Well, ladies and gentlemen, welcome back after tea. We are intending to start the session in the next 2 to 3 minutes. Request all of you to kindly take your seats. Request all of you to kindly take your seats. We'll start the deliberations in the next couple of minutes. Well, ladies and gentlemen, we have come to the final session. Now, immediately after this session, we'll have a presentation in order to save time. Hear me carefully, please. Hear me carefully. Because tomorrow morning, we're intending to have the presentation on the Bangaluru Airport Metro project. And people, in order to enable them to spend more time in the site, we are having the presentation after this particular session, and the entertainment will happen after that. So please, all of you who are interested for the site visit tomorrow, Bangaluru Airport Metro project, are requested to stay back after this session and wait for the presentation to happen. It's time now to start this final session, panel discussion on bridges collapsing during construction and the lessons learned thereof. First of all, I would like to call upon the chair of the session, Shri D. Sarangi, the Director General, to kindly come over. Put your hands together for the Director General, Road Development and Special Secretary, Ministry of Road Transport and Highways. Has had several experience for more than 3 decades with MSc Engineering and Structural Engineering honors, and is the member of several professional organizations, and importantly, all of us know, is actively associated with the Indian Roads Congress. So very hearty welcome to you, sir. And now I would like to call upon the co-chair, Mrs. Yvonne Gunn-Ribben, to kindly come over once again back, as she's the Deputy Head of Civil Engineering Structures, Federal Ministry of Digital and Transport, Germany, Working Group Leader, PRTC 4.2 for issue of 4.23 requirements and evaluation methods for structural redundancy of road bridges. So welcome to you, ma'am. Before we start, I would request the Chairman of the International Delegates Committee, Mr. V.C. Sunil Kumar, to come over and give away bouquets to both of them. I would request Sri Sarangi to kindly accept a bouquet. Welcome to you, sir, and also to Mrs. Yvonne. Thank you very much. And now I would like to call upon the panelists of this panel discussion on bridges collapsing during construction and the lessons learned. Mr. Joey Hartman from the United States of America. Put your hands together for Mr. Hartman. Mr. Pierre Julius from Belgium. A round of applause, please. I can see only people outside of India clapping. What about people in India? I can only see there. Mr. Frederic Naud from France. And we have the Indian counterparts, Professor Ravi Sinha from India, Shri V.N. Hegde from India, Shri R.K. Pandey from India. And I would also request Professor Mahesh Tandon and Nicholas Bardau to kindly join in as a part of this panel. Yes. So in the interest of time, I would straight away hand over the session to our chair, Shri D. Sarangi. Over to you, sir.
Thank you very much. Actually, the concluding session of this 2-day seminar, I think it is the most important, and it will be the most important takeaway for me at least. As we have been hearing since yesterday, there were some data given on bridge collapses or the bridge life in India around 34, 35 years. Of course, we don't have that data. If it can be shared with us, it will be very happy. Nonetheless, it's a well-known fact that the bridges do not last its intended design period of 100 years, or they collapse much earlier to that, which is a very, very undesirable circumstances. We have been discussing so much on carbon neutrality or reducing the carbon footprint. To my belief, designing and constructing the bridge that lasts for 100 years, no matter what material or construction process you are using, I think the most important or the single most important point in reducing the carbon footprint. I may be wrong, but I believe so. So from the perspective of Minister of Road Transport and Highways, I have prepared a small slide which will set the context for panel discussion. After that, I will be requesting the panelists, but before, let me start my presentation. Next, please. Someone will be operating it. I think it will be better the panelists sit here, somebody. Okay. In fact, we got data from all executing agencies of ministry, and this was in response to some parliament question, that 11 under construction bridges collapsed during last 3 years. So where the entire span, there may be many cases where some isolated problems or damages might have occurred, but these are the collapse of complete superstructure of at least one span. When we analyze the data, we found that in only one bridge, the failure was due to sudden flooding, and it was in Sikkim because of the glacial outburst last year. Then in 7 bridges, there were mechanical problems, like either crane failed, jack failed, or something else. So during the launching operation, mostly the bridges failed. In one bridge, there was a failure of the temporary structure. In one bridge, after launching of the girders, but before the end diaphragm were in place, so there was no bracing arrangement properly, that collapsed. And in one case, there was a failure of the pier cap, because the pier was constructed by some contractor. He left, then another contractor came who started from the pier cap, and there was some issue of continuity of the reinforcement that led to the failure. Next, please. To our knowledge, or whatever interactions we have from the different stakeholders, whether from the contractors, consultants, and our own officers, I have tried to list some of the issues of concern to us, or the challenges. The first is instability of partially completed structure. This is particularly the girders where the diagram and cross girders are in place. There is no proper arrangement, and in case of some problem, failure occurs. Incorrect sequencing of construction operation. In many cases, this has happened because either the designer notes are incomplete, or that is not scrupulously followed in the field. Many cases, the pre-stressing sequence is also not correct. Temporary structures, either it is not properly designed or not properly built that has caused failure. Lack of technical expertise and accountability of the contractors and the AEI personnel. This is a very, very important factor going by the size of bridge construction we have taken off in last more than 2.5 decades. Unfortunately, we have not been able to do the capacity building matching with that. So the people who are in the field, we try to blame them, particularly the poor authority engineer, but it is basically their personnel, whatever reasons they quote very less rates or whatever it may be, the persons do not have required expertise. They just want to buy time, get some give some comments, give some approval, but neither they are competent nor there is any effort by their agencies, by their employers to make them competent for the purpose. Then poor project communication between contractor, designer and AE, and poor document control. I have seen at least in 2-3 very, very major bridges, even over river Ganga, there has been so much miscommunication between the authority engineer, contractor and our own department. It has not only caused delay, but it has caused some of the actions which could definitely have been avoided from the beginning. Then checklist approach ignored. That's very important for each and every operation. What are the activities to be undertaken? What are the processes to be followed? That should follow some checklist. Many times we have checklist. It may be finding somewhere in the quality assurance plan, but we ignore it. We want to go by our memory, which unfortunately does not have everything, and that small issues cause problems. Key personnel of contractor absent during critical operation. The contractor's own personnel who are supposed to be duly qualified and supervising the activities during the important operations like launching or anything of that sort. Many times it is found that they are missing from the scene, and where they are absent, maybe the problem is there. Next, please. Poor upkeep and maintenance of temporary works, bridge deck erection equipment, hydraulic jacks, etc. Nobody care much for that, and they in turn result in failures. Required skill and experience lacking during the launching activities. This is because we are now going for more and more precast segmental construction. So this is very important. Deficient supervision control by IE. So they are lagging on both fronts. First, expertise is not there, competency is not there, and second, whatever they have, that is also not properly utilized. Delay in decisions. Honorable Minister was scolding all of us, but this is a fact. Many times we take the same decision, but after a delay of 3-4 months, which does not do any benefit either to the contractor or to the department. Rigor of quality assurance and quality control lacking. This is really very important, and each of us from our own country, we know where we stand on this matter, and we all are responsible for that. It is not singularly the contractor or the authority engineer, but everybody in the chain. Emphasis on speed at the cost of quality. Unfortunately, this has been the scenario because of the heavy pressure of delivery. And the method statement and design notes not taken seriously. Many times designer makes mistake, but even if designer has given correct prescription, but in the field there is laxity, there is deficient in attitude to follow it in letter and spirit. I think that's all. Okay. So these are some of the issues we found deficient in our project. And these issues pertain to departmental officers, to contractors, to consultants, all of us. It's not singularly any one of them. So how it will be improved, to what extent it can be, and the duration, it's maybe a matter of speculation. But at least I can assure one thing. If we receive during this panel discussion any valid point on which action is needed to be taken by the central government, I can assure you that we'll take it next 2-3 months. But the recommendation, the suggestion should be very, very loud and clear. With that message, I will start the discussion. To each of the panelists, there are 6 panelists. Each is allocated 8 minutes time. I think all the panelists have been introduced in some or other presentation, so I will not take time to give their introduction. Only R.K. Pandey sir is not introduced, but probably he does not need any introduction, particularly in Bangalore. So in that way, now the first is Mr. Joy Hartman. Sir, 8 minutes.
So good afternoon. Thank you for inviting me to talk about bridge collapses during construction. And my presentation is simply going to be an overview of what we require in the United States. So like many other nations, we have a construction specification that is required to be used. It's a minimum specification. Most states that build bridges have requirements in addition to what's in the specification. It's a rather large specification, has 34 sections or chapters that fall into the 5 categories you see there on the screen. Essentially earthworks, deep foundations, concrete structures, steel structures, and then everything else. Some other requirements for construction in the United States. Every set of design plans is required to have what we call an erection scheme in them. So that's the designer is telling you what kind of structure they want you to build and how you can build it. It is very unlikely that the contractor will use that design scheme, but they have to provide one. The contractor, because the contractor has equipment and practices that are specific to them, probably have another set of means and methods that they would rather use, and that's fine. They just have to have a set of erection plans signed and sealed by an engineer on file with typically the bridge owner, which is generally the state. In all cases, whether the contractor is using the erection plan that was detailed on the design drawings or his own erection plan, that he is responsible for safety and stability on the site. We do have challenges, just like everyone else. One of our challenges is the procurement method that is primarily used in the United States. It's a design-build method, so the designer and the contractor do not know each other at that point in time. And in the 90s, we introduced high-performance materials, like a lot of other countries, high-performance concrete with strengths, if I did the math right, up to about 105 megapascals, and steels at 690 and 485 megapascals, which were things we already had in our inventory, but these new high-performance grades were much more weldable, which made them, and much more drillable, so they made them much more easier to fabricate and more popular. Of course, if you make stronger materials, you have longer spans and heavier picks, and as a result of the okay, so I'll stand like this. So we have longer spans, heavier picks, and we resulted in a number of failures. We noticed through that investigation process that we had an expertise issue as well. So I'm going to show you a couple of those from the, well, starting in the 90s, bridging over the, in Tennessee, it had a 536-foot main span, was a three-girder section. 530 foot is like maybe 200 meters. We had an erection plan on file here, but it certainly doesn't make a difference if you have an erection plan on file if you don't follow it. The second one there is in New York. It was just a big box girder that they hadn't completely stabilized for lateral torsional buckling. And then pretty much more the same, a single girder that fell over as not being braced correctly, a whole cross-section where global stability hadn't been considered. Same thing for concrete girders, and then the last one there, that was a false work failure. So at the national level, I'm at the federal highway level. The vast majority of the accidents I have been involved with have been the result of either an unexpected or unintended load on the structural system. However, these 6 or 8 or whatever it is I just showed you were not about load. They were about stability. Every one of those investigations determined the same thing, which is the specifications we have cover stability in great detail. However, if the engineer is not either using the specifications or not applying them correctly, it certainly doesn't matter. So as a result of all of those failures that I just showed you, my office put together an entire manual to better educate engineers on what stability is and how you design for it. Contains all the sections that you see there, and I've provided you the QR code if you want to download it from our website. And this manual is now the basis for a training course at our National Highway Institute that's available to engineers all across the United States, essentially on how to design for stability, not just during erection, but at all stages of the bridge construction. And that's an introduction to the United States, so thank you.
Thank you very much. You have finished much before the allotted time. The next panelist, Mr. Perry. Please, I would request you, if there can be any suggestion to us how we can improve our system, that will be most welcome.
Good afternoon, everybody. I will give you some information about the situation in Belgium. Belgium is a very, very small country, especially if you compare it to India or to USA. Belgium, we have, I'm in charge of the south part of Belgium, and we have about 6,000 bridges. So I will try to explain briefly the different kind of specification that we use. Then I will show you some example of failure that we observe during construction, and I will finish with some challenge that I think would be interesting. Of course, we are in Belgium, in Europe, so we follow all the specification coming from the Eurocodes, and based on this specification, we are making our own specification, which name is Cali Route, quality for roads, in fact. And during the execution, if you look to the responsibility, while the contractor is responsible of all the temporary phases and all the construction techniques that he will decide to use. There are 3 persons who are performing control during the execution. Of course, the contractors and all the team of the contractor, including the team manager and so on. The owner of the bridge, which in Belgium is always the road administration, will perform also a control in order to see if the materials are in good condition, if the way they are used on the field are also well done. And finally, there is also a control office that will make some control. In fact, all our works need to have an insurance during 10 years against every failure during this period. And the insurance, of course, you know that insurance doesn't do something without a little bit certitude. They wanted to reduce the risk, and to reduce the risk, they pay an independent control office that will check the design of the structure, but also the way the structure is realized on the field. So 3 different view on the works is performed during the construction. So some case, well, we are a little country, 6,000 bridges, it's ridiculous comparing to India. So we only, hopefully, in fact, have a few cases of rupture. And the first one, I just passed the border because it is not in Belgium, it's just in Luxembourg, just after the border. And it was a very, well, classic problem of scaffolding that collapsed during concreting, and the cause was, of course, a problem of calculation, bad calculation of the scaffolding. The second case in 2001, this one was in Belgium. We were building a bowstring bridge, and the beam was tensioned by internal PT. And while they performed the tensioning of one of the tendons, while there was a rupture of the end block. And this was due to the fact that the cable, in fact, was too close to the edge of this block. The reinforcement was too weak, and in fact, we observed after the collapse, of course, that the design was not conducted into detail, and also that there was some drawing error by the control. So different error made during this local failure, because all the bridge doesn't collapse, of course. The last one, I would like to go a little bit more into detail, because it's a good example that sometime a bird somewhere in the world can change as big consequence somewhere else. So here you will see that there is only a little detail that was wrong, combined with other causes also, and that conduct to the collapse of the bridge in 1989. So as you can see, it's a box girder bridge, 3-span with internal PT. You can see in red the shape of the PT. And in the middle of the midspan, the lower slab was relatively thin, about 15 centimeter only. At the end of the day, the tensioning was performed. Everybody was going away, hopefully, and the bridge collapsed, as you can see here. And the rupture starts in the lower slab of the box. So, in fact, there were 3 errors in this structure. First error, there was too much compression in the lower slab due to the fact that, in fact, the real tensioning effort were higher than expected and produce a strain of 26 megapascal instead of 20 megapascal. The second problem was that the resistance, the strength of the concrete, the compression strength, was too low, too weak, and in fact we have only a strength of 40 megapascal instead of 50 megapascal at the time, of course, of the collapse. And finally, the little detail. The little detail, as you can see on the cross-section shape, we put on the lower corner a little profile in order to avoid to have a sharp edge at this position. So this little corner was 3 centimeters over 3 centimeters. And if you look to this view, this is a horizontal view, and the green line represents the place where this corner has to be placed. And of course, they didn't concrete all the bridge in one section, so there were different concreting sections. These are the vertical line that you can see. And at one position on this transversal section, they put also one corner profile that is the red dash line that you can see. So in the lower, you have a cross-section of the slab, 15 centimeter, and you can see that there is the corner that was placed in the wrong place. Well, small detail, 3 centimeter over 15 centimeter. And in fact, this conduct to a reduction of the resistance of the slab in the compression solicitation. We perform some tests, you can see on the right. And we observe during those tests that the reduction factor was quite important, 0.65. So if we combine all these errors, on the action we have only 26 megapascal strength of the concrete, and if we on the action, excuse me, and on the compression strength we have 40 multiplied by 0.65, so we have only 26 megapascal, and so the bridge collapse. It's what we wanted to demonstrate, as you can see. So if we look to all these problems, mainly we observe that there are some error, sometimes error that can be conducted by a lack of people. I don't know how it is in India, but in many countries of my colleagues, I heard always the same: we are not able to find people. Even engineer, technician, workers, it's difficult to find people, and of course, people well with the good knowledge. And for me, that is one of the first problem for the future, is that if we don't increase the quantity of staff that we can have in the design part on the field, it could be an error to increase the number of failure during the construction. And also it can have an effect on the control, if you don't have, because if the contractor has problem to find people, the administration and also the control office has also the same problem to get people. So this, for me, this is the main challenge for the next years in order to avoid to get an increase in Belgium to such kind of problem. Thank you for your attention.
Thank you very much for the very precise analysis of the failure. Let me tell, we can take 2 suggestions from the participants, one from left side, one from the right side, after the panelists give their deliberations. But other suggestions, if any, I hope the same QR code will be there and it can be sent to IRC, which in turn will come to us. Mr. Frederick Naud from France.
Good afternoon. The purpose of my presentation is to address the main non-compliance which are penalizing the construction of mixed steel concrete civil engineering structures noted in recent years in France. To address the main causes, as well as the corrective and preventive measures implemented by the project teams, and I will illustrate my points with examples to show these non-conformities. The first bridge is a viaduct over the river of the Soule. The main problem was that the frame was too short. It means 70 centimeters. The causes, the carpenter's workshop didn't take account the linear alteration by the lumber production. It was a problem of topography. The consequence, it's a non-alignment of the structures and a possible consequence on the loads. The corrective measures, recalculation of the structure to measure the impact, the efficiency of the support, a possible adaptation of the bosses, and adaptation of the cobalt to compensate for the underlays of the structures. The analysis shows a mistake of the carpenters and the project manager visa didn't detect the error. Also, the topographer checks process history, then the control external has not detected either his error. The preventive measures include a topography paragraph in the contract, a plan from a stopping point between the design team and the various trades. Enters external on control topography and focus not just on the measurement, but on a coherent approach. The second example is the bridge of the Varan River. Always same problem, the structure was too short, so it missed 30 centimeters, and it was undersized. The main causes was a linear alteration not taken into account, and no control of calculation by the company. Then the consequences was costly adaptations. The analysis shows the wrong combination of carpenter on the civil engineer, and the external control office was not independent of the design office. The preventive measures was to reinforce the control during the provisional phases and to support site adaptation with approvals. The third example is the true collapse. It's a bridge of the river Adour. During the installation of prefabricated slabs, a weld connecting caisson failed. Causes on site, modification to the phases of slab installation, and storage of slab on the caisson beam. The consequence, 3 elements failed in the river. The analysis showed a non-validation by the project management team of changes to the company. The measure prevention was a reinforcement of control during the provisional phases. Last example, it was a railway line, it was a bridge. The descriptions show that the seat modification changed the position of the temporary support, settling of the supports and tilting of the framework. The causes was a lack of preparation, consequences, an accident, and the analysis shows a lack of monitoring during the construction and a lack of support during the works. The preventive measure was systematic validation of all processes or changes on site and setting up external monitoring to support sensitive phases. As a conclusion, feedback for France, it was site improvisation, procedures not followed generally due to hazard, emergency and precipitation, gap in preparation, and poor coordination between different managers. The corrective actions were temporary works manager mandatory designated by the company and experience validated by the project or contract manager, special safety notices to manage interface between managers, beware of unrealistic schedules which lead to improvisations, take care of the preparation under the leadership of the contract manager, put safety at the heart of preparation, more prevention officer, more safety stop points, strengthen the presence of the project manager during delicate phases, it's important, and set up external control on stop points. Thank you for your attention.
Thank you very much for the very nice analysis of failures. Now I would request Professor Ravi Sinha.
Thank you very much. We have had 3 excellent interventions so far, and I'm going to be sharing the experiences of collapses which I have observed in India And we live in a global world, so many of the problems I'm going to highlight, you have already heard from the earlier speakers, but also a few other which are perhaps uniquely Indian issues. Let me first just mention that as engineers have to have a broader meaning of failure. So failure is not just collapse. Failure is also if there are other kinds of distress which get repaired at the project site because they should not have occurred at all. And then there are inherent defects which are not even detected, but they affect the design life of the facility. Already there has been a lot of discussion during this conference regarding what is the design life of the infrastructure which is being built. And a lot of that is attributed back to lack of sufficient quality control during the initial construction. So failure is overall, but for the purposes of the discussion today, I am going to focus only on the collapse part, where something actually failed to the extent of being observed as a collapse. So when I look at the possible causes of the collapses which I have observed and I have evaluated, then the reasons which come out are actually a number of them. First of all, there is often a lack of appreciation that bridges are complex structures and they have many interdependencies. So whether it is a EPC contract or whether it is a design-build contract, the assumption always is that you can subdivide the activities into a number of silos to be taken care of by the competent professionals in each one of them. And that is rife for creating situations where interdependencies are going to cause problem. There are so many cases which we have seen where interdependencies, and often later on they are described as lack of sufficient communication or something like that. But the basic fact is that you are having a complex system which interdependencies, and a simplistic management tool was used to come up with the construction problem. So this requires a retooling of the management system itself in place. Then the second issue which I observe is regarding the construction process. So when I was a child and I would be going somewhere and there would be, say, a bridge being constructed, and then I would ask around that who's doing it and how it is being done. One thing used to come out that structure after structure would have a traditional system of construction. The pace of introduction of innovation was very low. And the reason is that the new developments which are happening around the country or globally were not so easily percolated to the people who take the decision on introducing new technologies. Now what is happening is that people see something on YouTube and they assume that they have an understanding of what it takes to build the same thing in their domain. So there is an inherent unfamiliarity with the technical aspects of the new technology. That is a major, major cause which I have seen. There are so many cases where you talk to the people later on that how did you take care of this consideration or that factor? And there is a blank face. They didn't even know that these things exist. Then another problem which has been highlighted is the immense pressure in which everybody works nowadays to rapidly deliver the project. Rapidity is always related to increasing the rate of errors. And lastly, in this sequence is the use of more and more innovative formworks. The people who supply the formworks, they take no responsibility of the project. Contractually also, they are responsible only for the performance of the formwork, not of the performance of the project. And the contractor or the authority engineer or even the clients, they are obviously not having the same expertise on the formwork. So that's a gap over there. There's nobody who takes responsibility that this formwork is going to deliver the project for which it is being deployed. Then advanced materials are good. In fact, they are critical as long as we understand what they are. And that is a cause also of several times when we have seen underperformance. Then there is perhaps is a good thing that in India we have a great confidence on the codes and standards, that if all the clauses of the codes are complied with, nothing wrong can happen in the structure. But we all know that number one, codes are not infallible. Number two, codes don't cover everything. So good engineering judgment, good engineering understanding cannot be substituted by a series of code provisions. Codes are to help the engineer, not to become the engineer. Many times we have had a lot of discussion with the contractor asking for things to be done which are not mentioned in the code. Because for the contractor, anything extra which they do is a cost and time aspect. So this confusion comes up that why should you do it if the code has not mandated? Because the assumption is that if something is required to be done in the project, code itself is going to cover it and there is no need to do anything other than that. So it's a mindset issue. It's an issue of the contractor decision makers not having engineering knowledge to execute such projects. And lastly, the problems, amongst the problems, the inadequate QA/QC systems. We design bridges for a 100-year design life. The normal buildings like this one, the hotel we are staying in, they are designed typically for a 50-year design life. In major construction companies, many of the major construction companies, I see that there are some contractors whose quality assurance manual for their organization for a 50-year design life structure, because they do only buildings, that is more comprehensive than the quality assurance manual of contractors who are doing bridges which are supposed to have a 100-year design life. So there is a problem that how do we define whether the quality assurance manual itself is of proper quality or not. So that also we have seen is the gap, that something was never foreseen because it was never included in that organization's QAM. So what all these come up with in terms of the lesson learned, so those are the causes, and what are the lessons learned are that bridges are complex systems. We have to treat them as complex systems. Then failures occur due to cascading series of errors. At least in all the failures which I have investigated or I have been involved with, I have, except for one case where there was an external factor, I have never seen a situation where a single factor caused the failure. It is always a series of small errors which have all built up, which is all the more reason to emphasize the need to take a system approach. Then also materials and construction systems are both being pushed to the limits. How often does it happen, those of you who are in the design field, how often does it happen that there is a force that the design should have a utilization factor of 0.9, 0.95, 0.99? What are the consequences of these in terms of the typical variations of the construction site? These have to be understood because they are consequences, low probability consequences, but in a country like India where there is such a huge amount of infrastructure project which is going on, that low probability for a single project becomes nearly 100% probability for the projects combined together. Then again, to realize that codes don't cover all situations, so engineers have to do their engineering. And during construction, the erections, the sequence of construction, they need to be robust. So that means that they need to be fault tolerant and they need to be redundant, which means that if in spite of everything, something happens at a particular place, that should not jeopardize the project as a whole. And also, most importantly, we need to learn from the past lessons. So often, past lessons only result in administrative or financial action. They almost never result in lessons to improve the future contracts. So what I would like to conclude with is that the most important lesson is that bridge projects, they need to be treated with respect, and we need to consider that bridge is not like any other part of the infrastructure development, so special attention should be paid to it. So that's all I would like to share. Thank you all very much.
Thank you very much, sir, for very enlightening the investigation results that you have carried out and some very good suggestions. Now I would request Sri V.N. Hegde sir, please.
I'm audible. So, since I don't have a presentation, I just going to talk extempo on this subject over here. Now, I'm here to bring out this contractor's perspective here. Basically, I'm representing contractor, and a lot of academicians are there, and other professionals, government agencies are also there. You see, whenever I have been interacting with the contractor, one question, those contractors whose structures have failed and who had asked my counsel, like they are saying that the best of the contractors of the country, like whose structures have failed, they say, as per the EPC contract or the concessionaire contract, we are satisfying all the requirements of the contract. We are not leaving any contractual requirement undone. Whether it's the engagement of the design director, proof checking consultant, safety consultant, authority engineers has been engaged by the authorities itself after the due scrutiny. And despite that, joint records are maintained and all the work is done as per that. Despite that, the accidents are happening in our sites. How do I take care of it? It's a concern. Painful contractors sometimes ask me this. It's not that we are neglecting it, but ultimately it comes on us. I feel there are a couple of issues which has to be addressed in our contract, EPC or concessionaire, or even for that matter, the lump sum contract model. If you really look at it in all these contracts, there are directly 4 stakeholders. Of course, if you include the authority, 5 stakeholders, and indirectly the one stakeholder, DPR consultant. That's an indirect stakeholder. First, 3 stakeholders, that's the design director, that is basically the detailed design consultant, proof checking consultant, as well as the safety consultant has been engaged by the contractor. And the authority engineer is engaged by the authority. That's how it is. Let's have a look at the responsibilities. See, on the basis of, not couple of 4 to 5 investigations which I have carried out for the MORTH as well as the NHAI, and a couple of investigations which I have carried out to the railways for that matter. And also I have been carrying out some investigations for the contractors as well as the consultant, like that. On the basis of that, what I find is there are little bit improvement is required in well-established, like contract system of the contracting. Take the case of the design director. Design director is engaged by the contractor. A detailed design consultant is appointed many times as a design director. In my opinion, it has to be a different entity. If you really look at that particular clause, Article 10, in spirit, it says design director. He's not talking about it has to be a different entity. It cannot be the same. Design director has to understand the design for constructability. It is not just computations and arithmetical calculation of the structural design. His responsibility is much more than that of the detailed design consultant. In my opinion, it has to be exactly the separate entity. This is what one of my suggestions. And if it is there, design director should be able to understand the detailed design, permanent structural design, construction enabling structural design, and also some of the construction aspects, as you put it in one of your slides. And he has to be there during the construction, start of any critical activities. Whole responsibility, in my opinion, is with the design director. That is the reason I feel that the design director should be a different entity. Even if he has to be engaged by the contractor, he has to be separately engaged. He has to have 20 to 25 years experience, in my opinion. Let the detailed design consultant could be separate. Design director entity as per the contract could be separate. Design director could be getting the design coming from the contractor, from the detailed design consultant, as well as the temporary structure design consultant. One of the investigations which Professor Sinha and myself was doing, it was found that the design director said that the temporary structure design is not my responsibility. I have not got an order from the contractor. So I think we'll have to make it very clear as far as the design director is concerned. Another important stakeholder is the proof checking consultant. Right now, the proof checking consultant is engaged by contractor again. I'll tell you, I've worked for a contractor for 35 years, sir, like that. I look for, if that is the case, I look for a proof consultant who can just stamp my detailed design consultant's drawing, because I don't have time. I want to execute the job very fast. I'm not looking for a proof checking consultant who really does the independent verification. So that is the reason, as far as the proof checking consultant is concerned, he should have the experience of having done the detailed design of at least one bridge of the similar nature. Right now, most of the proof checking consultants, they don't have the experience of doing the detailed design. They're only proof checking throughout their life. I think this needs to be looked into, and my suggestion is it has to be engaged by the the government agencies, similar to the way they are engaging the authority engineers. I think that's a way to go about it. Safety consultant, in present, it's very clear. It's a safety of the project highway. All the responsibility of the roles and responsibility which has been mentioned in the contract, it is for the safety of the project highway. I think we'll have to modify that safety consultant's role for the bridge engineer, And also the safety consultant should be responsible for the safety of when the enabling structure is being done, construction is going on, responsible for the safety of the construction. That has to be very, very clearly brought out as far as safety consultant's role is concerned. Safety consultant, I am not insisting it has to be engaged by the client. I think it could be the part of the contractor's engagement. As far as the authority engineer is concerned, I think I hear, I think there's a lot of scope for the improvement in the authority engineers. One of the ways we can do for the bridges is, my opinion is, authority engineers contract should have structural bridge engineer as one key person. Right now, there is a bridge engineer as a key person. There is no structure. That bridge engineer, whoever has worked as at a site as a project manager, he becomes a bridge engineer. He may not be knowing the structural engineering aspect of it, but he approves finally the designs of the detailed design consultant and proof checking consultant without having done the design in the past. I think one key person has to be there as a structural bridge engineer in the authority engineers, this one. Last but the least, the DPR consultant. I think today also we heard I heard it many times from our Honorable Minister Nitin Gadkari. I agree with him. Many of the designs, especially the long span bridges design, cable supported bridges, the way it has been conceived by the DPR consultant, some of the bridges, it clearly indicates that DPR consultant doesn't have the experience of designing structures. Side span is equivalent to that of the main span. This kind of in a cantilever construction, in a cable stay or a cable supported bridges, we have this kind of conceptual. DPR is nothing but a concept design. Basically, he has to understand that constructability. Again, in my opinion, one of the conditions for the DPR consultancy should be that he should have done at least similar kind of one design, detailed design. It's not just proof checking or something like that. These are the concrete suggestions I have. That is, I'll just sum it up. Design director should be an independent entity. He should not be a detailed design consultant. Proof checking consultant should be engaged by the authorities rather than the contractor. Safety consultant, I think the terms and conditions for the safety consultant has to be modified. Right now it is a project highway specification is there, and also he should be made responsible for the safety during the construction, safety consultant. Authority engineers, a contract should have one structural bridge engineer as a key person. Presently it is not there, and the DPR consultant should have the experience of doing a detailed design of one similar bridge in the past. Otherwise, concept design would not be correct. These are 5 concrete suggestions I have got, DG Saab.
Thank you very much, sir, at least for some concrete suggestions. Let me tell you, we are in the process of revising the EPC contract agreement. Maybe some of your suggestions will be able to accommodate. Now I would request C. R.K. Pandey, sir.
Respected chair session, dignitaries on the dais, and distinguished delegates. Friends, very good evening. When it comes to lesson learned, the first and most fundamental question comes from where we get the data on failure. From the net. Slides chala diye. From the nets, yes, a lot of information we get through the net, but how reliable it is? No. Yesterday we heard a lot about statistics. Since yesterday we are hearing about a lot about the statistics of bridge failure. Yes, some study was done in America where he got a lot of information from America, but other part of the world, they got partial information or no information. It doesn't mean the countries which have given partial information have less number of accidents. So there should be a planned way of getting information. Coming to our context, there are two ways in which we are getting the information. One is the way which was started by the National Highway Authority of India, wherein after each failure, a committee of experts goes, analyze the whole reason for the accident, fixes the responsibility. A kind of reactive kind of collecting of information after failure of the bridge, somebody will go and collect the information. The other is initiated by the government of Gujarat. Therein, they are not reactive, they are more on a preventive kind of thing. They have panel of experts who is studying their whole system of, planning, procurement of contractor, procurement of consultant, procurement of all the entities which are involved in the construction of bridges, which will lead to no possibility of collapses. Now it is up to us to which kind of system we'll have to adopt. Both the system has its own plus and minuses. When it comes to reactive kind of system, getting information from the individual department may be very difficult because everybody knows no department would like to share his own information about their own failure. This is something which will, ultimately harm the profession because we cannot learn any lesson until and unless we have that kind of information available with us. Now, what is the answer to it? I think MORTH or the IABSC or IRC should take lead, and they should have panel of experts. Whenever any accident takes place, this panel should go, the expert can go, they can analyze, and that is the repository with one point. The idea is how it is better than the NHI model. It is better than the NHI model for a very simple reason. The NHI model, wherein we are basically aiming at fixing up the responsibility, here we can really learn lesson and refer to the code-making authorities, code-making people, that these are the issues where you have to take action, modify your code because of these failure. Number two, the second slide. The second point which I would like to emphasize, of course, I am debating about the data, whatever we are discussing so far, so many failure. But at the same time, yes, we all are sure that the kind of instances we have noticed during last 2 years is really alarming. Number of failures. Now, question is, why so many failures? What is the problem? There could be answers, and one of the answers could be, say, for example, when we have taken up NHDP, we have widened the existing corridor. Wherever there was a river, we have constructed a bridge. Now, our whole planning process has undergone a change. We are following crow flight alignment. We are constructing access controlled highways. When I'm saying crow flight alignment, it means whether river or not river, I'll have to follow a gradient, and if there is a valley, I'll have to construct a viaduct. elevated corridor is a buzzword today and everywhere where because of the high land cost, we are providing elevated corridor. When I said access control road, it means I am providing a lot of structures to provide number of crossing facility. It means if we'll compare our earlier program and today's program, number of structure per kilometer has been multiplied by 6. So you can work out the work we were doing earlier and doing now and see whether the failure are in that proportion. The second issue is the complexity of the structure. See 20 years back, where we were, all our bridges mostly were either simply supported PSC girder, RCC girder or slab bridges. Where are we today? 52 bridges are at various stages wherein we are utilizing ultra high performance concrete. Extra dose is not an issue. Everywhere you will find extra dose bridges. Cable state base is talk of the town. In projects, so complexity of the structure as well as quantum of the structure has gone high. Third issue, which is I am not giving any concluding remark, but should we think about our mode of procurement? Earlier, item rate contract. There were also system of approval of drawings. A drawing will go from one lower level to upper level. The factor of safety at 0.9. The next level will certainly say, check it, let us make more safe. And ultimately we'll settle somewhere 0.85 and fine. In the contexts wherein the contractor or concessionaire is responsible for design, there are also levels of approval. And when they see 0.9 is the factor of safety, their next response will be, let us further reduce, we'll have to reduce cost. And ultimately they go up to 0.99. As a designer, as a codal provision, we have no option. We can't say no to it. But what is the consequence? Are we in a position to translate these design at site? Your one mistake will lead to collapse. So whether the form of contract are responsible for increase in number of collapses, that you will have to think of. You can think of only after answering question 1 and 2. Coming back to the other issues is responsibilities. Today, you take any form of contract, there is authority, there is an independent or authority engineer, there is contractor, there is PMC, there is design consultant, there is design director, there is safety consultant, there is proof consultant. Who is responsible? Who is responsible? Many a times I feel responsibility of all means responsibility of none. So what is the answer? What are we doing? What are we supposed to do? In fact, we are supposed to prepare a well-drafted document specifying responsibility of each and every one. It is not new. See the system of PWDs, wherein the responsibility of each and individual level of officer is specified. We are expecting something like that. Coming to the quality of consultant, just now, Hegde Saab suggested, let us go for, proof consultant should be appointed by the authority. Of course, in other forum it can be debatable. They'll say authority engineer is appointed by the authority by the proof consultant. I'll say let us take a middle path. Let us give the minimum qualification for each category, whether it is design consultant, whether it is proof consultant. Rather, ministry should start empanelment of these consultants and let the contractor concessionaire select out of these. And last, most important is structural health monitoring. Yesterday, somebody was talking about when we can go to the doctor, why bridge cannot be inspected. To be very frank, when we started with the bridges, it was the system. It was the system, yes, bridge was constructed for 100 years and you will have to inspect it twice at least. Why we said inspect twice? It was one of the way of our health assessment. That time, technology was not available. That time technology was available, but it was not so reliable. That time technology was available, but it was very costly. So we thought prudent to depend on us. Today we have given different name, but point is when technology is available, why we'll have to say that I'll have to do structural health monitoring of particular type of bridge? In fact, I'll have to do structural health monitoring of all the bridges. Only the scope, the quantum of work which is required for structural health monitoring, it will vary. If we'll do all this, perhaps we'll have much more safer system. The last point, when we decide about the structural health monitoring and all those, the enabling structure, today morning somebody has asked this very pertinent question. We are saying that you'll have to inspect the bridges inside the bridge of the box girder where the access to provide, to go inside the box girder. Similarly, we talk about inspection of bearing, where we have provided access to the pier cap. So enabling structure should find place in our codal provision that all these to be provided. That's all from my side. Thank you.
Thank you very much, sir. At least your suggestions, in fact, we are noting down all the suggestions, but the particular suggestion on the mode of failure investigation, we'll definitely take it up seriously. And now, as I told from the audience, we can take two questions. In fact, we have received two suggestions, not questions. We have received some suggestions and one question. Question I would request the presenter to give directly. So suggestion, one from this side and one from this side, but 1 minute, not more than that for each. If anybody from this side, left of me. Okay, nobody. Any suggestion from this side? So there are two. I would take both. R.S. Sharma, sir. First, R.S. Sharma, sir. Sir, please, 1 minute.
Hello. I have got a number of suggestions, but since that is only one.
Sir, 1 minute, please.
One is to be given. That is, see, one of the what we feel, the lack of supervision, lack of things. What I find, one is due to the ignorance. See, where people know the things and not doing it, that is very difficult to improve upon it. So we need a quality people at the site, both from the contractor as well as from the supervision consultant. The people who are there supervising, even the supervisors or the key persons, they should have adequate experience of the type of the work they are supervising. So we have to provide training at the site, work site, and we issue the certificates. Only those people who are certified, both as the supervisor as well as level, should be appointed. So at least the knowledge will be there. Right now it's not there. You know, we are having so much work, but where is the manpower? It's not there. Thank you.
Thank you, sir. Ashok Basa, sir.
Sir, it is just a suggestion, and I think I have shared that with you last evening. First of all, failure is such a thing that we are always remembered, civil engineers are always remembered when there is a failure. For our success story, nobody recognizes us. That is taken for granted. So my submission is, sir, as Sharma Sahib has already said, that we will learn from the failures only. But unfortunately, failure is always camouflaged. I mean, true things never come out. I mean, when we go for investigation, it is very difficult to get the real reason of the failure. So now that NHI has got a lot of statistics for the failures, at least we do not want the name of the company, name of the organization, nothing. We want an IRC session for 2 hours at least, which should be disseminated. These case histories, let a committee decide which project's failure will be discussed. At least 2 hours duration should be there, so that youngsters and professionals like me, I mean, having not a very big exposure, at least I will get an opportunity to know what I want to do. At least the lessons from failure, that will not be repeated. Otherwise, these documents are being, cornered, and it is of no use, sir. So let that experience be disseminated. Thank you, sir.
Thank you, sir. Now I would request Mr. Nicholas for his concluding remark. Sir, 5 minutes, please.
Okay. So thank you, Mr. Chairman. So some remarks according what I listened to. Basically, if I can sum up in a couple of words, I can say quality control. Quality control. And what is quality control? Quality control is how each player of the bridge construction can know what is his own responsibility. Basically, it's a book saying that. And if I can sum up also what I learned in 3 letters, it could be DPN. D as design. Design, I learned a lot of issues about design. The design needs to be adapted to the temporary phases of the work, need also to be adapted to with the third part, safety, with the honor, all had to be included. P as preparation or planning. Does it mean that it takes time? It also needs to be included, I understood, the procurement process. And after the procurement process, to give time to the contractor to understood what he had to build with time and to appropriate the design. And N for no improvisation or never improvisation on site. Does it mean that, of course, if the design is good and the preparation is good, and theoretically, there is no reason for a lot of improvisation. But improvisation, we know that bridge is not full exact science. We are on site, and on site we have a lot of eventualities. And sometimes we all had this experience. We have month of design, month of preparation, and sometimes in 1 hour, one engineer alone decides something, and this is a catastrophe. Does it mean that no improvisation is how to increase maybe the number of people on the work of different parts, contractor, of course, but also maybe survey people, third part to lead. But also, what I listen a little bit, it's also how can we increase the skill of the people, how we need to train and to increase the skill of the people of the land. Bon, all this can be called quality control.
Thank you very much, sir. Now I would request Professor Mahesh Tandon, please, for his concluding remarks.
Yeah, good evening, friends. So, I know everybody is trying to go home quickly, but I think that it's important that this important panel discussion is brought to a logical conclusion. I will try to summarize what other people have said and what I have learned from many of the people who are involved with constructions and who had failures. The first thing is that the bridge is at its most vulnerable state during construction. And what are the reasons? It's an incomplete structure, and instability is invariably a problem because it's not complete. Like if you have a cantilever construction bridge, you've got 2 cantilevers, but really they are quite vulnerable as compared to what they would be once the bridge is completed. The other thing is the redundancy, which is so important in the structure, is invariably missing during construction stages. I think somebody mentioned, I think it was probably Pierre, that too much compression during in the incomplete stage of construction. I think that's the most valuable point, because we've had failures in where the section is developed in 2 stages, but all the pre-stressing has been put in the first stage, because that's the most convenient thing to do. So too much compression has also been a problem. Not only tensions and cracks and all that, but also this. In the design stage, in the construction stage, each construction stage requires a design and a design check. In one of the cases where we were discussing, and the very renowned engineer was there in one of the educational institutions, we asked him that, you know, during temporary stages this thing was not safe. So what has happened? He says that it was not my terms of reference to check the structure in construction stages. I can't check every stage. I can check the whole thing once it is completed. So I think even the terms of reference, whoever has appointed the design checker has to be carefully enumerated, so that these things don't come up where the person doesn't even feel. I mean, if you are making a, this was a extra dose bridge which is built in stages, and every stage you are putting pre-stressing, etc. He says that's not my responsibility. So that means that there is not even awareness as to what the design checker is supposed to do. The other places which has not been mentioned in this gathering is the amount of failures that we've had in the casting yard. In the casting yard, you are lifting a precast segment, you are stacking it, then you are transporting it. In all these stages, you can have a disaster. And of course, I have seen disasters in all the 3 stages. There is a method which has to be checked, all these sequences, and who should check that? Is it the design consultant who should check it, or there should be some other independent person who should check it? I think that is an open question, but the question is that it has to be checked. Also, I think it was probably Nicola who mentioned the interaction between various stakeholders. Like you have the designer, you have the contractor, you have the independent engineer, you have independent people for checking the design, seeing the site. All these people are working in silos. I think that's the word you used, Professor Sinha. We cannot work in silos in a project like this. Routinely, there should be, that's my suggestion. Routinely, there should be a meeting of all the stakeholders, and it should be chaired by the person who's finally will sort of be responsible, irrespective of who made the mistake business, but there is always one person who is finally responsible, and he is from the side of the owner. So that person should conduct these meetings. It may be once in 2 months, depending on what type of project we are doing. And that's where you should have a brainstorming session. the standard operating procedures of the next major activity that is going to take place at the construction site must be discussed. Everybody should have the standard operating procedures. It may be made by the contractor. Normally that is the rule or the norm or tradition in India. But that has to be discussed. And that has to be discussed when the designer is also present. The people at the site are present. They will tell you what the difficulties are of following a particular thing. So this working in silos, I think, is one of the reasons we are having a problem, because we are not talking to each other and understanding and getting ideas from the other person. Of course, this is all assuming that you have complete independency of people. That means that all the stakeholders have to be independent. There has to be no sort of conflict of interest coming anywhere. This I am assuming that that is the case before we even start off. And before you select anybody, like you take some of these metros, even if you are a consultant of the contractor, you have to declare whether you have a conflict of interest with anybody. And they are assessed by the owner, not by the contractor. And of course, what Mr. I think Hegde mentioned, which is quite right, that really speaking, all these independent people should be appointed by the owner, so that there is no chance of any conflict of interest. You never know, the people keep changing jobs, the situation keeps changing. So to avoid that, we should not have, these people should be appointed by the owner, and especially the design checker. That's where I find the most problems that are overlooked. Many of the things like, what to do about the construction stages and how the construction is visualized, that is the responsibility of the designer. He must give one scheme which is complete. That means that he must give how it is to be constructed. And that has to be checked. If after that it changes, that means the contractor wants to, in a design construct basis, for example, we have the design, the contractor always wants to change some things to save money or to economize, let us say. Well, that is a different issue. Then the process has to be repeated. But it's important to have this independent people, and all appointed by the owner, whatever the methodology you adopt. Okay, thank you, sir.
Thank you very much, sir, for very nice and very constructive remarks. We'll definitely follow it up. Now I would request co-chair for concluding remarks.
Yeah. Let me sum up the conclusions. So we are dealing with complex systems, maybe new systems. It was not considering all the construction situation, and mostly are things coming together. So when we are working on a new construction site, we are always dealing by the optimization of the triangle of quality, costs, and time. And I think it's coming clear out of this seminar that it's essential that we are looking onto the quality. And what we heard also today on the panel discussion is that we have to consider the human factor during our construction work. Good and deep knowledge can't be substituted by IT programs and or artificial intelligence maybe in future. So I think it's essential to keep ongoing training and keep your knowledge improved. So for the designing, I think we can keep an eye on robustness and the resilience. And in Germany, we are normally talking about failure-avoiding design. So I think this will be maybe future things to be considered, and improving the codes and share the knowledge on site is essential, but also sharing the knowledge worldwide. I think this is what we are here together and coming together and share our knowledge to improve our codes, to improve our deep knowledge. Yeah, thank you everybody, and I hope you are getting home with a deeper knowledge. Thank you.
Thank you, madam, for your remarks. I will just take 2 more minutes before you conclude this session. We might not have very good position with regards to bridges, its durability, its construction stage failure, whatever we discussed last 2 days. But looking at the attendance at such late hour, I have a belief that maybe our future is much more bright what our present has been. So whatever suggestions have been there, it has been recorded, and I have also remembered certain things. I can assure we'll deliberate upon this, and this is at the very opportune moment because we are going to revise our EPC document shortly. So I am hopeful, and I would request our ADG Ascender to put a little bit more efforts to that, and we'll be definitely able to bring certain things into contract documents, into some of the policy guidelines. So that's will be the starting point from our side to see that we don't have such kind of situations in failure. And the last, I would request, like this 2 days seminar, we are also going to organize a very good seminar by ING YAPSE in Dehradun in October 20th and 21st. So the people who are into design, construction, and maintenance of steel bridges, because that will be focusing on steel bridges only, I would request them to participate. Thank you. With that, I conclude this session, and this is the last session of the seminar. We have come to the concluding stage. Thank you all again for this patience and waiting for such late time.
I request all of you to kindly stay back. We'll have the felicitation first, and thereafter there will be one more presentation about Bangaluru Metro Rail project, and thereafter we'll have a wonderful musical program arranged for all of us by one of the most respected and popular singer, Sangeeta Katti. So I would request all of you to kindly stay back. I'll give you the details later. Now I would request the co-chair, Mrs. Jovan, to kindly felicitate our experts from India. Professor Ravi Sinha, I would request the professor to kindly come forward. Thank you very much. Shri V.N. Hegde, I would request Mr. Hegde to come forward. Mr. Hegde? He is left. Oh, Shri V.N. Hegde has left. Mr. R.K. Pandey? Yeah. He's also left. Yeah. Professor Mahesh Tandon. Has he left or is going to come back? They are not coming back. Okay, sir. Okay. Okay. I thought they might come back. So, Professor Mahesh Tandon. Thank you. I would now request Shri Dharmendra Sarangi to kindly felicitate first Mr. Joy Hartman. I think probably they must have gone to catch a flight. Okay. Mr. Joy Hartman, thank you, sir. Mr. Pierre Gilles from Belgium. Mr. Frederic Naud from France after Mr. Pierre. From France, thank you very much. And also to Mr. Nicholas Bardau. Thank you, Mr. Nicholas. I would now request Sri S.K. Nirmal, the SG of IRC, to kindly come over and felicitate both the chair as well as the co-chair. The chair is requested to stay back, please. Yeah. Mr. Nirmal will felicitate you first. Sri Dharmendra Sarangi. So, Mutual Admiration Society, this is. Thank you, sir, for chairing this session and giving us great insights on the panel discussion on bridges collapsing during construction and the lessons learned. I would also now request the co-chair, Mrs. Vion, to kindly come over. Yeah. From Germany, Conreben. I would request all the panelists to kindly come forward for a photograph. Yeah, all of us. For photograph, yeah. So stay back immediately after the photograph. As it is, the questions after this, the QR code will be displayed after this photograph because we would like to have the session at the backdrop, and our friends will put the QR code after that. No, okay. So immediately, since we are having, since all of you are very well versed with QR code, immediately after this, we'll have a presentation from BMRCL. Thank you very much. I think all of us should give a huge round of applause for the camera and the photographers, and also the people working there in the console. They have given wonderful sound. They are the unsung heroes. Thank you. I would now request Dr. M. Srinivas, the Chief Engineer of BMRCL, Mr. M. Suresh, Chief Engineer of BMRCL, to kindly come over here for a presentation. And immediately after the presentation, I have a few announcements to make. And thereafter, the musical journey will unfold. As we are all aware, music requires no language. It's just we have to have the taste to enjoy music, and Sangeeta Kotti, Madam will thrill us, will enthrall us with her melodious voice. She is one of the most respected, popular she has in India, and she has got several credits to her name, and also several awards and accolades have followed her. I'll give her more details about Sangeeta Kattiji afterwards, but right now, please put your hands together for the Chief Engineers of BMRCL, Dr. M. Srinivas and Shri M. Suresh.
Hello. Yes. Audible? Satmala. Good evening, delegates. I am Srinivas, Chief Engineer, Bangalore Metro Rail. Of course, it's already exhausted so much since morning. A very beautiful and very important sessions were held. Of course, just we'll give the insight of how the Bangalore Metro Rail functions, and I think most of the delegates will be coming tomorrow morning to our site to see actuals, and you can get lot of information after seeing that. Basically, you want to know the Bangalore, I think you might already experienced very traffic jams. The solution is only the mass rapid transport. So in this way, the government's thought and that started implementation of Bangalore Metro Rail project. So Bangalore Metro Rail project, the Bangalore Metro Rail Corporation was established in 2005. It is the joint venture between Government of India and Government of Karnataka in 50-50 ratio. Normally we call it as father as a Government of India and mother as a Government of Karnataka. Because the mother will take more of responsibilities. In the sense, we have to provide land, all other amenities. Of course, the Government of India will support us. So in that way, so this is a joint venture company established during 2005, and actually work started in 2007. Actually the phase 1 which is started north-south direction and east-west direction. And initially there was not much response, but now the peoples are very interested in metro. Nearly 8.5 lakhs passengers are traveling every day. That able to reduce some the traffic jams in the city. I think slides. So the phase 1 we got a 40.3 kilometers length, and phase 2 is 72.05, and phase 2A, 2B is 58 kilometers. Totally we have taken 175 kilometers, out of which already we have done 75 kilometers of metro. So the progress we have planned to complete the phase 2 project completely in 2025, and phase 2A, 2B, that is the airport line, which tomorrow you're going to inspect, visit the site. That is in June 2026. We got a lot of requests from the public, so there is a lot of projects in the pipeline. It is under investigation stage. Some of them are at DPR stage. Phase 3 is also approved. So total is 175 kilometers, and after completing this, nearly 15 lakhs people will travel every day. So this is one of our achievements. And Bangalore Metro, totally we have a long vision of doing, this in this sector, and Government of India is also supporting, and Government of Karnataka is also encouraging, and we are doing it. Now, the 2A, 2B, which tomorrow you want to visit, the detailed details of this project will be shared by our colleague, Mr. Suresh M.
Thank you, Dr. Srinivas. I'll continue from this presentation. Phase 2A, it is covering 19.75 kilometer, having 13 elevated stations connecting between Central Silk Road to Kiarpuram, and civil work has been awarded and started in the month of September 2021. And phase 2B is having 38.44 kilometer, having 17 elevated stations, and it is connecting from Kiarpuram to airport through Hebal. And civil work has been started from February 2022, and totally 58.119 kilometers. And project highlights, phase 2 and 2B has been approved by Government of India in the month of June 7th, 2021, and project cost is 14,788.1 crore, and loan agreement was signed with ADB for $500 million during August 2021, and JICA also has funded $300.82 million for the system works, and MOU for between BIAL and BMRCL has been signed for PPP for 800 crores. And commissioning schedule, phase 2A having 90.75 kilometer by commissioning by June 2026, and phase 2B by December 2026. And physical and financial progress, phase 2A is having 2 packages, and phase 2B is having 3 packages, and having 2 depots. So totally 7 packages are there. And physical progress, phase 2A is almost 70+%, and phase 2B, package 1 is 36, package 2 55%, and package 3 is 60%, and Bayapanalli depot 42%, and phase 2B, that airport depot, is around 50%. And innovations, we have adopted many innovations in phase 2B, phase 2A and phase 2B compared to phase 1 and phase 2. Mainly precast pier cap, concentric and eccentric type we have used. And the portal piers with precast beams in split flyover. And U-girders we have used. Pier arm in, precast pier arm in stations, and walkway provision we have made. And this is the concentric pier arm, and having U-girders. And this is with the cantilever type. Bangalore Metro, we are following maximum of 2 meters of eccentricity. And beyond 2 meter, we are going for the portal structures. And this is the typical section. And this is portal structure we have used in between the split flyover. This whole of outer ring road is covering 9 split flyovers. In between space available was only 8 meters. So initially it was with single pier, and if we had gone for single pier, we would have left with 2.6 or 2.7 meter on either side of the split flyover, which was of no use, because of that we have gone with the portal, so that we have created way for the in between way for the vehicular traffic. And this construction, these are the construction stages. Of course, a single pier is only having pile cap and pier, whereas this portal is having 7 stages. So these are the 7 stages of construction after pile cap, pier, and then in between precast portal beam, and then stitching, and again pier, and then portal, precast portal erection and stitch concrete. So these are the activities involved. Of course, it has taken much time, but it is worth it. So this is the completed structure. So in between, we have created the road. And this is U-girder. It is having 165 metric ton with a top width of 5.45 meter each, and total width 10.95 meters, and spacing is provided is 5.15 meter. This is the completed what we have seen pictures. And advantages was straight away there is a difference between phase 1 and phase 2. We have followed the left one with the box type segmental girders, and now phase 2A, 2B we are following with we are adopted this U girders. So with this 1.7 meters straight away where the rail level has been reduced. So thereby there is a cost saving. And because of this lateral web, it acts as a noise barrier and anti-derailment wall, and it acts as a walkway also and support for the system cables. And construction methods and time period. So U-girder versus U-girder and segmental girders, there's a lot of difference between the duration for the producing one 28-meter span. One U-girder will take 7 to 8 hours for casting, whereas segmental box girder will take 10 to 11 days. And in a week, we can erect up to 7 spans, say 196 meters of 28-meter standard spans, whereas segmental it takes, it will be around 2 spans only, say 56 meter. And time cycle for the casting to erection. For U-girder 15 days, whereas segmental it takes 30 days. Comparison of, when you compare U-girder with segmental girder, there is a lot of advantages. And the weight is, for U-girder it is, for double U-girder it is 330 metric ton. For segmental it is 412 metric ton. So straight away there is around 17-18% of dead load, decrease of dead load. And full pretension will be during casting, it has to be done. Whereas segment by segment, we are March casting and additional pre-stressing operation after erection it requires. And maximum up to 28 meter with U-girder we can go, we are doing, and 34 meter in case of segmental. And big trailers, of course, it requires for the U-girder. Small low bed trailers are required for the segmental. And cranes, we can erect U-girder with cranes and launching girder, whereas segmental is launching girder and ground support. Multiple front can be used in case of U-girders, whereas for segmental, always erection is to be in sequential order. So this is one time-saving aspect. And it can be erect in few hours, say 6 to 8 hours, U-girders. Whereas the segmental, it takes 4 days for the erection purpose, for one span. And parapet is inbuilt, whereas in case of segmental, it takes 3 to 4 days. And this is a typical section of station. Just skip. And cross section of a station, it is with single pier with cantilever pier arm, having secondary wing also, and then side entry exit structures connected with FOB. And this is a longitudinal section. And this is one precast station what we have gone for this station pier arm design with precast only, so that this unique method has been adopted just to save time, as well as the below road can be open for traffic. That means once pile cap, pier, and central pier head, and then second level pier, and then platform level pier head is constructed, we can keep open the road. So that is the, and then later on this launcher is erected. The picture it can be shown, seen. And so the segment is segment. It can be first level of platform will be erected first, and then second, this concourse level will be erected. So this is one innovative things we have adopted. And this is the cross section showing side platform with central tracks. And this is other type of, say, island platform. So platform will be a center, and tracks on either side of the structure. And these are the interfacing works, wherein traction, signaling, telecommunication, electrical and mechanical, AFC, rolling stock, lift and escalator, and station finishing works. So these are the number of items to be coordinated with for completion of the structure. And many operation rooms also we are providing for operation purpose, auxiliary substation, traction substation, signaling, telecom, equipment room, station control room, UPS battery room, ticket office, and excess fare office. So these are the operation rooms we are going to provide in a station. And walkway, one more, this one is walkway provision also we have made in the beginning itself, so that in between that is below the viaduct, connecting between station to station. So over the pile cap itself, walkway columns has been provided. And this is a typical walkway provision from station to station, and between the station to station and below viaduct. And this is the scheme with 3D views of walkway. And construction sequence. This is utilization plan where initially we get about 9 meter for, yeah. 9 meter, and then once pile cap and foundation is over, pier is over, so we are taking the barricade inside, so that we will keep open the road for traffic, so that minimum disturbance to the traffic. And these are some of the utility identification initially we conduct, and diversion will be made, and later on we'll go for pile. So these are the piling. I'll just skipping the items, piling. And test on piles, we conduct initial pile load for the on test piles. And later on, routine load test on the working pile also we conduct. That is vertical load test, lateral as well as dynamic. And non-destructive also we will conduct using this PIT as well as cross-hole sonic logging test also. So these are the pictures showing vertical load test with the reaction pile method, with the pile head, anchor head, as well as beams. Lateral load test we conduct. And for dynamic load test, these are the pictures. And pile integrity test also we conduct. Some of the procedure. So in case of any, the second picture shows major defect. So we'll go for next, it can be, it will, yeah. Pile cap, pier, crash barrier, I'm just skipping all the items. Concentric pier, pier cap, and then this is eccentric pier cap erection, pedestal bearing, And there are methods of erection of girders with cranes, U-girders with cranes. We are using cranes for the erection. And Goliath crane and launching girder. Yeah, balance. And tomorrow during visit we'll be explaining the other aspects of construction. This one at site itself. Thank you.
To conclude, I think there's only two items we have to tell for the benefits. The Bangalore Metro Rail, we got several very interesting structures. I think many of them traveled, that is in Majestic Station, which can accommodate 10,000 passengers time. And another one we are going to, which is going to inaugurate shortly, which is 5 levels structure, underpass, road level, flyover, then metro. Over that, one more metro will crossing. Such structures are very huge. Of course, we have no time to explain all those things. We have taken a lot of challenges for constructing this metro. Thank you.
I would request Dr. M. Srinivas and Suresh to kindly stay back and accept the felicitation from the organizing committee. Mr. Prakash and the team will felicitate you. Kindly go. Let's give a round of applause. In fact, it was a very exhaustive and comprehensive presentation. On our request, they have concluded it. I am very sure you'll have a lot of questions to ask them tomorrow. So we just requested them to conclude the presentation so that any doubts are there can be explained tomorrow. Let the music be less when I'm speaking, okay? Right. When I'm not speaking, you can increase the volume. Thank you. And now I would request Shri S.K. Nimal, SGIRC, to kindly come over and felicitate the team members of the local organizing committee. And I'm very sure I'm not going to request all of you to put your hands together and clap. It goes without saying because the local organizing committee has been toiling right in and day out. I would request first of all Mr. P.B. Prakash to kindly come over and receive a memento from Shri S.K. Nirmal.
I think before I start this last program of the day, let me first of all compliment the CPIO, Sri Patil, S.F. Patil and his team for the excellent arrangement made, for the, all the logistics which they have provided, hotels and everything. For last, I think, couple of months, they are seriously working hard to make this program a grand success. And today we have seen that, last 2 days we have seen the realization of all these hard work, how it has resulted into the fruits. So, and I had received excellent feedback from all the participants about the organization. So thank you very much to all the local organizers.
Mr. P.B. Prakash. Thank you very much, Mr. Prakash. Photographers, Ange, candid Tegiri, okay? Right. P.B. Prakash. After that, I would request Mr. Sunil Kumar, VC, AC of K-Ship, to kindly come over. Mr. Sunil. Yeah, you're there, yeah. Thank you. I would now request Mr. G.D. Kumar, EE of K-Ship, to kindly come over. Mr. Kumar, yeah. Somehow you forgot our duty. Yes, please put your hands together regularly, continuously. After that, I would request Mr. Satish Babu, AC of Building Circle. Mr. Satish Babu is not there? Okay, I'll go to the next one. Yeah, on behalf of Satish Babu, it's also being received now. After that, Ishwarappa, IC of SHDP, to come out quickly. Ishwarappnore ಎಲ್ಲಿದ್ದೀರಾ? ಬನ್ನಿ ಸ್ವಲ್ಪ ಓಡಿ ಸರ್. ಟೈಮ್ ಇಲ್ಲ. ಸಂಗೀತ ಕಟ್ಟಿಯವರ ಸಂಗೀತವನ್ನು ಕೇಳಬೇಕು ನಾವೆಲ್ಲ. ಯಾ. After Ishwarappa, I would request Mr. Keshav Prasad, AC of QAZ. Keshav Prasad. Yes, Mr. Keshav Prasad. Keshav Prasad, our Nantara, Mohan Kumar. I am calling out the name a little early because if you are far off the stage, you can come close to the stage. SC Vigilance, Government of Karnataka. Mr. Mohan Kumar. Yeah. Thank you very much, Mr. Mohan Kumar. After Mohan Kumar, we have Mr. Chandra Mohan, SC of WNH Designs. On behalf of Chandra Mohan, we have, that is being received now. After that, we have Madam Lalita B, AC of K-Ship. Lalita Madam ಅವರು ಹೊರಗೆ ಹೊರಡಕ್ಕೆ ಪ್ಲಾನ್ ಮಾಡಿದ್ರಿ ಅನ್ಸುತ್ತೆ, but you cannot plan like that because we'll have to wait and listen to the music of Sangeeta Kattiji. So I'm pretty sure you will be, all of you will stay back because music is the right tonic for all of us before we head back to our destinations. And after that, Mr. Subhash Naikwad, SC of KRDCL. It's being received on his behalf as he is busy with other work. Yeah. Yeah. Thank you very much. Thank you, Mr. Nirmal sir, for doing the honors. So before we head to the music program, please note that the site visit tomorrow morning will start at 10 a.m. from Lalit Ashok. So all of you are requested to be in Hotel Ashok by 9:45. However, if you are staying in some other hotels, you will be picked up at 8:30 a.m. And 120 numbers is what we are expecting. So one batch will have 40 each. The first batch will leave Lalit Ashok at around 10 a.m. And accordingly, as the numbers build up, the next shuttle will move on. And finally, we'll be back at 1 p.m. And at the end of the visit, you will be dropped back to Hotel Lalit Ashok.
I think regarding the first visit, because it starts at 10, and I think there are a lot of, we have all the foreign speakers and those who are going to, and having international flights. So we would like to accommodate in the first visit at 10 o'clock. So all of you, I mean our PR guests, they will be accommodated in the first lot, that is at 10 o'clock. So that you come back early and you can plan for your international flight visit. Yeah? So any other announcement for logistics tomorrow? Any other announcement? No, that is today. Any other announcement? Okay, in 10 minutes stage will be ready. So the cultural program will start in about 10 minutes time. Thank you.
Yeah, okay. वॉल्यूम देना था, वॉल्यूम वॉल्यूम चाहिए. Good evening, ladies and gentlemen, and welcome back. Well, the music maestro is here. Before she takes off, well, first of all, she needs no introduction. Let's give a round of applause for Sangeeta Kattikulkarni and the entire team. A very quick introduction. Well, ladies and gentlemen, her musical journey has been a captivating exploration of various genres, including Hindustani classical, light classical, bhajans, folk, and film music. Listen to me carefully. At the tender age of just 4, she had the privilege of receiving blessings from the legendary Sangeet Samrat Naushad Sahab of Indian cinema, which set her on the path to learn Hindustani classical music. She was hailed as a wonder in music by Naushad Sahab, and still you don't want to clap. Yes. I think the mic is gone. Hello? What happened to the mic, man? Just don't play with that, okay? Well, ladies and gentlemen, Srimati Sangeeta Kattikulkarni has released over 500 albums through renowned audio companies, That itself is a great achievement in its own accord. She has lent her melodious voice to the playback singing of around 500 films in Kannada and Tamil languages. She remains one of the most sought after artists in Indian music festivals and events, representing the country not just in India but abroad. So the result of all this is several awards and accolades have followed her. And each and every award, that's a huge list. I think it requires a concert, talking concert for me to list out the number of awards which she has won. She has about 4,000 solo concerts to her credit in India and abroad, and she has performed in most of the important musical festivals. And more importantly, she's a great human being. That's what matters most, and that's why the music becomes more sweeter, more soother, and she's been a source of inspiration, bringing about positive transformation in the lives of her students and also to the entire society. So without much ado, let's give a huge, huge, huge round of applause because the artists love the sound of the clapping. So it's all yours, Madam Sangeeta Katti Kulkarni. It's over to you.
ಗೆಜ್ಜೆ ಕಾಲ್ಗಳ ಧ್ವನಿಯ ತೋರುತ್ತಾ ಹೆಜ್ಜೆಯ ಮೇಲೊಂದು ಹೆಜ್ಜೆಯ ನಿಕ್ಕುತ ಗೆಜ್ಜೆ ಕಾಲ್ಗಳ ಸೇಮ್ ಬ್ಯಾಲೆನ್ಸ್ ಹಿಯರ್. ಚಿತ್ತದಿ ಹೊಳೆಯುವ ಪುತ್ಥಳಿ ಭಾಗ್ಯದ ಸೌಭಾಗ್ಯದ ಲಕ್ಷ್ಮೀ ಭಾಗ್ಯದ ಕರಿಯುಳ್ಳ ಅಳಗಿರಿರಂಗನ ಚೊಕ್ಕ ಪುರಂದರ ವಿಠಲನ ರಾಣಿ ಚೊಕ್ಕ ಪುರಂದರ ವಿಠಲನ ರಾಣಿ ಕರಿಯುಳ್ಳ ಅಳಗಿರಿರಂಗನ ಚೊಕ್ಕ ಪುರಂದರ ವಿಠಲನ ರಾಣಿ ವಿಠಲನ ರಾಣಿ 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 ಸೌಭಾಗ್ಯದ ಲಕ್ಷ್ಮೀ ಬಾರಮ್ಮ ನಮ್ಮಮ್ಮ ನೀ ಸೌಭಾಗ್ಯದ ಲಕ್ಷ್ಮೀ ಬಾರಮ್ಮ ನಮ್ಮಮ್ಮ ನೀ ಸೌಭಾಗ್ಯದ ಲಕ್ಷ್ಮೀ ಬಾರಮ್ಮ ಬಾರಮ್ಮ ಭಾಗ್ಯದ ಸೌಭಾಗ್ಯದ ಭಾಗ್ಯದ ಲಕ್ಷ್ಮೀ ಬಾರಮ್ಮ ಭಾಗ್ಯದ ಲಕ್ಷ್ಮೀ ಬಾರಮ್ಮ ಭಾಗ್ಯದ ಲಕ್ಷ್ಮೀ ಬಾರಮ್ಮ ನಮ್ಮಮ್ಮ ಬಾರಮ್ಮ ಲಕ್ಷ್ಮೀ ಬಾರಮ್ಮ ಬಾರಮ್ಮ Similarly, the parampara, the tradition of Bhakti Sangeet grew all over. It got evolved. संत दास श्रेष्ठ सभी ने भगवान के ऊपर अपने अपने मन लिखा. Sant Mirabai, she is considered to be one of the most prominent saints who evolved in the bhakti cult, in the devotional cult. Aaj tak, even till today, she is considered to be the epitome of bhakti. Lord Krishna, what was her deity, was everything to her. But this is a very rare composition when she writes on Rama, a very popular bhajan, a Ram bhajan written by Meera. Ram, 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 Ram. Oh Rama re, Rama re, Ram re. Ram, Ram re, how the tradition grew and it became a very common factor amongst the commoners. Then every commoner started thinking that I can also sing. I can also traverse through the beautiful path of bhakti and reach the level of trance or salvation. And music is the most easiest to me, the path to salvation. So we musicians are all blessed. From how many janmas we don't know. That this janma we are so blessed to be musicians. Moreover, to be the musicians who are performing before people like you. And thank you so much. You become Prata Smaraniya. Thank you so much. So the bhakti grew all over this country, all over the world, in its own dialect and own languages. Let us now come to Maharashtra, where Marathi tradition of bhakti grew very big. The tradition which is named as Varkari Sampradaya, there the deity is Vithala, Vithala, Vithala. So Vithoba, the Pandharapura Vithoba becomes, right, because of the God, all incarnated. So let us chant a Vithala number in the Bhakti type. Then after this, let's move on to the folk and light music and ghazals. So Vithala, one Marathi Abhang. I'm sure there will be Marathi speaking people here. Because in the evening when I came, I heard a few people speaking Marathi, so I thought, yeah, Marathi एक अभंग. आता तुमच्या समोर एक अभंग ची प्रस्तुती आहे. And ಸ್ವಲ್ಪ ಎಲ್ಲ ಕರೆಕ್ಟಾಗಿ ನನಗೆ ಈ ಕೀಬೋರ್ಡ್ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ. ಅವ್ರೇನು ನುಡಿಸ್ತಾರೆ ಅಂತ यहाँ पे keyboards big, E monitor, this particular one. Here is the man who is responsible for my musical career, my dad, Dr. Chekati. I'm so happy that all the way from Dharwad, my hometown, he is here today. He is a scientist at university from Karnataka University. He did his research on Indole series, and I'm so happy to have Daddy here today. Thank you so much. जीव भाव जीव भाव जीव भाव जीव भाव जीव भाव जीव भाव बोलावा विठ्ठल पाहावा विठ्ठल बोलावा विठ्ठल पाहावा विठ्ठल बोलावा विठ्ठल पाहावा विठ्ठल करावा विठ्ठल जीव भाव बोलावा विठ्ठल पाहावा विठ्ठल बोलावा विठ्ठल पाहावा विठ्ठल करावा विठ्ठल जीव भाव येणे सोसे मन बोलावा विठ्ठल पाहावा बोलावा विठ्ठल पाहावा पाहावा बोलावा विठ्ठल पाहावा विठ्ठल बोलावा विठ्ठल पाहावा विठ्ठल करावा विठ्ठल जीव भाव येणे सोसे मन झाले हाव भरी येणे सोसे मन झाले हाव भरी झाले हाव भरी परतवा घारी येत नाही परतवा घारी येत नाही बोलावा विठ्ठल पाहावा विठ्ठल करावा विठ्ठल जीव भाव बंधनापासून मुखदली गाठी बंधनापासून 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 मुखदली गाठी देतानी मिठी सारे गावात देतानी मिठी गणी सारा देतानी मिठी सावकाश 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 बोलावा विठ्ठल पाहावा विठ्ठल बोलावा विठ्ठल पाहावा विठ्ठल करावा विठ्ठल जीव भाव तुका म्हणे देह भरिला विठ्ठल तुका म्हणे देह तुका 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 म्हणे तुका म्हणे तुका म्हणे देह करे जाणे राणी जाणे राणी सारे जाणे राणी जा गाणी रे जा सारे गाणी गाणे जा गाणी रे सा तुका म्हणे मला रे सा रे सा नि जा रे सा रे ध नि रे सा तुका म्हणे re ga ma ga re sa re ga ma ga re sa re ga re sa ni da ni sa re ga tu kamani de da ni sa re ga da ni sa re ga ma ga re ga da ma ga re sa da ni re ga re sa da ni ga re sa tu kamani de ha bhari na vittal tu kamani de ha bhari na vittal tu kamani de ha bhari na vittal tu kamani bhari na vittal tu kamani de ha bhari na vittal काम क्रोध की हृदय कर काम क्रोध के हृदय घर धर धर बोलावा विठ्ठल पाहावा विठ्ठल करावा विठ्ठल जीव भाव बोलावा विठ्ठल पाहावा विठ्ठल करावा विठ्ठल जीव भाव विठ्ठल 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 even till today, the tradition goes on there in Pandrapura. From nowhere people come, we don't know where they originate from and where their origin is. They come with all those percussions. They keep chanting Vithala, Vithala, and just walk through the pilgrimage. Till today we will find this. Yes? Coming to the next genre of music, that is light music. There's a ghazal parampara. One beautiful ghazal before you now. Kaustav Songman. Going back to Amir Khusro days, Khusro Sahab ne, Mirza Ghalib ne, काफी तर्ज़े tradition of ghazals grew so big, and one of the prominent exponents, Maestro, the ghazal maestro, the king of ghazals, the ghazal maestro, जिनको हम जगजीत सिंह साहब के नाम पे जानते हैं, उनका बहुत ही मशहूर गीत है ये, हालांकि फिल्म प्रेम गीत में भी लिया गया। ये गजल आपके सामने पेश खिदमत है। Kaustav Songman is going to present होठों से छू लो तो मेरा गीत अमर कर दो।
होठों से छू लो तुम मेरा गीत अमर कर दो, होठों से छू लो तुम मेरा गीत अमर कर दो, बन जाओ मीत मेरे मेरी प्रीत अमर कर दो, होठों से छू लो मेरा गीत अमर कर दो। ना उम्र की सीमा हो, ना जन्म का हो बंधन, ना उम्र की सीमा हो, ना जन्म का हो बंधन, जब प्यार करे कोई तो देखे केवल मन, नई रीत चला कर तुम ये रीत अमर कर दो, नई रीत चला कर तुम ये रीत अमर कर दो, होठों से छू लो तुम, मेरा गीत अमर कर दो। आकाश का सूनापन मेरे तन्हा मन में, आकाश का सूनापन मेरे तन्हा मन में, पायल छनकाती तुम, आ जाओ जीवन में, सांसें देकर अपनी संगीत अमर कर दो, संगीत अमर कर दो, मेरा गीत अमर कर दो। जग ने छीना मुझसे मुझे जो भी लगा प्यारा, जग ने छीना मुझसे मुझे जो भी लगा प्यारा, सब जीता किए मुझसे, मैं हर दम ही हारा, तुम हार के दिल अपना मेरी जीत अमर कर दो, तुम हार के दिल अपना मेरी जीत अमर कर दो, होठों से छू लो तुम, मेरा गीत अमर कर दो, बन जाओ मीत मेरे, मेरी प्रीत अमर कर दो, होठों से छू लो तुम, मेरा गीत अमर कर दो।
वाह 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 वाह, बहुत खूब। First, thank you so much for presenting this evergreen ghazal. Well, ಘಜಲ್ ಅಂದರೆ ಕನ್ನಡ ಸಾಹಿತ್ಯದಲ್ಲಿ ಭಾವಗೀತ್. ಇವನ್ ಇನ್ ಮರಾಠಿ ಇಟ್ ವಾಸ್ ಭಾವಗೀತ್. ಕನ್ನಡ ಸಾಹಿತ್ಯದಲ್ಲಿ ಸುಗಮ ಸಂಗೀತ ಅಂತಕ್ಕಂಥ ಒಂದು ದೊಡ್ಡ ಚಾಪ್ಟರ್ ಓಪನ್ ಆಯಿತು. ದೇರ್ ವಾಸ್ ಅ ಬಿಗ್ ಹೊರೈಸನ್ ಇನ್ ಕನ್ನಡ ಲಿಟ್ರೇಚರ್ ವೇರ್ ದೆ ಸೆಟ್ ಸುಗಮ ಸಂಗೀತ್ ಅಂಡ್ ಮೆನಿ ಪೋಯಿಟ್ಸ್, ವರಕವಿ ದತ್ತಾತ್ರೇಯ ರಾಮಚಂದ್ರ ಬೇಂದ್ರೆ, ಕುವೆಂಪು, ಕೆ ಎಸ್ ನರಸಿಂಹಸ್ವಾಮಿ ಒಬ್ಬರೇ ಇಬ್ಬರೇ. ಈಗ ಬೇಂದ್ರೆ ಅಜ್ಜನವನ್ನು ಕವನ ಭಾವಗೀತೆಯ ಪರಂಪರೆಯಲ್ಲಿ, ಸುಗಮ ಸಂಗೀತದ ಪರಂಪರೆಯಲ್ಲಿ. ಐ ಆಮ್ ಶ್ಯೂರ್ ಪೀಪಲ್ ವಿಲ್ ಎಂಜಾಯ್. ದತ್ತಾತ್ರೇಯ ರಾಮಚಂದ್ರ ಬೇಂದ್ರೆ, who had an initial DR, who told the people that my mom has given me doctorate ever since I was born. So no doctorates matter to me. This was the poet. As a salute to this greatest of great poets, Dara Bendre. This is for Kannada literature, Kannada literary excellence. ದನಕರದ ಕಾಲಿನ ಧೂಳಿ ಸಂಜೆಯ ಮುಗಿಲ ಮುಟ್ಟೇದ ಮುಗಿಲ ಮುಟ್ಟೇದ ಮುಗಿಲ ದನ್ನ ಕರದ ಕಾಲಿನ ಧೂಳಿ ಸಂಜೆಯ ಹೋಳಿ ಮುಗಿಲ ಮುಟ್ಟೇದ ಮುಗಿಲ ಮುಟ್ಟೇದ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ತನ್ನ ಕರದ ಕಾಲಿನ ಧೂಳಿ ಸಂಜೆಯ ಧೂಳಿ ಮುಗಿಲ ಮುಟ್ಟೇದ ಮುಗಿಲ ಮುಟ್ಟೇದ ಓ, ಓ, ಬೆಳದಿಂಗಳ ನೋಡ ಮದುಮಗಳ ಕಣ್ಣಿನ ಬಗಿ ಮದುಮಗಳ ಕಣ್ಣಿನ ಬಗಿ ಚಂದಿರನ ನಗಿ ಸುತ್ತ ಹರದಾದ ಸುತ್ತ ಹರದಾದ ಬೆಳದಿಂಗಳ ನೋಡ ಶಾವಂತಿ ಹೂವಿನ ಕಂಪು ಶಾವಂತಿ ಹೂವಿನ ಕಂಪು ಶಾವಂತಿ ಶಾವಂತಿ ಹೂವಿನ ಕಂಪು 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 ಶಾವಂತಿ ಹೂವಿನ ಕಂಪು ಇಡಿಗಿಸಿತು ತಂಪು ಇಡಿಗಿಸಿತು ತಂಪು ಇದು ಸಾಕ ಬೇರೆ ಏನು ಬ್ಯಾಡ ಇದು ಸಾಕ ಬೇರೆ ಏನು ಬ್ಯಾಡ ಬೆಳದಿಂಗಳ ನೋಡ ಸವಿರಾಗ ಬೆರೆಸಿದ ಉಸಿರ ಇದಕಯ ಹೆಸರ ಇದಕಯ ಹೆಸರ ಸವಿರಾಗ ಬೆರೆಸಿದ ಉಸಿರ ಇದಕಯ ಹೆಸರ ಇದಕಯ ಹೆಸರ ಅಂಬಿಕಾ ತನಯನ ಹಾಡ He was popularly known as Ambika Tanayadatta. Ambika Tanayana Hada Ambika Tanayana Hada Tanayana Hada Tanayana Hada Danakaradda Kalina Dhuli Danakaradda Kalina Dhuli Sanjiya Huli Mugila Mutteda Mugila Mutteda ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ ನೋಡ ನನ್ನ ಕರದ ಕಾಲಿನ ಧೂಳಿ ನನ್ನ ಕರದ ಕಾಲಿನ ಧೂಳಿ ನನ್ನ ಕರದ ಕಾಲಿನ ಧೂಳಿ ಸಂಜೆಯ ಹೂಳಿ ಮುಗಿಲ ಮುಟ್ಟೆದ ಮುಗಿಲ ಮುಟ್ಟೆದ ಬೆಳದಿಂಗಳ ನೋಡ ಬೆಳದಿಂಗಳ बेड़दिंगल का मतलब होता है full moon, पूनम की चांद. So the poet writes, sitting in a full moon day, on a full moon day, when he was newly married, and when the ritualistic family, they didn't send his wife for an evening walk. So he imagined his wife to be sitting next to him, and in Shaniwarwada in Pune, he penned this lyrics. I think he was a 24-year-old when he wrote this. So a big salute to Dattatreya Ramchandra Bendre, Nama Bendre Ajjanige Jayavani. There are many songs for I think when I was sitting there outside having my coffee, many people came to me and they said they just love my song written by Bendre, Mugila Marige Ragarade. So there are many songs in the list. I'll try to hum 2 lines for them especially for the fans who requested these two lines.
ನೆಲದಂಚಿಗೆ ಮಂಜಿನ ಮುಸುಕು ಹೆಂಗೋ ಬಿದ್ದಿತ ಗಾಳಿಗೆ ಮೇಲಕ್ಕೆದ್ದಿತ್ತ ಗಾಳಿಗೆ ಮೇಲಕ್ಕೆದ್ದಿತ್ತ ಮುಗಿಲ ಮಾರಿಗೆ ರಾಗರತೆಯ ನಂಜ ಏರಿತ್ತ ಆಗ ಸಂಜೆ ಆಗಿತ್ತ ಸಂಜೆ ಮುಗಿಲ ಮಾರಿಗೆ ರಾಗರತಿಯ ಮುಗಿಲ ಮಾರಿಗೆ ರಾಗರತಿಯ ನಂಜೇರಿತ್ತ ಆಗ ಸಂಜೆ ಆಗಿತ್ತ ಆಗ ಸಂಜೆ ಆಗಿತ್ತ ಮುಗಿಲ ಮಾರಿಗೆ ರಾಗರತಿಯ ನಂಜೇರಿತ್ತ ಆಗ ಸಂಜೆ ಆಗಿತ್ತ ಆಗ ಸಂಜೆ ಆಗಿತ್ತ ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ಮಗರಿ ಸರಿಗಮರಿ ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ಗರಿ ಮಗರಿ ಮಗ ಮದ ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ನೀರಿಗೆ ಹೋಗಿದ್ದ ನೀರಿಗೆ ಹೋಗಿದ್ದ ಓ ಬೊಗಸಿ ಗಂಡಿನ ಬಯಕೆಯ ಹೆಣ್ಣು ನೀರಿಗೆ ಹೋಗಿದ್ದ
we always love to sing this. I think I was around, this was recorded in at least 25 years back when I was still in college. I mean, these are nostalgic memories, and I salute the composer, C. Ashwath, the one and only C. Ashwath, who is the doyen of music, जैसे कहा जाता है यहाँ पे. He was another phenomenal person. So, Darabendra and C. Ashwath, the great combination. Thank you so much for being very patient to listen this nostalgic Kannada literary excellence, with literary excellence, this number. बहुत सारे गजल्स हैं जो भी याद आते हैं वो गुनगुनाती हूँ मैं. I don't know how much, what is the time given to me because it started late. दादरा is one, एक प्रकार है दादरा, तो that also falls under light classical music, light music. Our Indian classical music is so rich that it takes different forms, but the love, the bhav, the feel, and the establishment, the treatment, and the anubhav, that is the experience, remains the same, no matter whatever language it is written or composed in, whatever raga.
रंगी सारी उमरे यारे है, रंगी सारी मोर गुलाबी चुनरिया रे, रंगी सारी उमोरी चुनरिया रे, रंगी सारी उमोरी चुनरिया रे, मोहि मारे नजरिया सावरिया रे, मोहि मारे नजरिया सावरिया रे, मोहि मारे नजरिया सावरिया, रंगी सारी उमोरी चुनरिया रे, रंगी सारी उमोरी चुनरिया रे, कहीं मारे नजरिया सावरिया, कहीं मारे नजरिया सावरिया रे, कहीं मारे नजरिया सावरिया. जाओ जी जाओ, जाओ जी जाओ, करो ना बतिया रे, जाओ जी जाओ, जाओ जी जाओ, करो ना बतिया रे, जाओ जी जाओ, करो ना बतिया रे, जाओ जी जाओ. जाओ जी जाओ, जाओ जी जाओ, जाओ जी जाओ, करो ना बतिया रे, ए जी बाली, ए जी बाली, ए जी बाली, ए जी बाली, हो जी बाली, ए जी बाली, हो जी बाली, हो मोरी उमरिया रे, ए जी बाली, हो मोरी उमरिया रे, कहीं मारे नजरिया सावरिया रे, मोहे मारे नजरिया सावरिया, रंगी सारी उमोरी चुनरिया रे, रंगी सारी उमोरी चुनरिया रे, कहीं मारे नजरिया सावरिया, कहीं मारे नजरिया
I hope all of you are enjoying this Sugama Sangeet of Karnataka. This is light music, vocal. Friends, really 2 days program of international seminar is a contribution of a lot of souls, lot of friends, lot of departmental officers. Apart from that, hoteliers, our consultants, concessionaires, and a lot of people are behind this 2 days event. I should thank each and every one of them. So, of course, it is too late, but very few delegates are here from India and abroad. Friends, all the team which has worked since 3 months continuously. Of course, we planned it in the month of February, March to proceed with this September 2 days event, international seminar in Bangalore. PR chair Nicholas, we interacted 2-3 times on virtually, but after hearing to them, of course, the personality behind this event is IRC Secretary General Sanjay Kumar Nirmal Saab. With his advice, we started, and our Honorable PWD Mr. Satish Jarkiwadi Saab was kind enough to say yes to this event, and he directed all the officials to see that the event gets a good completion, successful completion, and all the delegates should be treated as a state guest, and they should be, like abroad, foreign delegates also treated like a state guest, and even delegates from India, across the India, should be treated in best practices which has been practiced in IRC events. Every year we have a IRC session also. So on those lines, all the team, I should thank all from SC to all C, from C to assistant engineers, juniors, all have contributed there immensely for this 2 days event. I thank one and all, and also thank IRC team headed by Secretary General Nirmal Kumar Saab for giving us the opportunity to be here and to host this event. Now I come back to this evening cultural program. Really, India has got a beautiful culture, civilization also. We have got 10,000 years of history, but it is not properly showcased, it is told, but across the globe, everybody is understanding the importance of India and the importance of Indian peace and peace and civilization and peace and culture, what we have practiced in the past. Of course, there were some aberrations, but even then we could have, we have a beautiful culture. So that is shown through so many musical forms. Yesterday we heard around, one of the speaker was telling around 126 dance forms are there in India. So that is one part. Second part, there is, music to enjoy the life. Apart from working, we have to have some cultures, such Sangeet Karyakram, that light music. Really, I should thank Sangeeta Katti and her team. They are giving us a beautiful feast of music. Really, I am personally enjoying that. I should thank Karnataka Sangeeta Nritya Academy President Shubha Dhananjay for having her here in this evening. So I wish them all the best in their future. They are the best artists, best performers. I have not seen. Of course, I have heard of them, but live seeing them is different, and seeing through video, TV is different. Now I am seeing live. It is a really happy moment for me. I thank all her team, and I thank all the IRC team for Sanjay Kumar Nirmal Saab is here only. I really thank him taking this event in Bangalore. I thank you, sir. Thank you, one and all. I thank more people also. I thank PR delegates, PR members. Really, they gave us opportunity to show our, departmental strength to how we'll manage. This is one of this kind. I thank all the departmental officers as well as the Ministry of Roads and Transport officers, IRC members, PR members. Thank you one and all. I wish the Sangeeta Katti should perform continuously till what she decides. I don't want to give a time. It is her time. When she will stop, we'll enjoy. Till then, we'll enjoy. Thank you. Please proceed. Thank you.
Thank you, sir. Thank you so much. It's such an honor and pleasure. Well, music goes on and on and on. There is no adi, there is no anta for music. And when it comes to classical music, the ragas and ragini paddhati go on. But since we have taken a subject here called parampara, how the different styles of music got evolved in our country, especially since we are dealing with Indian music. So let us continue with this ghazal, ya sugam, ya bhav sangeet parampara, with one of the most popular ghazals by Farida Khanum, आज जाने की जिद ना करूं. तो बहुत ही खूबसूरत गज़ल है. हालांकि गज़ल की परंपरा जो है वहाँ पे एक नाम हो तो बताएं. It started with, as I said, Amir Khusro Sahab, Mirza Ghalib, and the voices were Mehdi Hasan Sahab, Begum Akhtar, Jagjit Singh, as he presented one nostalgic number of Jagjit Singh, Ghulam Ali Sahab. काफ़ी ऐसे फनकार यहाँ पे गज़ल की परंपरा बरकरार बाकायदा निभाया और बरकरार रखा. उनमें से एक खूबसूरत फूल जैसी आवाज़ थी उनकी, फरीदा खानम, और बहुत ही खूबसूरत तर्ज बनाए उन्होंने. और आज भी आई थिंक दिस इज़ ऑल टाइम फेवरेट्स ऑफ ऑल गज़ल लवर्स. सो गज़ल की परंपरा हम इस गज़ल के साथ समाप्त करते हैं. नेक्स्ट विल मूव टू द फोक जॉनर एंड देन फिल्म एंड विल एंड फॉर टुडेज इवनिंग.
रहो आज जाने की जिद ना करो आज जाने की जिद ना करो हाय मर जाएंगे हम तो लुट जाएंगे हाय मर जाएंगे हम तो लुट जाएंगे ऐसी बातें किया ना करो है आज जाने की जिद ना करो आज जाने की जिद ना करो तुम ही सोचो जरा क्यों न रोके तुम्हें तुम ही सोचो जरा क्यों न रोके तुम्हें जान जाती है जब उठ के जाते हो तुम तुम ही सोचो जरा क्यों न रोके तुम्हें जान जाती है जब उठ के जाते हो तुमको अपनी कसम जान जा बात इतनी मेरी मान लो बात इतनी मेरी मान लो आज जाने की जिद ना करो है आज जाने की जिद ना करो यूं ही पहलू में बैठे रहो यूं ही पहलू में बैठे रहो हाय मर जाएंगे हम तो लुट जाएंगे हाय मर जाएंगे हम तो लुट जाएंगे ऐसी बातें किया ना करो ना करो बातें किया ना करो आज जाने की आज जाने की आज जाने की जिद ना करो
Thank you so much. One style which is called an eternal style. ऐसे कहा जा सकता है कि इसका अता पता कुछ है नहीं. अता पता का मतलब ये है nobody knows where it originates from and where it reaches. So it is as good as the true music, the nativity, that is the lok sangeet, ya fir folk music. So let us come to the genre of folk music now for this beautiful evening, gentlemen, ladies and gentlemen. Folk music, it is so dear and near to our hearts. Anybody, everybody can sing. So you're most welcome to sing with me. Please join. Please bless us. Please bless the stage with your unique voices with us. If you know the song, or let me repeat it for you. First and foremost, let us go to Maharashtra, where the Lavani is the most popular form of folk music. रेशमाच्या रेखाने लाल काळ धाग्याने रेशमाच्या रेखाने लाल काळ धाग्याने कर्नाटकी कशीदा मी काढीला हात नका लावू माझ्या साडीला कर्नाटकी कशीदा मी काढीला हात नका लावू माझ्या साडीला रेशमाच्या रेखाने लाल काळ धाग्याने रेशमाच्या रेखाने लाल काळ धाग्याने कर्नाटकी कशीदा मी काढेला हात नका लावू माझ्या साडीला नवी कोरी साडी लाख मोलाची भरली मी लक्षी फुल येलाची नवी कोरी साडी लाख मोलाची भरली मी लक्षी फुल येलाची 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 गो येलाची गुफियेन रागो मोर राग मोर जोडीला गुफियेन रागो मोर राग मोर जोडीला कर्नाटकी कशीदा मी काढीला हात नका लावू माझ्या साडी कर्नाटकी कशीदा मी काढीला हात नका लावू माझ्या साडीला रेशमाच्या रेखाने लाल काळ धाग्याने रेशमाच्या रेखाने लाल काळ धाग्याने कर्नाटकी कशीदा मी काढीला हात नका लावू हात नका लावू हात नका लावू माझ्या साडीला माझ्या साडीला माझ्या साडीला माझ्या साडीला Thank you. This is the style which is persistent even today. The most prominent form of folk music in Maharashtra. And now, ईस्ट की तरफ जाएंगे हम, वेस्ट बंगाल से। यही लोक संगीत कैसे बदलता है? बदलता तो नहीं है, दिल तो वही है, सुर तो वही है, सिर्फ बोली अलग है। I would request Kaustav Songman to present a very nostalgic number by Hemanda and Lata Di. इस गाने के बारे में मैं बाद में बताऊंगी, पहले वो गाएंगे। मैं सिर्फ मुखड़ा गाऊंगी। जी जी वही। You should sing with us. You would know this song.
वल्लौरे नखवा हो वल्लौरे रामा वल्लौरे नखवा हो वल्लौरे रामा वल्लौरे नखवा हो वल्लौरे रामा Rama Vallore Nakwa ho Vallore Rama Mi dolkar darya saraza Mi dolkar darya saraza Kar paanyavari bandrala yena Mi dolkar darya saraza Vallore Nakwa ho Vallore Vallore Nakwa ho Vallore Rama আর কাইন্দো না তুমি সজনী হবে আরো আঁধার আমার জীবন রজনী আর কাইন্দো না তুমি সজনী হবে আরো আঁধার আমার জীবন রজনী তুমি হাসো যদি আকাশে চাঁদিনী হাসে যদি আকাশে চাঁদিনী হাসে কত চেয়ে থাকো তাই ভরসা বুকেতে আসে খর ধারায় জীবন নদী পাল ছেড়ে ভাঙে হাল যদি খর ধারায় জীবন নদী পাল ছেড়ে ভাঙে হাল যদি শুধু প্রেমেরই পাল তুলিয়া পারে চলে যাব দুজনে কুজনে হাইসা পারে চলে যাব দুজনে কুজনে হাইসা দোল 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 দোल দোल
डोलकर दर्याचा राजा तर पाण्यावरी बंदराला करतो इजा
দোল দোল পাল তোল চল ভাসি সব কিছু তাইকা দে দোল 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 পাল তোল চল ভাসি সব কিছু তাইকা আল্লাহর হজুর হে আল্লাহ হে রামা হে ওরে মার জোর হে আল্লাহ হে রামা হে মার জোর হে আল্লাহ হে রামা Vallore Nakwa ho Vallore Rama
So this song was composed by Hridaynath Mangeshkar ji and sung by none other than sung by Hemant Kumar and Lata Mangeshkar, both in Bengali and as well as Marathi. So this became very popular. This was a fisherman folk. ಇದಕ್ಕೆ ಮೀನು ಬೆಸ್ತರ ಹಾಡು ಅಂತ ಹೇಳ್ತಾ ಇದ್ರು. So similarly, many folk numbers are sung and they are chanted and they are dedicated to their deities wherever whoever sings it. It is for their, चाहे वो गांव हो, चाहे वो शहर हो, चाहे वो बड़ा सा स्टेट हो, कहीं भी हो. So they dedicate their numbers to none other than God. One such number, which I think when it got originated, I really don't know. I'll just sing the song for you. And time ಎಷ್ಟಿದೆ sir? Okay. ಕರೆಕ್ಟ್ ಜನಪದ ಸಂಗೀತ. ಓಕೆ, ನಮ್ಮ ಚೌಡ್ಕಿ ಪದ ಸೌದತ್ತಿ ಎಲ್ಲ ಮುಂದೆ ಹಾಡಂದು ಹಾಡ್ತೀನಿ. ಓಕೆ, would he remembered one more prominent style in our state Karnataka, where we go to the northern part of Karnataka, that is Dharwad district, Saundatti, the goddess Yellamma. There is a typical style where the bhaktas sing this song as a folk number. ಎಲ್ಲಿ ಕಾಣೆನೋ ಶಿವನೊಲ್ಲಭೆ ಎನಿಸಿದೆ ಉಧಾ 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 ಉಧಾ. This is the percussion which is played there, and this is the authentic style which is performed with this song. उधा 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 उधा. क्या बात है. ಕಲ್ಲಿನೊಳಗೆ ಪುಟ್ಟಿ ಕಲ್ಲಿನೊಳಗೆ ಹುಟ್ಟಿ ಉಗರಗೊಳಕ ಹಿಡಿದಿ ಎಲ್ಲಿ ಕಾಣೆ ಎಲ್ಲಿ ಕಾಣೆ ಎಲ್ಲಿ ಕಾಣೆ ಎಲ್ಲಿ ಕಾಣೆ ಎಲ್ಲಿ ಕಾಣೆ ಎಲ್ಲಮ್ಮ ನಿನ್ನಂತ ಹಾಕಿನಲ್ಲಿ ಕಾಣೆ ನಿನ್ನಂತ ಹಾಕಿನಲ್ಲಿ ಕಾಣೆ ಎಲ್ಲಿ ಎಲ್ಲಾರು ಬರ್ರಿ ಎಲ್ಲ ಮರ ಪಾದಕ್ಕೆ ಬಿದ್ದು ನಾಲ್ಕು ಓದೋ 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 ಅಂತ ಹಾಡೋಣ. ಉದಾ 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 ಉದಾ. ಎಲ್ಲಿ ಕಾಣೆ ಓ ಎಲ್ಲಿ ಕಾಣೆ ಎಲ್ಲಿ ಕಾಣೆಲ್ಲಿ ಕಾಣಿನ ಎಲ್ಲಪ್ಪ ನಂತಕ್ಕೆ ನೆಲ್ಲಿ ಕಾಣೆಲ್ಲಿ ಕಾಣಿನ ಓ ಎಲ್ಲಿ ಕಾಣೆಲ್ಲಿ ಕಾಣಿನ ಎಲ್ಲಮ್ಮ ನಂತಕ್ಕೆ ನೆಲ್ಲಿ ಕಾಣೆಲ್ಲಿ ಕಾಣಿನ ಎಲ್ಲಿ ಕಾಣೆನು ಶಿವನೊಲ್ಲಭೆ ಎನಿಸಿದೆ ಎಲ್ಲಿ ಕಾಣೆನು ಶಿವ ಎಲ್ಲಿ ಕಾಣೆನು ಶಿವನೊಲ್ಲಭೆ ಎನಿಸಿದೆ ಕಲ್ಲಿನೊಳಗೆ ಹುಟ್ಟಿಯುಗರ ಕೊಳ್ಳಕ್ಕ ಹಿಡಿದಿ ಎಲ್ಲಿ ಕಾಣೆಲ್ಲಿ ಕಾಣಿನ ಎಲ್ಲಮ್ಮ ನಂತಕ್ಕೆ ನೆಲ್ಲಿ ಕಾಣೆಲ್ಲಿ ಕಾಣಿನ.